Okay, let's see if everybody can hear me. I'm moving over to I'm taking a look on the YouTube side of things. Ah, yes! Okay, let me just make sure that hearing is a thing that's happening. Okay, can you guys hear me? Oh, yes, sweet! Okay, this is the first time that I've done this since only longtime Gutsick Gibbon fans will remember this. But for a while, I was gaming. I was game streaming on this channel. It was Ancestors, the Human Journey or Human Odyssey or something like that. It was actually a very fun game. But that was when I did like regular streams. So you got like a wide view of the room. You can see one of my dogs down here. Yeah, thanks for being here. I'm gonna be in and out here as I continue to like set things up. I'm pulling up a rebuttal PowerPoint for the rebuttal section of this debate. This debate is actually starting at 7, and the way that this is going to work is I'm going to be broadcasting the StreamYards through OBS, which I've never done before. So we're gonna make sure it works. But in the meantime, I hope you guys will like hang out and chat and make sure that you like are telling your friends and stuff and getting so excited for this debate. You know, we're going to be finally settling it once and for all. Like, does the hominin fossil record support human evolution? It does. You're not going to believe it. I'm excited, though, to go through it with you guys. I've got a good intro, I think. I've watched copious amounts of Dr. Jerry Bergman content, so I think I know what he's going to say. But we'll see. I'm sure you can hear my dogs fighting in the background. So what I'm going to do here is double check that everything is still working the way that it's supposed to work. Okay, cool. Excellent. People are here and this is working. Yeah, credit to Dapper Dinosaur is the one who taught me how to do this in the first place many moons ago. Friend of the channel. I'm actually seeing a lot of friends of the channel in the comments. I'm happy to see it. Hold on just a sec. Hey guys. Hey guys, can you stop? Sounds like a Wookiee fest in here. Anyways. Sorry, one sec. Luke's my husband is taking them outside. They're being so bad. You guys aren't used to seeing me live. This is what happens when you see me live. It's like, you know, dogs do dog things. Okay, so what's going to happen next is I'm going to put that stupid thumbnail back up that I made for this, where I'm making a mean face, and I'm going to throw some extra slides on the PowerPoint, and in about 10 minutes probably I'll be back to double check that none of you guys left. And then at 7, we're going to get started. So I'll be around. Just stay tuned. Gutsick Gibbon out for a moment.
All right. Welcome, everybody, to Standing for Truth. My name is Donnie Badinsky. I am your host and moderator for tonight's highly anticipated debate on hominin fossils and human evolution between Dr. Jerry Bergman and Erica from the Gutsick Gibbon YouTube channel. And it is a privilege to have two experienced debaters for this event. Now, the question for tonight is this: does the hominin fossil record support human evolution? Now, before I get into the details and the format, and before we get into the fun itself, let's get acquainted, break the ice a little bit, get to know our debaters for tonight. Erica, let's start with you. Certainly not your first time here, nor is it your first debate. And so it is great to have you. Erica, tell us, how are you tonight? And tell us a little bit about your channel.
Yeah, okay. Can you hear me okay? I'm coming
You're
through all
coming in
right?
good.
Okay, let me
Yes.
make sure that everybody can hear me on my end, just to be sure. If you can't hear me in my chat, bug out right now and let me know, because otherwise I'm just going to start talking. Okay, yeah, so my name is Erica. I am a fourth-year PhD candidate in biological anthropology. So what I study is sexual dimorphism in Miocene apes, which might come up tonight, but probably not. My YouTube channel is mostly like science communicating biological anthropology or paleoanthropology, but I also do a lot of like engaging with the creationist literature and like debunking creationism over on my channel, which is why I'm so interested in having this conversation with Dr. Bergman tonight with Jerry. He said it was okay that I call him Jerry, so we'll go with Jerry. On the hominin fossil record, right? So my formal education was I got a BSA in pre-professional animal science, so I was pre-vet. Then I got my master's degree. It was a master's of research in primate biology, behavior, and conservation. And so, yeah, I think I'm pretty well seated now that I'm approaching. At the end is in sight for my dissertation, for my doctorate. I think I'm a good person to tackle this topic tonight for the side of conventional science.
Okay, Erica, appreciate you helping us to get acquainted. For those in the audience who like what they're hearing and seeing from Gutsick Gibbon, please do check the description box of this video for a link to her YouTube channel. So you can go give that a subscription and check it out. Erica, appreciate that introduction. Dr. Jerry Bergman, it's great to have you here as well. Not your first time on Standing for Truth, nor is it your first debate. As I said earlier, we've got two experienced debaters for tonight. So, Jerry, how have you been since the last time you were here? I think it was, if I remember correctly, your debate with Dr. Chris Thompson. Excellent debate. And so, again, tell us, how have you been since then, and tell us a little bit about yourself.
Well, I've been busy writing and researching. My background is I taught at University of Toledo, the Medical College of Ohio, which is now taken over by the University of Toledo. And I taught in the area of genetics and did cancer research. And so I know a lot about genetics and mutations because, of course, cancer is caused by mutations. So we know an awful lot about mutations and how they work and what they can do to life. And so that's my main interest. I've been interested in the evolution issue for many, many years. I was at one time an evolutionist. I worked for Madeline Mary O'Hare, and she, in our magazine, The Atheist, she had a lot of articles about evolution. And so I asked her, why don't we have more articles about atheism? Why are you spending so much time on the evolution question? She said, well, very simply, because evolution is the doorway to atheism. And we have found that the key to bringing people into the atheist worldview is to present effectively the evolutionary theory. And so I pretty much accepted that. And later on, I did more research on evolution and realized the science is quite clear that we did not evolve, we could not have evolved, we never evolved, and the science is very clear that we didn't evolve. But yet the fact is that most scientists believe we evolved, and so it's a belief, and it's often defended aggressively because this is their worldview, and they believe in evolution because that's how we got here, and they don't accept the other worldview, which is basically we were created, we live here, we exist for a purpose, and we have an afterlife. Evolutionists feel we came here by chance, by evolution, and when we die, we die. And so basically the contrast is very clear between the two worldviews.
Jerry, thank you very much for that introduction. Thank you from the both of you for those introductions. In a similar way to Erica, if you want to see more from her, check the description box. If you want to see more from Jerry, check the description box of this video. Okay, let's go over some of the details for tonight's exchange. Again, for anybody just joining us as we are doing this live, the question is this: does the hominin fossil record support human evolution? Erica takes the affirmative and proposes that fossil hominins are all close human relatives. Humans are thus apes, which acquired our human-specific characteristics as we evolved from more primitive apes over vast geologic time. Jerry Bergman takes the negative for tonight's debate. Jerry, taking the opposing position, proposes that humans are not apes and fossil hominins do not belong to the same created kind. All true species / specimens fall into discrete groups which are not related, usually a full ape or fully human dichotomy. And so, okay, Jerry, Erica, we are going to move into our first opening statement. Again, Erica takes the affirmative, and so she'll be giving the first opening statement, which will be 17 minutes each. Then we'll jump into rebuttals of 8 minutes each to respond to each other's points and arguments brought up in our opening statements. Then we'll jump into a discussion. Now, the discussion is going to be more free-flowing, more organic, rather than just a real strict cross-examination. That'll be for 50 minutes. Then we'll have concluding statements, 5 minutes each, to wrap up our thoughts, wrap up our points, address anything that we feel has been left hanging up to that point. And then this is where we get you guys in the audience involved. We'll have a flexible Q&A in light of the live viewers that we have in both streams. What we'll do is bump super chats to the top. So please, if you do have a question on tonight's topic, do tag me. Keep them respectful, keep them professional, as our debaters tonight have been gracious with their time. And let me know the questions for Erica or Jerry, and we'll have some fun with those. Okay, Erica, I see your slides being shared at the bottom. And if you'd like me to, I can get those up on the screen.
Awesome,
And
phenomenal.
you have between 17 to 18 minutes. Guys, I don't want you to feel too rushed or too pressured. So let's say somewhere between 17 and 18 minutes to make your case. Erica, I'll start the timer when you're good to go.
Perfect. Okay, let me double check that I'm good on my end. Make sure everything's showing up, because it's real buggy for whatever reason. Probably because I don't know what I'm doing, but that's okay. This is a learning experience for me.
Yeah.
Donnie, I'm gonna full screen my PowerPoint presentation. Or actually, wait, I think I can just do this. And then maybe I can do this. Is this gonna make it full screen? Oh, well, whatever. You can see that. Can you still see me?
I can see you. Have you tried to click the full screen on the slideshow itself?
Yes.
Or is that what you're...
Yes, it should be full screen on the slideshow, and you should see me over on this side, I believe.
We can see you. We can see the slides, but it's not full screen, as in we can still see the rest of the PowerPoint.
You know
where
what?
It says home. And
That's okay. We'll just keep it that way.
okay.
That's okay with me. As
we
long
adapt.
as you can see it, I'm a good sport. You know, I try to make technology work, but oftentimes it doesn't work for me. So we can just work with what we got. And one
Okay.
last check to make sure that we're good on the live end. Looks good to me. Everybody seems to be saying that it's working. Thank goodness. Oh my goodness, thank goodness. Let's do it. All right. So, Donnie, let me get my timer. Sorry. It's been a while. I'm
No
rusty.
worries. You're doing good.
All right, my timer started. Okay, folks, I'm going to be supporting the affirmative today, right? I'm here to say and to present the case that hominin fossil record demonstrably supports evolution, and I'm going to take it a step further and go ahead and say that it also precludes creationism, making that, like, not a possibility. So first things first, like, what is a hominin? Just in case everybody's not quite on the same page. But by current and conventional understanding, a hominin is any ape that is more closely related to humans than it is to the panids, so the chimpanzees and bonobos. It's basically any fossil ape that's more closely related to humans than it is to our closest living relative, which is the chimps and the bonobos, as I said previously. And this group is going to include apes in the genera like Ardipithecus, Australopithecus, Paranthropus, Homo, and many more. And if you don't know what any of those are, don't worry, because I'm going to tell you. So I'm going to pull a line from Ken Ham here, the classic. Actually, this goes all the way back to George McCready Price. We're working with the same data here, right? The hominin fossils exist whether we like it or not, and we've got these opposing hypotheses that Donnie sort of outlined at the beginning. So how are we going to interpret them? How would conventional science interpret these hominin fossils as opposed to creationism, or in particular, young Earth creationism? So evolutionary theory would say that humans descend from more basal or more primitive apes. The hypothesis most specifically would be fossil hominins are all close human relatives. Humans are thus apes, which have acquired our human-specific characteristics as we evolve from more basal or primitive apes over geologic time. Basically, we should see transitional species, right? And this makes three very specific predictions. The first one is that humans will have the morphologic or physical characteristics of apes, and that we will also have the physical characteristics of successively higher groups, or successively, higher groups. So things like we'll have the characteristics of not just apes, but also of anthropoid primates, and primates generally, and mammals, and chordates, and so on and so forth. Will also be, prediction 2 or prediction B, genetically most similar to the other apes, to the other hominoids, right? And critically, they should also be most similar to us, right? So it should go both directions. And finally, what we're going to be talking about today, which is the fossil record should demonstrably show the slow emergence of human characteristics from more primitive Miocene apes across geologic time. Now, predictions 1 and 2 are already true, right? And Jerry and I can go through this if we'd like, but humans do have all of the physical characteristics of apes. We have all of the physical characteristics of primates, all the physical characteristics of mammals, right? That's just where we nest. That's just the reality of it. We've known this since Linnaeus invented taxonomy in the 1700s. We're also most genetically similar, though, to other apes. We share 98.8% of our coding DNA with chimpanzees, our closest living relatives, and slightly less than that when we're looking at the entire genome. And this holds with the most recent data, right? So just 2 weeks ago, right, we got the complete sequencing of the ape genomes. This is almost telomere to telomere, and it reflects the same old phylogeny that we've been talking about since the dawn of these kinds of genetic studies back in like 2002. So humans and chimpanzees are one another's closest living relatives. We call them our closest living relatives, and they call us their closest living relatives too. Chimps share more genomically with humans than they do with gorillas, right? So the chimps and the bonobos. But number 3, or C here, we have to investigate tonight. We're going to investigate here the fossil record. So to support human evolution, the hominin fossil record absolutely must display the emergence of the human suite of characteristics over 7 million years of geologic time. From these Miocene apes that are generic, they're not chimps, right? Akembo and Pyrrholopithecus pictured here aren't chimps, but they do share a lot of similarities with modern apes. So we'll put our Miocene apes as our stand-in and switch back and forth a bit between that and chimps. And 7 million years comes from the molecular clock. So we need to see humans emerge from basal apes over 7 million years. Let's see what we see. But in order to chart this emergence, we have to actually know how humans differ from other apes. So I'm going to walk you through those characteristics that we're going to be looking for as we look through the fossil record very quickly now. The first is large brains, right? So I made this in R. This is just a look at the brain case size of 6 different hominoid genera. So we're looking at humans, gorillas, orangutans, chimps and bonobos, siamangs, and regular old gibbons. And what you can obviously see here is humans have huge brains and other apes don't, even for their body size, right? Humans still shine when it comes to brain case size with about an 800 cc difference. Humans have an average of about 1300 cc's. The biggest ape is going to be gorillas, and they're not getting past 500 cc's. Obligate bipedalism, of course. Humans move in a very weird way compared to all other living apes, so we should expect to see the emergence of the characteristics that facilitate our bipedalism show up through the fossil record. Now, humans and chimpanzees and all Miocene apes have the same bones and the same muscles, so we're just looking at a change in the shape of these bones and the size through time. Small canines. Humans, compared to other great apes, have itty-bitty canines, and apes generally, we have itty-bitty canines, right? And these canines are monomorphic, so they're the same size in males and females. This is typically not the case for the other great apes, but it is for us. We have a broad dietary niche and complex tools, so chimps use tools, and they use them to hunt. and they eat a lot of different things, but humans take that to the next level, so we should see an advance in tool use, and we should see an advance in the types of foods that hominins are eating through time. Finally, extended time to maturity. A lot of people don't know this, but humans take forever to grow up, and that is actually reflected in our physical morphology. So humans actually have 5 stages in our life history. We are infants, then we go through the childhood phase, then juveniles, then adolescents, then adults. But chimps only have 3, infant, juvenile, and adult. Those extra 2 stages, though, are marked by specific physical phenomena that show up in our morphology. So we should see the emergence of the human life history through time as well. So all these traits should show up in the fossil record, and we should see mosaics in mosaics, as in we should see transitional species that have transitional bones. The bones themselves need to be transitional. Luckily, it's very, very easy to identify all of these characteristics in the fossil record. Bipeds are super easy to identify. They have a forwardly placed foramen magnum, or a hole at the base of the skull. That's so that we can hold our head directly on top of our vertebral column and look all around. We have an inline big toe to sort of toe off as we walk, a bowl-shaped out pelvis for anchoring powerful gluteal muscles and strengthening the pelvic floor, a valgus knee to keep our weight in line, and many, many more. We can see big brains by looking at skulls. We can see small canines by looking at fossil teeth. We can see broad dietary niches by looking at isotopes and microwear and the morphology of the teeth. We can tell if tools are increasing in complexity over time by looking at the tools at different fossil sites where hominins are found. And we can tell whether or not the human sort of life history is emerging by looking at tooth eruption times and the microstructures of those teeth. Goodness. So, to summarize, if hominins are displaying the emergence of human traits over time, we will be able to tell. So let's talk fossils. We're going to start with brain case size. I also made this little graphic in R, and what you can see here, hopefully with my cursor, is over here to the farthest on the left, you have a Miocene ape called Rudopithecus. Then in sort of purple or violet above that is Sahelanthropus chilensis, the most primitive hominin that we know of that is considered to be a hominin. And then to the far right, you can see a human on the top, that's where we're going towards, and you can see a chimpanzee farther low, marked where their brain case size is at roughly 1200 cc's and roughly 400 cc's down here. So we should see brain case size increase. Let's see what we see. Next up comes Ardipithecus ramidus at 4.4 million years old. Not much to write home about, mostly just the same as a chimp. But then, here come the Australopiths. Members of Australopithecus see an increase in brain case size as we move more recently into the past, and it moves up towards in the direction of humans, right? So they have bigger brain case sizes. This is something that is demonstrably true. And even when we take their body size into account, their brains are still bigger than they should be for an ape like them. I included Paranthropus in here just for my Paranthropus enjoyers, and you can see that there's still an increase. Homo is where things explode, though. You can see when I add in these Homo points, right, that I've got them categorized by early genus Homo down at the bottom, middle genus Homo, which is really like African and Asian Homo erectus, and then later members of genus Homo, and we even see members of Homo getting bigger brains than what we see with modern Homo sapiens. So it might be tempting as a creationist to look at this definitive increase in brain case size in hominins through time to say, well, the ones in green, that's the Australopith kind, and yeah, they may have bigger brains than they should, but they're still a created kind and they're not moving towards humans. But you can't do that, because the shape holes overlap. So the highest Australopithecus and Paranthropus brains overlap with the lowest members of genus Homo. And the lowest members of early genus Homo overlap with the earliest members of Homo erectus, African and Asian, and so on and so forth as you move through the hominin fossil record, showing us that yes, in fact, brain case is increasing through time, and yes, in fact, they overlap the entire time by genus. And as I said earlier, highlighted on your screen now, this is even when you take body size into account. So what I've charted here is the encephalization quotient against time. You still see that same old increase. So do we see large brains emerge through time in the hominin fossil record as evolution predicts? Yes, we do. What about bipedalism? So start on your screen there is Ardipithecus over on the far left. And we're going to have to start with Ardipithecus because Australopithecus is already firmly bipedal. This is not up for debate. There is no wiggle room here. We know our Australopithecus as a genus is bipedal because they have all of the characteristics of a biped. So for evolution to support hominin evolution of bipedality, we have to go earlier in time to Ardipithecus. So what do we see? This is Ardipithecus. This is a skeleton. It's a beautiful skeleton. It's over 40% complete, and that's not even like reflecting it laterally. As you can see, the foramen magnum over here on the right is intermediate. It's in between what you see with chimpanzees on the top and what you see with humans on the bottom. That tells us that this thing held its head upright like a biped and not like a quadruped. But better yet, the pelvis is preserved on this thing. And not just the pelvis, but specific muscle attachment sites. So the pelvis itself looks more like a human than it does like a chimpanzee in the ilium, or the blade of the pelvis, but in the ischium, it looks more like a chimpanzee. So this pelvis itself is a mosaic. It's a mixture of primitive and modern features. From the side, it maps way more with Homo sapiens. But if you look at it specifically from the ischium, you're going to see that it shares more similarities with more basal apes. That should not happen if this thing is not trending towards bipedality, right? There's absolutely no reason for these features to exist, especially when you take into account the fact that it has an anterior inferior iliac spine, which is a muscle attachment site that clocks a biped, right? There it is on the far left highlighted by my cursor, then a human in the middle, and then a chimpanzee on the far right. And it doesn't matter which measurement you take, right? When you're looking at the pelvis, it's mosaic. 3 of these measurements you can see on your screen right now map with Homo sapiens, and 1 maps with a chimpanzee. Same is true for its femur. So we know Ardipithecus was at least partially bipedal some of the time because its body was upright and it couldn't have held its head like a chimpanzee could because its foramen magnum is too far forward and its pelvis is too derived towards strengthening the pelvic floor and the glutes and things of that nature. What about Australopithecus? Is it a biped? Yes, it's bipedal. Now, I told Jerry this before we talked, but I've watched a lot of his content and I'm gonna bust him here. I don't think that Dr. Bergman fully appreciates just how filled out the fossil record is for Australopithecus, right? Like we have hundreds of individuals across thousands of specimens across at least 4, probably more like 8 species, right? We know what these things look like. Every single bone, at least as far as I know, is represented. The foramen magnum in Australopithecus is forward like a human, not backward like a chimp. It's anterior rather than posterior. The lower back, the lumbar lordosis, looks like a human. You can see in this chart, there's Australopithecus right there, more like a human than like a non-human ape. And it has the human number of thoracic vertebrae, and we know that because this spine was preserved coming out of the head of the Australopith that it was preserved with, of its head, of its owner. The pelvis is unambiguously human-like. There is no getting around this. This is a drawing that shows the comparative picture with the chimpanzee in A, B is Lucy, and then C and D are a female and a male human. But when you look over here to the right, you can see 3 fossils, and then at the bottom, a human and a chimpanzee pelvis. Their pelvis is that of a biped, full stop, and it's not just a biped, it's a human-like biped. It's moving in the direction towards later members of genus Homo. Not exactly like genus Homo, but towards them. And if you prefer numbers, you can do a canonical variate analysis here, as Crompton et al. Did in 2024. And you can see that all the apes that exist today that aren't humans are over here on the left, and all the Australopiths lump with the humans in orange, right? Their pelvises look like those, their pelvises look like those of humans. And who's this one in the middle spanning the gap? It's Ardipithecus ramidus from earlier, our transitional pelvis hominin. So yes, they are bipedal, full stop. Moving on to the femur, same situation, right? The distribution of cortical bone in the femora of all Australopiths look like that of humans, having more distribution on the lower portion of the femoral neck. This is because that's where the weight is being borne, right? If you're upright, you need to have a really strong femoral neck on the bottom. There's a lot of strain there. They also have a valgus knee like a human to keep their weight in a singular column as they move. Lots of people like to talk about how there's no feet for Lucy. There's a toe for Lucy. There's no feet for Lucy because Lucy is one specimen. We have feet for Australopithecus, the genus, and my favorite one to point out is this middle one here, STW573, belonging to Australopithecus africanus, or our most complete Australopith specimen, and it has an inline big toe like a human, you guys, right? Like Australopithecus had feet that looked like human feet. You can look at the fourth metacarpal or metatarsal here, over here on the left to see that again. But I think the big toe fossil shows it best. And of course, we have their footprints as well. They look like human footprints if you don't run any analyses on them and if you don't pay attention to the size of them. But the Laetoli footprints are actually displaying a foot topography and a gait that is intermediate to humans and chimps. These are not made by humans, right? And we know because we tested it with living humans and living chimps walking through a substrate. Now, that doesn't mean that Lucy didn't climb. Just because it's bipedal doesn't mean it didn't climb. In fact, it had to climb because it had an itty-bitty brain and didn't use very advanced tools. So it maintains ape-like features in its arms. It was bipedal when it was on the ground, full stop. It doesn't matter if you're looking at the over 95% complete specimen of STW 573, or the over 50% complete specimen of the MH Australopithecus sediba specimens, or Lucy, which is laterally reflected, over 80% complete, or Katanumu man. Every single one of them shows the characteristics of a biped. So yes, we can see bipedalism emerge through time in the hominin fossil record. Check. What about small canines? This is actually super nice because Australopithecus already has small canines, just like a human does. But what's cool is you can see the emergence of that small canine through time and even within genus Australopithecus. Here it is represented in graphical format. So yes, we see small canines observed through, emerge through geologic time. We see the same thing with stone tools. Lamequian is assigned to Australopithecus, Oldowan is assigned to Homo habilis, Acheulean is assigned to early members of Homo erectus. Big brains, bigger tools. Check. And lastly, the human growth pattern. I'm running out of time here, so I'm going to kind of rush through this, but the human growth pattern for pretty much every hominin besides Homo sapiens is actually more ape-like, right? These Dmanisi specimens, which most people put in Homo erectus, which I don't think Jerry would consider to be a member of the ape kind, they grow up like apes do, right? Very quickly comparison to the slow growth that we see in Homo sapiens. And this extends up even through later members of like bona fide Homo erectus found in Africa and Asia. Check. We see the emergence of an extended time to maturity in the hominin fossil record. We see them all. We see them emerge slowly in full. I can go through this in depth with more figures later, which means that the hominin fossil record, as I said earlier, demonstrably supports human evolution and precludes creationism because there is no way to separate out these specimens and say that some are members of some kind and others are members of another kind. It simply doesn't work. I've never seen creationists agree on it, and I don't suspect that they ever will because there's simply too many fossils. So that's the end of my presentation.
Erica, thank you very much for that first opening statement of 17 minutes to our chat tonight. I appreciate all the engagement and interaction already. I am mostly caught up on your questions. The chats are flying, and so just keep those coming. Do your best to tag me. That way I don't miss them. Okay, Erica, that was between 17 and 18 minutes. Again, I appreciate it. Jerry, we are now going to reset the timer, and you'll have equal time for your opening presentation, somewhere between 17 and 18 minutes. I do see your slides at the bottom of the screen. And before you start, Jerry, I would recommend, if it's not too much trouble, if you want to go back to your first slide that says human evolution debate, at the bottom where it says hide, on that little bar, click that, and yeah, but now you'll have to go back to your, yes. Okay, Jerry, you're good. And just let me know when you're ready to begin. And you also have between 17 and 18 minutes.
Okay, I'm all ready.
Okay, floor is yours.
This is evolution. We start out with goo, fish, we go up to mammals, primates, and humans. And Darwin basically very concerned about the fossil record, didn't find much evidence at all. Of course, one could argue, well, today we have a lot more evidence. Let's look at the past claims. In 1925, and I'm aware of this because I did a book on the Scopes trial, and the evidence presented at the Scopes trial was this: Java man, Piltdown man, Neanderthals, and Cro-Magnon. And this was widely shown in the textbooks. I collect old biology textbooks, and from this evidence, they concluded that evolution is fact. It is true. It happened. And this is the evidence. How can you deny the fact of evolution when we have Piltdown man, etc.? Piltdown man, as you know, has been proven to be a fraud. Lots of literature on that. And it's pretty clear that it was a fraud, and therefore it has been removed from the record. Java man is based on a skull top and a couple of bones, which I think are human, and that likewise has been rejected. Neanderthal, another example. Neanderthal was used for about a century to prove human evolution, and here we have in the Neanderthal Museum, we have a Neanderthal all dressed up and nowhere to go. And the picture of this young girl is an example of taking a Neanderthal skull and building a body around it. And they're quite skilled at doing this. It's been done for many years, basically taking skeletons that were found in somewhere, and we assume they're murdered, and we need to find out who they are and what, and if indeed they were murdered. Here's Paropithecus, another example, and this was an ape man now based on a tooth of a peccary, which has been shown to be, again, false. How about Cro-Magnon? Well, this is a good example of new scientists. It could be you. Cro-Magnon skulls look just like our own. Here we go. Result of this, and I have hundreds of cartoons. Basically, this evidence was seen as unequivocal proof of human evolution, no question at all. And this is a good example of a cartoon, a fundamentalist here who says down with education, in other words, evolution. And the poor young boy, the younger generation, says, gee, Pa, must we wait around in this mud all of our lives? And another example is science, evolution science has shown creation and intelligent design to be wrong. And indeed, what we have seen from this evidence is that all of the evidence used for probably from 1880, I guess, to about 1950 or so has been refuted. That's the history. And in this book I did with Peter Line called Apes as Ancestors, we basically looked at all the claims relative to evolution, human evolution, and we found essentially one person has a model, a set of fossils. He argues that this is proof of human evolution, and his critics, other paleontologists, argue, no, it's not for some reason. And so we have this back and forth. And what we did in the book was show what one claimed, what the other claimed, and in essence, paleontologists themselves have effectively refuted many of the claims made by other paleontologists. And this is about 700 pages, about 8,000 references. So it's carefully documented. And if you know Peter Line, he's very thorough in doing this work. And that's what we're looking at. It's called the progression. And when we compare now, by and large, in the fossil record, what we find is bones. There's not much evidence of soft tissue, primarily bones. And when we look at the skeleton of man and of chimps, we find they are remarkably similar. I taught forensics for a number of years. And one issue is when you find a skeleton, you have to determine, was the skeleton human or primate? And that is not as easy as one might think. And we had to go over the differences. And of course, the skull and the pelvis area are very different. On the other hand, often when you find a skeleton, it's not in good shape, and therefore you have to determine whether it's human or whether it's primate. In the United States, this is less of a concern. In other countries like Africa, this is a major concern. The first step, you have to prove it's human. And then second step is to try to find out who the person is and whether they were murdered and who was the killer. Another example, making more comparisons. And they point out here the comparisons are such where there are differences, but many of the bones are very, very similar. Feet are different, of course, pelvis and the skull, but on the other hand, it's not always easy, unless you're an expert, not always easy to tell whether the bone is from a chimp or a human. Okay, we share the same bones. Shapes and sizes differ though, but 98% the same is what we taught when I taught forensics. So they are very similar. And again, there are differences, but you have to be an expert to determine those. Differences primarily were adapted for bipedalism, and the foramen magnum, of course, is a different position to allow our head to hold up high. The problem is you've got a skeleton, in this case you have a skull here, and from that skull, they sent that skull to different artists, and you can see the 4 different drawings they ended up producing from that one skull. And that's called, I presented this to one paleontologist, and he said, well, artistic license. We have to, obviously, we have skulls, we have bones, we have to somehow build what we think the individual looked like. And another example done by the National Geographic, you can see the bones at the top here. And from those bones, they had artists draw what they thought the human would be. Now, this is probably an extreme example because we're only talking about fragments. But nonetheless, from these fragments, you can see the drawings that were produced for National Geographic. Now, different evolutionary trees, it's clear that there's a lot of debate in the evolutionary and paleontological community. And these are 4 examples. Richard Leahy's model, you can see here. Next to that is Bernard Wood's model. Now, these are leading paleontologists. This is a few years old, which I'll explain in a few minutes. And then David Johansen and Tim White's model and Colin Grove's model. So you can see there's enormous differences from the fossil evidence that have been found. But now, fortunately, the number of ape to human transitional fossils are in the thousands, possibly one expert said in the tens of thousands. Although many are fragmentary, nonetheless, we have a huge number of fossils, and we're able to make some pretty good predictions on what these fossils look like. And again, that's what we're contrasting it with. We've got the progression from the ape to the modern human. And now that progression has been rejected. And one professor said, the simplistic picture of progress has come in for increasing criticism over the years, as our scientific knowledge about human origins has grown. Professor Alexander Worth wrote, the idea that evolution is a hierarchy of complexity with humans on top lurks in everything from biology classes to politics. It's time we unlearn this false and harmful view. Well, what is the modern view today? Well, this is an example of an effort to be able to, by date in this case, to place the fossils in some type of order. And you can see that's very, very different from the evolutionary progression that we have seen in the past. In fact, the evolutionary progression is by far the most popular picture of human evolution found anywhere. There are many, many examples. Now, this shows a lot of examples, but you can see how difficult it is to produce the progression from this picture. Well, they're trying to do that. This is another effort. You can see now we're beginning to try to produce a progression, and the progression is shown by dotted lines. And more fossils, more evidence has improved this. And you can see here, now they're grouped up into several categories. And now, with even more fossils, this is the latest set I have seen. You can see there are a tree and there are sections. You are at the top, so that's us, the Homo group. And then you can see the Pananthropus group on the right, and then the Ardipithecus group below that. And on the other side, you see the Australopithecus group. So now what we have is, and I've seen this over and over in the fossil record, what we have is not a progression from an ape to man, but what we have is a lot of variety in the level in the primate world. An enormous amount of variety is what we see. And we see that in so many areas. The horse evolution is an example, which we had the progression shown for years. In fact, that's one of the most popular presentations of evolution. And now we see all we have is a large number of horses, which does not fit the progression. There's the progression again, doesn't fit. Now, the percent of similarity, this book, Jeffrey Marks, got 98%. And this varies. A creationist just posted his comparison, and he found 95% similar. In fact, another study published in Nature found 85.1% different. Now, this was only nucleotides, and they looked at a 1-to-1 exact matches. So only certain parts of the genome was compared. And since that's the work that I did at the medical school, it is very difficult to compare genomes. There are genes in there. There are spacers. There are a lot of things we don't know for sure what they do. There are a lot of regulatory genes. In fact, a very important part of the genome is the regulatory genes. And as one geneticist I work with said, it is very hard to compare things that are at its heart uncomparable. And we can see that parts can be compared, but it's very difficult to compare the whole thing. Well, let's assume that 15%. Well, assume less than that. But the 15%, so we're talking about 450 million differences. How is these differences bridged? How do we go from apes, primates to humans? Well, Dawkins attempted to show how it's bridged. He started out with a bunch of letters, typed into a computer, and he programmed the computer to produce basically, me thinks it is like a weasel. When the changes were made, you can see the second line there. Instead of a question mark, WDL question mark, we have WDL. And so L is moving toward what we're looking at, and we end up with 44 changes, and me thinks it is like a weasel. The problem with this, a lot of problems, but the main problem is, number one, mutations, and this is what we know a lot about. This is what my work was involved in, because cancer is a result of mutations, and I worked in the area of cancer research. And number two, about 5,000 diseases are caused by mutations. So we know a lot about mutations. One important factor is hotspots. And so hotspots occur only in certain areas. You can see there are 4 hotspots here. And this is, I forget what gene this was, but another example is, this is, this is E. coli gene, and we can see the hotspot. And just thinking of that diagram we looked at a few minutes ago, we'll never get to the final area because we will have, like the question mark, WDL question mark, that will keep changing. That is a hotspot that will keep changing, and we will get very few or not many changes in the rest of the genome. And you can see a study of hotspots in different types of cancer. You can see they depend on the cancer. And what we found is that cancer is of many types. That means that the hotspots vary, and to determine what specific cancer cause is in this case, we need to look at the hotspots. And that's what we do. One study, only 2 mutations accounted for 94.4% of all mutations out of 319 identified in one gene. So the result is hotspots will keep changing, and we will get few changes in the rest of the gene. Also, looking at the empirical changes from a G to a T, we found in one study 16% from a C to a T. So a C to a T was a very common change in the genome. Very, very common. A to a T, 0.7, very, very rare. But still, conversions to thymine were much more common, 58% were changes to thymine. And this information is useful in determining the cause of the cancer or what's going on. You can see if you apply this to human evolution, what's going to happen. You're not going to get, period, the genome changes from an ape to a human. It's not going to happen. And that's, when I would mention that to my colleagues at the medical school, I got the look that, what are you talking about? We know that mutations mess up, they destroy, they damage the genome, period. You're not going to go from apes to humans. And this is from the cytosine. And again, we get A to C, 0.2, G to C, 12%, and conversion to adenine, C to A, 0, T to A, 0.8, and G to A, 24%. And so we can see that we're going to get movement in a certain direction. We're never going to get, as Dawkins pictures, is genome changes. Polarity is also important. Non-charged, non-polar, uncharged, polar, uncharged, borderline polar, nonpolar, polar, positively charged, polar, negatively charged. To have a protein that folds, it is critical to have a genome that produces the proper changes to produce the proper folding. And we can see that you have a mutation, for example, in the polar positively charged, chances are it's going to go to nonpolar uncharged or polar uncharged. And as a result, that's going to destroy the protein. It's not going to work anymore. And that is the basis of, 5,000 diseases. So, give an example of the evolution account is valid. If we change letters, for example, instead of IS, we have IA, and we keep changing letters until we get, for example, the creation account is valid. The problem with that is that the first step works, okay, The second step, when you start making these changes to go to another genome, we find that it doesn't work. And so if the changes occur from the gene that we start with to the gene where it changes into, we find that the changes don't work. The gene doesn't work, it's destroyed. And so it is next to impossible to go change from one gene to another gene, a different gene. So
30 seconds left, Jerry.
many simple changes can be made, but not the gene changes that we see. The interactome, this shows the fact that the entire genome interacts highly. When we get a change in one or two proteins, it affects one or two, or in some cases, hundreds of other genes. And that's called genetic catastrophe. And we see that's what happens in cancer. Although cancer, normally what you're talking about is a gene that just doesn't work. It no longer does what it's supposed to. And that's what causes cancer.
Time.
Okay.
Okay, Jerry Bergman, thank you very much for that roughly 17 to 18 minute opening statement. Erica, Jerry, that concludes our opening statements for tonight's debate on the question, do hominin fossils support human evolution? I appreciate the visuals and the time and work you both put into constructing those presentations. To our live chat, again, I appreciate all the interaction, the feedback, and the questions. We have bumped the super chats from both channels up to the top of the list for Q&A time. So, Erica, we're jumping into rebuttals. Now, for the rebuttals, we have 8 minutes each to respond to each other's opening statements, and I will start the timer again on, let's say, your first word. 8 minutes, Erica.
Okay, hold on, set my timer on my side so I can keep track of it too. So I actually had a weird moment during that because I had to check to make sure that I remembered the title of the debate properly, right? Like I actually thought maybe that was on my end because the title of the debate is, do hominin fossils support human evolution? And while I appreciate Jerry's presentation, and I've heard it before because I've watched all his previous debates and I've also watched his private presentations, that's not what the debate is about, right? We're not talking about mutations tonight. We're not talking about the waiting time problem or any of that. We're not even talking about genetics. And I wish we were talking about genetics a little bit because I heard Jerry mention the Jeffrey Tompkins' work in that. And I personally debunked Jeffrey Tompkins. I personally checked all of his methods. And when I published that work online, Dr. Robert Carter, another young Earth creationist, double-checked my methods and through a series of events confirmed that Jeffrey Tompkins' methods were incorrect and the 85% number is not an accurate number. Now, Jerry cited a Nature paper. I think what he's getting at is the Richard Buggs number, but that is not the same thing that Jeffrey Tompkins was trying to measure, and that's not the same thing that the 2002 paper was trying to measure or any subsequent paper. What Jeffrey Buggs' number is referring to is a nucleotide by nucleotide comparison, which you can get that to be 85%. Again, that's not what Tompkins did. It's a separate thing, but that also reduces the human-to-human genomic similarity down from 99.9 to about 94%. And then humans and chimps are still more similar than rats are to mice, African elephants are to Asian elephants, and lions are to tigers. So that, I don't see how that helps, but I'm just going to set that aside for now and move on to what I did decide to write down my notes for Jerry's opener that was relevant to the debate tonight. So first he talked about the Piltdown Man and Nebraska Man and all that kind of stuff, all the classic creationist talking points that I've heard before. I don't really care about that because it wasn't creationists that debunked any of those. It was other paleoanthropologists who did that. And every time they did, it caused extensive scrutiny to be applied to every other fossil of the fossil record to make sure that they were all legit. So we're not looking at any hoaxes sitting around in the fossil record at present, but even if that was a real threat, I really don't think that creationists want to play this game considering the number of hoaxes that are found in biblical antiquity studies, right? So, setting all of that aside, and paleontology generally, and every field of science, there are always bad-faced actors. He talked about debate amongst scientists with regard to specific theories and specific family trees. That's true for species. That's true for, is Australopithecus afarensis the specific parent species of genus Paranthropus and genus Homo? There's some debate on that kind of stuff. But what there is no debate on in paleoanthropology. And what the topic of tonight's debate is there's no debate on human evolution being shown from basal Miocene ape-like ancestors in the fossil record. All paleoanthropologists agree on that, and all paleoanthropologists, to my understanding, also agree, and I've done plenty of deep dives on this, that Lucy or Australopithecus was bipedal, which means you have a bipedal hominin, a bipedal ape with all the characteristics that make a human bipedal, with an ape-sized brain, but slightly larger than that, and some aspects of its teeth are human, and some aspects of its face are human, and other ones are more trending towards Miocene apes. I'm using human here to mean trending towards genus Homo. That's an ape man, right? We have about as many ape men as you could want. We have every possible stage along the way that you need. And creatures just hardly ever talk about them. Or when they do, they'll say, yeah, okay, maybe Australopithecus was bipedal, and maybe the brain case size does overlap with Homo and with previous hominins, and maybe you can find transitional bones in every single transitional specimen, but that doesn't mean that evolution happened. And to that I say, yes, it does. Unless you can provide an alternative hypothesis that is testable, that explains the data better, then that's where we're at, right? I mean, evolution made this prediction, and every single subsequent hominin has continued to support that prediction in full. I noticed that Jerry talked not a lick about all of our well-preserved Australopiths like SCW 573 or the Malapa hominins or even Turkana boy or the Dmanisi specimens or anything like that, or Ardipithecus. He mentioned varieties that they overlap. Yes, they do, because they evolved into one another, right? It's descent with modification. They're not found contemporaneous with one another all at the same time. You see these characteristics emerge through geologic time. And lastly, he talked, a lot about mutations. I guess really what I want to say, and I'm going to end my rebuttal early because I don't think that I can, you guys know I can fill the time, but I'd rather move the remaining time to the discussion because I'm really at a loss here. I want to talk about the bones, the fossils, because that's the title of the debate. I have a PowerPoint presentation where we can go over bone by bone by bone if Jerry wants to, and I can show, because I know Jerry has a medical background, right? I looked up his degree, so I know that he will be able to appreciate the fact that Australopithecus has an anterior-inferior iliac spine means that it's probably bipedal in combination with the rest of the suite of characteristics. So I'm going to kick it back to Jerry for his rebuttal, and I'm going to request that when we move to the discussion, I want to talk about Australopithecus. I want to talk about Ardipithecus. I want to talk about Homo habilis. I want to talk about Homo erectus, sensu lato, or sensu stricto. And I want to talk about whether or not we see human evolution through those fossils.
Erica, thank you very much for that rebuttal. And before we hand it to Jerry as moderator, I will say that is a fair point. What I would like tonight is a real comprehensive debate on the question, do hominin fossils support human evolution? So I would really like to see a lot of interaction with the Australopithecines that Erica talked a lot about, Homo habilis, and all the other hominins, sticking as much as we can to fossils, to our live chats. We do have over 2,000 people watching between both chats. So super chat questions will be priority at this point. It looks like we've easily got over 20. So if you do want a really good chance at getting your question engaged by our debaters tonight, Erica and Jerry, send in a super chat. We are hoping for a good balance between questions for Erica and Jerry, and I'll bump those to the top. Okay, Jerry, we are going to reset the timer, and you have up to 8 minutes for a rebuttal starting now.
Okay, I didn't have any problem with most of Erica's slides. I don't have any problem with, we have a variety of primates that lived in the past. That's not the concern. And I know we argue about the details of these primates, but that my concern is that does one primate evolve into the other primate? My concern was the evolution from a highly primitive primate to modern man. And again, I don't have any argument with the things that Eric has presented. That's fine. I'm familiar with most of that. What I am saying is that you cannot go from one primate to the other by evolution because there's no mechanism that allows the change from one primate type to another primate type. You can get mutations that have minor changes, very minor changes, but you never get the number of mutations you need to go from one primate to the other. And what Erica has done is she's had a lot of animals, lines them all up and say, well, here's one slightly more complex, here's one slightly different, here's one slightly different. She lines them all up and assumes that from the one primate, the others evolved. And I am saying, and these charts I showed simply show that what we have is a lot of different primates. And the same thing is true with so many other claims of evolution. And therefore, I think what she's doing is fine. It's interesting when I think I got more and more into this, and I realized, because I've done a lot of reading about these fossils, and I realized this is kind of an exercise in futility. And I came across a number of studies that conclude that Lucy is a pygmy. And I thought, this is absurd. But when I looked at some of the studies, some of the claims that people made, this may be wrong, but it's not absurd. And so drawing conclusions from fossils, from bones, is difficult. Not only difficult, but the key is to show evolution. You have to show there's a mechanism that one primate evolved into another primate. And the evidence from genetics is very, very clear. It cannot happen. It will not happen. It cannot happen. Why do people argue it did happen? Well, because, and I've spent some time talking to some of my colleagues at University of Michigan when I was doing some work there, and I mentioned that, well, you've got primates, you've got changes. How do we know that these changes are due to mutations, etc.? And the response was, I talked to was very honest. He said, we believe in evolution. We believe that's how we came from. We accept the idea that we evolved. If we didn't evolve, creation must be true. If creation is true, there must be a God. We don't believe in God. Therefore, if there's no God, evolution is the only explanation. And so, yes, you say there's a problem going from one creature to another creature, that the mutation system is not going to not do it. And we agree, that's a problem. On the other hand, though, what is the solution? Your solution is God did it, and we can't accept that solution. Therefore, we have to believe, because we believe in evolution, we have to believe that indeed this one animal evolved into this other animal, even though there's a problem in the mechanism, and they've come up, of course, with different theories, gene duplication and a number, and genetic random drift and so on. But none of these really satisfy the clear evidence that shows that one organism can evolve into another organism. And so to me, all we're talking about now is a bunch of animals that lived, and that's fine, but it's not showing, indeed, we cannot prove, because of the problem of genetics, we cannot prove that one animal evolved into another type, because we know a lot about mutations, and we know there's no way that mutations are going to cause one primate type to evolve into another primate type. Although you can get minor changes, that's not debated. Certainly you can get many minor changes, but you cannot go from one type to another clear different type. Although you can bring about one color to another color, mutations can cause color changes in the fur of animals. So you have a lot of mutations that can cause changes, and we understand pretty much why those mutations cause these changes. But on the other hand, there's no way that mutations can evolve a chimp into a human. It's not going to happen. And therefore, in many ways, as one friend who was an atheist and an evolutionist said, the science leads me to believe there must be a God because evolution doesn't explain it. In fact, I wrote a whole book on this, and that basically talks about evolution, cases of people who were believed in evolution and became creationists and believed in God as a result of studying evolution. And Erica did mention one thing, which was excellent, I thought, and that is scientists were the ones who showed all of these claims that were brought up in the Scopes trial as wrong. And that's true. I have said for many years that science will prove evolution wrong. And they're doing a really good job of doing so. But in the end, science will prove evolution wrong. And so I agree. Creationists, even if we did it, it would be hard for us to bring that to the scientific world. So scientists are doing a good job showing indeed that evolution is wrong, and science in the end will indeed show that evolution, and I'm talking about from the goo to you by way of the zoo, or as my biology book that I used to teach out of said from atoms to man, indeed, cannot occur. And so that's my main point. I had a lot of slides relative to all the arguments relative to the various fossils related to human evolution. I thought, I'll point out Dr. So-and-so said this, and then you'll point out, yeah, Dr. So-and-so from Harvard contradicted that and said, no, this is more accurate. So I thought these are, in many ways, kind of like arguing how many angels can dance on the head of a pin. They're arguing about minutia back and forth. And I thought, this gets to a point where I'm bored. And I spent a huge amount of time on this book, Apes as Ancestors, as well as other people that I worked with. And so kind of wonder, where's this leading? Where's this going? It's going to a lot of debates about a lot of creatures which existed in the past. And yeah, it's nice to figure out whether they're bipedal or not bipedal and so on. And that's all very nice. But again, we're not showing the key concern, and that is, how do you evolve a chimp into a human? And that clearly can't be done. And I think if an evolutionist could do that, he would get a Nobel Prize, and well deserve a Nobel Prize. But many, many evolutionists have tried to do this, and they've been unable to. And one I talked to, and he's the one said, well, the other choice is God, and I can't accept that. So evolution must be true, but it's the only choice there is. And so therefore, yeah, there's a problem how we go from a chimp to a human, but we'll figure it out. And we cannot accept it won't work, because it has to work, because what other explanation do you have?
20 seconds left.
So in short, that's where I'm coming from.
Okay, Jerry Bergman, thank you very much for that 8-minute rebuttal. Erica and Jerry, that concludes opening statements and our rebuttals. We're moving along smoothly here. We are now into everybody's favorite part of these debates, the discussion. We got 50 minutes on the clock for a discussion, and it's not a strict cross exam, but I still do want to give you both the opportunity to pick questions and pick specific topics that you'd like to interact and press each other with. So we'll go 25 minutes each, let's say. Jerry just ended with his 8-minute rebuttal. So what we'll do is give Erica the first 25 minutes to lead the way. What I'd also like to do, Jerry and Erica, is do our best to keep it focused. So one topic at a time, one point or question at a time. And that way I think we can be thorough addressing the topic at hand, hominin fossils. And if you need to screen share, so Erica, if you wanted to show a visual to help with the point, and same with you, Jerry, we can do that as well. Okay, let's start the first 25 minutes then. Erica, you are going to get the first half to lead the way, and the floor is yours.
Yeah, can you hear me okay? Make sure everybody's
Yes.
good. Okay, cool. So, so, again, we didn't hear any talk about any fossils on that one, and I want to talk about the fossils because that's the topic of the debate. I'm happy to come back and talk with Jerry about mutations. Truly, I'd love to do that, but that's not the topic for tonight. Tonight, we're talking about the fossils, and the reason why the fossils are important is because, and Jerry said this moments ago, that science, right? Like, science is at play here. Science is responsible for finding these, previous hoaxes to be incorrect, and science is what's moving us forward. Science requires the ability to set up a model, a hypothesis, make predictions about that hypothesis, and then test that with experiment. And that's what's been done in paleoanthropology. A prediction was set as early as Darwin that was what would we expect to see if humans did evolve from a more basal ape-like ancestor, right? And the reason they said it that way is because they knew humans were apes, because we have all the traits that apes have, all the physical traits, now we know all the genetic traits too that makes an ape an ape. But the question was what would we expect to see? And as early as Ernst Haeckel, we have people describing what this hypothetical ape man or transitional fossil would look like. And we have found them in spades. Every single bone that needs to transition, we find it transitioning through geologic time, right? Now, Jerry can say that, these are all different groups, but the problem is, if you think they're different groups, you have to tell me what delineates those groups. And creationists can't seem to do that. Is Australopithecus and is Australopithecus anamensis, and Australopithecus afarensis, are they related? Are they not? What about Ardipithecus? What about Africanus? What about Prometheus? What about Homo habilis? Or you could ask these kinds of questions. He said it's an exercise in futility with these fossils. I agree. For creationists, I absolutely agree. They've been at this for a very long time. The more fossils that come out that bridge the smaller and smaller gaps, it gets harder and harder for them to move these hominins into specific boxes. They're incapable of doing it. And that's why they keep changing which hominins are fully human and which hominins are fully ape. He mentioned that Lucy's a pygmy. I've never heard anybody propose that, except for Chris Roop, who is a creationist, and I don't think he did a study on it. If he did, I'd like to see it. Nobody in actual paleoanthropology thinks that Lucy is a pygmy because we find Australopithecus heads in articulation with Australopithecus bodies that have that Australopithecus pelvis. They're not humans. They're something in between humans and Miocene apes. Let me see. Anything else? Oh yeah, the last thing I'm going to say is nobody thinks that a chimp evolved into a human. Chimps and humans are both derived from a Miocene ape ancestor, so they've both been changing for just as long. So here's what I'm going to pit back to Jerry, and I'm going to kick it into his corner. I want to hear what he has to say. What would an ape man look like? If there was a transitional fossil that was out there that existed that would prove to you, Jerry, that this thing is a transitional species, what would it look like?
And before you answer, Jerry, feel free, if you'd like to, take a minute or so to interact with any of those points Erica made, and then move on to answering that question.
Yeah, let me say that. I had 2 or 3 thoughts, but they're gone now. I think I'm taking after Joe Biden. Anyways, I don't mean to upset anybody, but we just heard so much about his interviews. But at any rate, the major, showing this slide again, well, the major concern is I'm not concerned about all the details about all these fossils. I remember what I was going to say. That's true. Louis Leakey stressed over and over and over, we didn't evolve from chimps. Chimps and humans have a common ancestor. I know that's what he, but it's easier to say we evolved from chimps. And actually, we evolved from a chimp-like ancestor is the claim. But the problem is trying to figure out that ancestor. We have live chimps and trying to figure out that ancestor. And of course, we can speculate. We can probably find bones, etc., that seem to fit that. But as I mentioned before, bones are very limited in telling us much about a creature. They tell us certain things, but they're very limited. And I'm not debating all the differences in these creatures that we're talking about. But again, the key is we're talking about evolution. Can one creature evolve into another creature? Can a chimp-human common ancestor evolve into a human? Can that common ancestor evolve into a human? And the slide I showed, if you can see it here.
Yes, we can see it. Or I can see your slides at least.
Okay. What we are finding is as we dig up more and more fossils, what we're finding is we have groups and very definite delineated groups. And bridging these now, you'll probably find some fossils that will, to some degree, bridge these. By and large, this is what we find. And when we look at, if I can go further here, we look at horses. Horses is one of the most well-known examples of evolution. In fact, horses was, for years, for a century, this was evidence of evolution. There we have the progression. Now we have more information. Guess what we have? This is when we have more fossils, more examples of horses. This is what we end up with, a lot of variety in horses. And therefore, this claim of evolution from Eohippus to the modern horse is not true. What we see is, and this is more accurate, what we see is a huge amount of variety of horses, period. What we see with humans and primates is a huge amount of variety. And again, that is not proof that one evolved into the other. And that is a central thing we have to prove. And I guess Peter Lyon and I went round and round on all these things, and it's interesting to find the traits of these different creatures which we're looking at. But again, the key is we have to be able to show that one evolved into another, and we can't show that, period.
So
Okay, let me step in right here. And Erica, before you go, perhaps before Jerry answers your question that you had, since we got a few different points on the table now, Erica, did you want to take some time to respond to any of that?
yeah, I
And then-
do. I
okay, go
do.
ahead.
Jerry, are all those horses related in your opinion? All those varieties of horses, are they related?
Yeah, they're all, well, we know because most of them are alive. And of course, we find the fossils. When we find the fossils of a horse, we can typically find the fossils represent a horse that is alive today. And that's true with many fossils. We find the fossil of an animal, we find, lo and behold, they're around today.
What about Eohippus? Eohippus is not alive today. Is Eohippus related to modern horses?
I would say Eohippus is just an extinct horse.
Okay,
or
so
type of
those
mammal.
so those horses, like the entire horse group, that displays less variation than the apes that we're talking about today. The apes don't need to reduce any digits. They're not getting rid of any digits. They're not changing size drastically. The difference between a Miocene ape and a human, physically speaking, not talking about what's going on with the brain or spirituality or anything like that, which if you want to appeal to that as the difference, that's fine. But we're talking about bones. And the difference between a Miocene ape and a human, something like Rudopithecus or Pierolopithecus and a human, is less than the difference between Eohippus and a modern horse or a modern zebra. So if you accept that those guys are related, I don't think you have any ground to stand on, morphologically speaking, when you look at the apes, when you look at the Australopithecus specimen, members of the Australopithecus genus, the Australopiths, Ardipithecus, all these Miocene apes, members of genus Homo, you can't accept one and not accept the other unless you have a reason.
Well, we know that from my work in forensics, we know that there's a lot of similarity between the bones in humans and bones in many primates. And so that similarity is there. And so, yeah, you're pointing out the similarity. Yeah, it's there. But that doesn't prove that one evolved into another. And the key is did one animal group evolve into another animal group? Did that happen, number one? And you're just assuming. You're lining up basically what they've done in the past so often. You're lining up a bunch of animals and you assume, well, this animal evolved into this animal, which evolved into this animal. You don't know that. You can line them up and say, well, they look like they did, but that doesn't prove they indeed did. You need evidence that they did, and we don't have that evidence that they did. It's simply an assumption that they must have evolved from this to that to another thing.
So
what we know about genetics is very, very clear. You're not going to get evolution. You'll get mutations, you'll get disease, you'll get 5,000 diseases, you'll get cancer, you'll get changes because we know that mutations, by and large, they damage the gene and we know they don't work. And we know, therefore, that you will never get evolution because the genome clearly prohibits it. And you have to have faith. And of course, I told one of my friends, you have more faith in evolution than I do in creation.
So
said, well, that's true.
Two things on that, though, right? But you just did that, right? You just made the assumption that Eohippus is related to modern horses. And the reason you made that assumption is right because they share characteristics and they share synapomorphies. They're all members of the family Equidae. In the same way, humans are apes now, and we descend from previous apes because everything that makes a human emerges through the fossil record through time. Sometimes we can even narrow down the specific mutations that are responsible. We found the mutation that was responsible for reducing the tail in the evolution from monkeys to basic apes. That happened just last year. We put it into a mouse and the mice were born without tails, right? We know where some of these mutations are. The change is less between a human and a Miocene ape as between Eohippus and a modern horse, and yet you accept that Eohippus and a modern horse are related and deny that humans and other apes are related and that humans are members of the same, that they share a common ancestry through common descent. But that's not logical because the mechanisms are the same in both ways. If you accept that Eohippus can reach a modern horse, necessarily those same mechanisms can get you a human from a Miocene ape. Full stop.
Now, I don't know if Eohippus is related. I think it's just an extinct animal, and what type of animal it is, the details, I don't know. But I'm not claiming it evolved from Eohippus. I don't know.
Okay, that's a little different. That's fair enough. That's a little different. So let's try this instead. Is a Chihuahua related by common descent to a Great Dane?
We know that is true because we have done it. We know that we started out with wolves, and we know we have bred from a wolf to the 200 and some odd different breeds of dogs existing today. And we know that that's true with dogs. It's true with a number of animals like dogs, cats, and so on. we know that built into that animal is the ability to produce a great deal of enormous amount of variety. But that's built into the animal. And I don't think there's any doubt that indeed we start out with wolves way long ago. And from wolves, we bred to, some argue there's more than 300 and some breeds, but nonetheless, we have a large number of breeds of dogs. And we know because we did that.
Right.
And we know also because that's true with dogs and certain other animals. Other animals, we've tried to breed differences and haven't been able to. There are a few animals that we are able to breed enormous differences, and you're right, huge differences. Dogs, horses, cats, other animals, cows, I'm told. But on the other hand, so many animals, we try, and boy, you can't get much more than a color variation. There's just not much variety in being able to breed those animals, and that is inbuilt in the animal. It has the, I hate to say the animal has the ability, but some animals, you can produce enormous amount of variety from the single type, but most animals you can't. You're very limited, and that depends upon the specific animal and the genetic construction of that animal, and that's intriguing, but that's not really related to whether our common ancestor became humans.
So, Donnie, I'd like to share my screen here because I think it's very telling that Jerry accepts that Great Danes and Chihuahuas are related, because the change in body, the body changes that actually, the genomic changes, yes, but reflected in the body between a Great Dane and a Chihuahua are, just looking at it, because I'm pulling up the pictures so that they can be side by side. I'm grabbing
Erica, are you looking to screen share?
Yeah, not yet. I'm grabbing,
Okay.
I'm sort of rambling, filling the time while I pull the pictures up on my slideshow because I'm adding some pictures now so that we can look at them side by side. The difference between a Great Dane and a Chihuahua are absolutely less than the difference between a member of Australopithecus and a human. So I'm going to share my screen now so that you can see this. Here you go. You should be able to see it, Donnie.
Yeah.
So that's a Great Dane, the big one. The little one is a Chihuahua. Nobody has any problem accepting that these two things are relatives. Nobody has any problem accepting it because, one, we witnessed it, but two, they have all the same bones. The bones are just different sizes and slightly different shapes. There's obviously a difference in brain case size. There's a difference in the morphology of the teeth. There's a difference in the length of the tail. Lots of differences in these little guys. In fact, you can even breed dogs with like more extreme differences than this. This is the difference between a human and two members of Australopithecus, right? One is Australopithecus prometheus, or what I like to call Australopithecus africanus, and the other is Australopithecus sediba. These are Lucy's genus. The differences between these three are demonstrably less than the differences between these two. And yet mutation and selection can get you these two from a wolf, but according to Jerry, they can't get you these three from something that is like, well, shoot, let's pull up Rudopithecus and look at that. Something, or we'll do Artie, something like this, right? That's not logical, and that's special pleading in my opinion. Now I want to hear Jerry's response to that, but I also want to know, when you look at these guys side by side, right? It's not just that you're laying them side by side like this. This is through geologic time, right? The brain case size increases through time, and they overlap. That's not what you see even in the horse series. The hominin evolution series is astronomically better than the horse series. Ask any paleontologist this and they'll tell you, and I know this because I talk to paleontologists all the time, and I'm fixing to be one here soon. And to be abundantly clear, like these aren't incomplete. These are all skeletons. And to make matters worse, I've heard Jerry mention before on talks that it's like, oh, Lucy's not that complete. I disagree with that because, of course, you could reflect her laterally and you end up with over 80% of the skeleton represented. But this individual right here, Australopithecus africanus, again, that same STW 573 specimen, that's over 95% complete. And you don't even have to laterally reflect it. So I'm left asking again, we have the ape men that creationists have been asking for forever. We know that they belong to the same species, the same genus, because this guy that's highlighted right here was found in articulation, right? That hand that you can still see clenched in the picture, right? It's still in the block. because this thing was found all together. So we know that that head belongs to that body. So we know what an Australopithecus, member of Australopithecus looks like. We know that these are accurate representations and not pygmy humans. So we know that they were bipedal. So we know that they have mosaic features in their pelvis, in their femora, in their head, in their teeth, in their arms, in their fingers, in their feet. And we know that it overlaps with previous Miocene apes, and it also overlaps with the earliest members of genus Homo that creationists accept as fully human. Right? Members of Australopithecus overlap with early genus Homo, which overlaps with Homo erectus, which overlaps with Homo heidelbergensis, if you want to call it that. So I'm left asking again to Jerry, what would an ape man actually look like? What would actually convince him? And I don't think that he has an answer to that, because if there was an answer, I would be able to show it to him, because we have all of the transitions that we need to support human evolution. Stop sharing.
Okay, Mike, thank you for showing the picture of dogs. I have several that I show this, but no one's claiming that the one dog, the big dog, evolved from a small dog or vice versa. But the same thing with horses. I have horses that have skeletons that are about as high as the ankle of a dog. And other horses, which are one that's like 8 feet tall. And so, yeah, there are huge differences in dogs and horses and cats and so on. I'm not denying that. But no one's claiming that a long time ago, way back in the fossil record, there was this wolf or whatever, and that evolved through natural selection into the other types of dogs. This is built-in variety that the dogs, horses, cows, and other animals display. And some animals have this built-in variety, and some animals don't. Humans, my conclusion is, don't have this variety. And claiming that these different humans lived, well, that's one thing. But claiming whether or not one primate, in this case, evolved into another primate is a whole nother question. And that's what I doubt. I don't question any of the data that you brought up relative to the traits of these various primates that you found. The question is, can they and did they evolve into modern humans, and can they do that by mutations? And my conclusion is they can't. And so what we've seen is there's a lot of variety in the natural world, and in animals, and especially primates.
But Jerry, if you can't tell me which ones belong to one variety and which ones belong to another, which you can easily and clearly do with dogs, and you can clearly and easily do that with horses, you can say this little horse is a member of Eohippus, and this medium-sized horse is a member of Mesohippus, and this large horse is a member of Equus equus, right? You can do that. Hominins you can't do that with, because the fossil record for them is filled out so completely, and there are a couple of other animal groups that are filled out this well as well. But because we're humans and we like to know about ourselves, we've researched hominins extensively. And there's no way to clearly delineate which members clearly have these characteristics and which members clearly have these characteristics where there's no overlap at all. That's impossible to do. So these varieties that you're talking about are non-discrete. They're gradients, which means that if you say a human has these characteristics and you accept Neanderthals as human and you accept Homo erectus as human, then everything overlapping with Homo erectus gets lumped into humans, which means now Homo rudolfensis and Homo habilis are human. And that means everything that overlaps with Homo habilis and Homo rudolfensis is human. So now Australopithecus is human. And then everything that overlaps with Australopithecus, it has to be human. So Ardipithecus is human. And you end up with every single hominin and eventually every single primate being a member of the human group, and then you back it on into mammals and it becomes a mess. Evolution predicts a gradient. Creationism does not. Creationism specifically predicts, like all the way back to like Frank Marsh, that you should have these discrete groups. And these discrete groups don't exist. They don't exist in hominins. They don't exist in other groups, but of course I focus on hominins. So you keep talking about these mutations, and I could appreciate that. But like, the reason we're talking about the fossil record tonight, and I can have a conversation with mutation, you've had it already with Dan and you've had it already with Chris Thompson, but those mutations necessarily result in physical changes to an organism. We can agree on that because we agree that dogs and wolves share a common ancestor, right? So that means if we find physical characteristics in the fossil record between organisms that we accept are related, we can agree that mutations and selection caused those differences to proliferate. So now the job of the creationist is to point out which differences were created and are the result of God specifically saying these are specific created kinds, and which differences are the result of like created design being at the mercy of natural selection and evolution. because you do accept some degree of change over time, because you agreed that there is a type of change that can happen within organisms. As a creationist, it's your job to point out what's design and what's descent. And the problem is when you apply that question in particular to hominins, everything is human. They all end up as human, because everything overlaps with everything else. And I'm not just talking about species. Like, I know there are creationists out there who are saying, well, how do we know that it's not just a combination of human bones and ape bones that gives the appearance of a transitional species, that gives the appearance of overlap? But the problem for the creationist is it isn't just the specimen, it isn't just the species, it's the bones themselves. Like I showed in my PowerPoint presentation, and I'm going to pull it up again, Donnie, so that everybody can see. The specific bones are transitional. One part of one bone will be will be more human, and one part of another bone will resemble earlier, more basal critters. Just a sec. Share my screen. Good Lord. In the case of this pelvis, right? This is a canonical varied analysis. So this is looking at several, actually over, I think I have it on here, over 30-something landmarks, if memory serves, from Crumpton et al., I think. That might be McNulty's paper. Either way, this is landmark data. So this is taking a 3D scan of something, marking it up, and then sticking them all in to see how they hash out, like how they compare to one another. This is 3D data. So it's not just one measurement, it's many, many, many measurements. And in some ways, Australopiths resemble humans in just the pelvis. And in some ways, they resemble chimps, right? Earlier, I showed this to you with Ardipithecus ramidus, one single pelvis that in 3 dimensions that you can see on the screen resembles humans and other Australopiths, and in 1 dimension on your screen resembles chimpanzees, right? They have a tall ilium, or a tall ischium, like chimpanzees, but a short ilium like humans. They have an anterior-inferior iliac spine, but they also have curved phalanges, long arms, and a divergent toe. All of this in one organism, some of this in one bone. So creationists have to answer that. They have to explain, how do you differentiate the kinds? Because these physical characteristics are reflecting mutations. They're reflecting genetic differences. Back to you.
Okay.
Answer that.
And before you go, Jerry, there's a bit there, so feel free to respond. Then I would like to, if we could, see some engagement on your question, Erica. And correct me if I'm wrong, your question was, what would we expect an ape man to look like?
Yes, thank you, Don.
And then perhaps Jerry can answer that, and then you can provide an example that might meet his answer. But there are a few things there first, so Jerry, feel free to take a minute or so to respond. Go ahead.
Yeah, no one's claiming that the one dog, Great Dane, whichever it is, evolved into the other dog. That built-in variety is what allowed the variation to exist. It has nothing to do with evolution. It has everything to do with the built-in variety. And that's why we see this great difference in dogs, in the skeleton, in this case in dogs, and in horses and cats and other animals. And so you see many, many examples of this, of certain types of animals. And when you look at a lot of these creatures, you can see similarities and differences. Relative to variations in human bones, you can see that as well. When you work in forensics, you have every now and then cases of a skull that looks very much like a non-human skull. And you have to determine, indeed, was this a human? Because if it was a human, we got a murder here we have to look at. If it's not a human, we don't. Therefore, you have to differentiate it. And those who examine skulls, and there's a number of collections, find indeed that among humans, you see enormous amount, relatively large, I should say, amount of variety. And you have indeed humans that have skulls, not identical, of course, but more ape-like than other humans. And so what I think you're doing is you're looking at the variation you see in primates and humans, and you're lining them up, and you're assuming that one evolved into the other, etc. And that is the assumption that I'm mainly concerned about. Because again, you have a great deal of variety in bone structure, in relatively great in humans as well as in primates. And what you're doing is you're finding that variation, and you're lining them up, and you're saying, well, this evolved into this, which evolved into that. And I'm saying that you can't do that, because you have no mechanism to show that indeed one evolved into the other. You can't do that. And logically, understanding mutations, you cannot show that indeed they could produce the differences that you see. And so certainly mutations can produce differences. You can especially mutations can cause a loss of structures of tails, as you mentioned, and so on. So mutations can produce differences, but can we go from a chimp-like common ancestor to a human by the building of mutations? No, we can't. We cannot do that. That's not going to happen because we know too much about mutations. We know the fact that you will never get the changes you need as a result of mutations for the reasons that I mentioned. And my presentation was very brief on why you can't. There are people who spent a huge amount of time looking at the difficulties of going from one animal to another by mutational changes. And I should mention, didn't mention this before, but you have a correctional system, that basically repair system, and basically something like 99% of all mutations are repaired. They're fixed. Now, how can natural selection explain that? And so the body is designed in such a way to where change is resisted enormously. In fact, the mutations that are there are due to the fact that the repair was not proper. And so many mutations that actually show up are a result not of the mutation, but the fact that the repair didn't work for various reasons. And there's about 5 different repair systems. So the body is designed in such a way to resist changes by mutations. And that's one thing, of course, cancer researchers are looking at, understanding that in more detail. And but that's another subject. So, the key is, again, we have lots of fossils. You can line them up.
I'm going to jump in, Jerry, and I appreciate those responses. Let's try and now keep on both sides, Erica, Jerry, let's keep it more free flowing where it's maybe 30-second responses. Yeah. Therefore, there's not too many points, because I do really want to see some engagement on the question regarding a transitional form. What would we expect to find in terms of an ape-man? And then Erica, perhaps you can go over some of the examples in visual form that you presented in your opening. So Erica, let's throw it back to you. Go ahead.
Sure. So 2 things. You might have heard me typing away on that. I wasn't trying to be disrespectful. I wanted to make sure that I had an example for Jerry, because I told him that, we have mutations to get from this ancient Miocene ape form to modern humans. And I gave an example of knowing the gene to get rid of tails earlier. Like, we've narrowed it down to this entire gene complex on how to lose a tail. And Jerry's response was that, well, that's degradation. What about brain growth? Because I have 2 examples that I've pulled up here, and I'm going to share my screen again, Donnie, to show this to Jerry, and then I would like to get to this ape man question, but there's just too much good stuff to talk about. So hopefully you can see that. It's ready to share if you'd like. Here's 2 examples of mutations that we have clocked in humans and compared to other apes and even Neanderthals. On the left, and I can give you guys these papers later, I just had to grab these images first. Humans have a mutation in transketolase like 1 where we got an arginine instead of a lysine. And this is a difference between modern humans and Neanderthals, and it's also a difference between modern humans and ancient humans. And this single point mutation in transketolase like 1, having an arginine instead of a lysine, has caused a tripling in the basal radial glial cells, which causes neurons to, let's look at this, it's 2.5 times the amount of neurons that you previously saw in Neanderthals, at least with what's interacting with this specific, with transketolase like 1 specifically. So there's an example of brain growth specifically with relation to human evolution, and this is proposed as being one of the genes that may have given humans an edge and been the reason why humans are here and Neanderthals are not. Down here you can see 2 brains next to one another. Each of these brains belongs to a marmoset, which is a type of small monkey. They're a New World monkey, member of the family Callitrichidae. They're not known for being very brilliant. On the left is a normal marmoset brain, and on the right is a marmoset brain that had the human gene, RGAP11B, inserted into it. Now, all primates, and I'm a little rusty on this one, so hopefully I won't get this wrong, but to my understanding, all primates, maybe it's all anthropoids, have RGAP11A, have the regular RGAP11 gene, right? But in marmosets, like they're a dumber monkey, so they don't have the second copy. Humans do. Humans have RGAP11A and RGAP11B. And when you take the human version, the human copy, it's just a duplication of RGAP11A with a series of neofunctionalization, I guess, to it. I'm probably butchering that. But it causes the brain to grow significantly larger and to even develop more gyri and sulci, right? So this is a gene, a duplication in an ancient primate gene, that when it gets duplicated and slightly altered, you end up with a bigger brain, right? This is how you get something that's fundamentally different from a primate that is, relatively just a slight divergence from a mammal to something like anthropoids, and then something like apes, and then something like humans specifically. So to be clear, these mutations that we've narrowed down that have a direct impact on the fossil record aren't just loss, it's gain as well. Now, I really want to ask Jerry, and I want him to take this way, and I'm with you, Donnie. I think we should do the back and forth. So what I think I'm going to do is let Jerry answer this question on the
Yeah,
ape
and
man
let me
thing.
answer.
Yeah, and then I'm going to shut up because I want to hear all of what he has to say, and then maybe we can get into the back and forth 30-second thing. I won't go nearly as long next time. So go ahead, Jerry.
All systems in the body have mutations that produce growth, and they also have mutations that stop the growth. And your little mutation you're referring to, from recollection, is the mutation did not stop the growth, and the growth continued beyond what it normally should. And because it has more cells, larger brain, doesn't mean it's smarter. It doesn't mean it's functionally superior. What happened is that it's larger, and you get that with some other organs as well, which can be lethal, by the way. And what happens is that the growth is not stopped when it should. The brakes were broken, and as a result, the growth, in this case, glial cells, I assume, continued, and so you have a lot more glial cells, but this does not mean the person is going to be more intelligent or more brainy in whatever way you think the brain should do. And of course, you see this with Neanderthals. Neanderthals had, on the average, and I forget the numbers, but Neanderthal has, on the average, a much larger brain than humans have today. Whether that was, well, I assume it was functional because we're talking about another human in Neanderthals, for example, but you cannot look at mutations that damage the stop factors are helpful. Indeed, in many cases, they're not, and they cause death. And there are many diseases, like Huntington's disease, a good example, where you have a mutation that causes an increase beyond what it should normally occur. And so growth has to be started, controlled, and stopped. And in this case, from my recollection, the growth system was damaged, so it didn't stop when it should. And as a result, we end up with a larger brain, but we don't end up with more functional, more brain able to do what brains do. I would assume this would be damaging. Too many glial cells, you have a problem. Glial cells are certainly very important, but too many, I would say, probably damaged the brain, and as a result, it did not work as well.
But it didn't, though, right? Because it exists in modern humans. That's what I'm saying. Neanderthals don't have this mutation. Modern humans do. We have a higher neuronal density than Neanderthals because of it. That's like it's not like this could have happened. This is the difference, genetically speaking, between us and Neanderthals. They don't have this tripling. It's not a tripling. I think it's like 1.5 times. It's a near tripling. We do, right? So it wasn't lethal for us. It was actually super beneficial. And in the case of the marmoset, right? They didn't let that marmoset go to term, but they could have. And if they did, I have no idea. I mean, the marmoset's skull was forming just normally around with the brain. It wasn't like it was going to abort. It wasn't like it couldn't reach term, right? The scientists were the ones that said, I don't know what the ethics are of bringing a marmoset with a brain that's 2 times larger than a regular marmoset or whatever it was into the world. But that's neither here nor there. I really want to know, what would an ape man look like to you? Because surely, if you agree that mutations cause physical changes, and I think we both agree with that, then a hypothetical ape man with a set of hypothetical genetic changes would look like something. So what would it look like in your opinion?
I would say a hypothetical ape man would look more like an ape, would look more like a chimp or a gorilla or some other creature. It would have features that are not typically human, but that are typical of some other primate. And that, again, that's guessing, that's speculation. And that's my concern, is that all too often, this is how evolution proceeds, by a lot of speculation. And then they assume, well, this is the way it must have been, and therefore we must have had this change. What you mentioned relative to Neanderthals, I guess have to take umbrage at that, because that's my genetic background. I've done genetic testing, and I found I have a significant number of Neanderthal genes. And I know a number of people who have a significant number of Neanderthal genes. And I guess this leads into the racism idea, which was so prevalent in evolutionary biology for generations. Indeed, there are differences between different races, and these differences are genetic, and therefore, well, we know what happened. And therefore, when you demean Neanderthals, I guess I have a problem with that, because I have a significant number of Neanderthal genes according to the genetic testing that was done on me. Now, whether I have the traits that you're talking about, I don't know. But on the other hand, from what I know, Neanderthals were simply, as one article in National Geographic said Neanderthals are simply one of us. They are us, as we know, in every way, shape, and form. They looked a bit different physically, but on the other hand, as far as we know, they had musical ability. They buried their young. They find many, many traits Neanderthal had are very similar to us. In fact, many, many differences. So I guess I wasn't aware of any, although there could be, because there are certainly differences between different groups. So this could be a difference you find in different groups. I don't know. But on the other hand, I have to admit, I haven't heard that before. And I just wonder if that's not racism, eugenics creeping into science, which we've finally gotten rid of largely, but that dominated evolutionary biology for a generation.
I don't really know what to say to that, because like this is not a gene that modern humans have. No, like that's what I keep saying, is that modern humans don't have this gene, right? Humans do have Neanderthal genes. None of the genes that exist in humans today are impacting the density of our neurons, right? Like that was the point of this study, is to show that all modern humans have this advanced brain gene, right? Transcaptase like 1, where we have an arginine instead of a lysine. Yeah, an arginine instead of a lysine. Neanderthals don't have it, right? So like all modern humans do have this benefit and Neanderthals do not. No modern humans have this gene, but Neanderthals did. So like there's not a racial element to that, because Neanderthals aren't members of Homo sapiens. First of all, they're a different species. In fact, some people have proposed that their physical characteristics, if we're being consistent, would place them in a different genus, but I don't agree with that personally. But they were very similar. I mean, they're human in the sense that they're genus Homo. They're one of our closest living relatives. They were capable of incredible things. They buried their dead. They had art. They were capable of, hunting vast prey. But they're extinct and we're not. And one reason why that might be is this specific mutation. People have pointed to it as one of the reasons, because it has been argued to have allowed humans, anatomically modern humans, to be more innovative. Every modern human has it. And every modern human can trace our ancestry back to a group of modern humans, not Neanderthals. There are Neanderthals in our gene because there's introgression. But no, this is not an example. There's plenty of examples of scientific racism, and there's plenty of examples of racism in all science and all history. But this is not an example of that. But I really want to hear about the ape man. Now, you said earlier that it would resemble an ape instead of a human. So I can show you Ardipithecus again, where I could show you that Ardipithecus is ridiculously ape-like in many characteristics, to the degree that it's got a massively divergent big toe, that it's got larger canine teeth than what we see in any subsequent hominin, but still smaller canine teeth than any Miocene ape that came before. It's got long arms, curved phalanges, right? It's got, like, generally speaking, ape-like body proportions. And yet, in addition to that, it has a pelvis that's a mix of human and ape characteristics. And when I say ape, just for the pedants out there, I'm meaning it in the sense that creationists mean it, so non-human ape. It's got a mixture of aspects in its pelvis. It's got an anterior foramen magnum, so we know that it was upright. It's got a less prognathic face than any of the Miocene apes that came before, like Rudopithecus, or maybe not Rudopithecus, but like Paralopithecus or Hispanopithecus, right? It's got a small ape-like brain, but it's got these aspects that tell us that it's something that's moving more bipedally than anything previously. And interestingly enough, that made a phenomenal prediction for scientists. What kind of environment would an ape that is sometimes coming to the ground, to the point that it has a morphology that reflects that, what kind of environment would an ape like that live in? A mixture of woodlands and grasslands. And when you do the paleoecology on where Ardipithecus lived, in Gona or in Aramis, that's what you get. Right? This is exactly a prediction made by evolution. And that's what I find a little bit frustrating about this conversation, is because I hear you, I really do, and I'd love to have a conversation with you about mutations, but the way science works, every field of science, even when they're collaborative like this, is that a prediction is set on the outset. The prediction is then experimented on, right? You experiment to see what happens, basic hypothesis testing. And then if the result supports the prediction, which in this case every single hominin has in spades, as far as this basic concept of human evolution from basal Miocene apes, then you either reject the hypothesis, which no one has done yet, right? You're talking about how paleoanthropologists disagree. They do, but not on this. Or it's back to the drawing board. And creationists don't have an alternative hypothesis. And they can't deal with these ape men. They just keep saying, well, you can group them, but you can't. And so I have to ask, like, I don't think you have an idea on what an ape man would look like. I don't think any creationist does. But
if I could jump in, Erica, would you say that Ardipithecus ramidus would meet Jerry's answer would meet his requirements. It sounds like that's what you're saying.
If Jerry's saying that an ape man would be something that has more ape characteristics but a handful of, human characteristics, yes. By the time you reach Australopithecus, you've got far more human characteristics because they're all looped up in that bipedal locomotor suite. So yes, I would say that Ardipithecus would meet it if Jerry's defining it as something that has some human traits and lots of ape traits. And you could also appeal to Aurorian tugenensis for that, or Sahelanthropus chilensis for that, or Ardipithecus cadaba for that as well, but I didn't go over them in my PowerPoint, so I didn't think that there was a good reason to bring them up.
Okay, so with that, Jerry, did you want to interact with her example?
Yeah, I did. I understood that Neanderthals and non-Neanderthals interbred, and that's where I got my genes from. And people who are from the area of Europe that I am from commonly have genes from Neanderthal because we were able to interbreed. And normally you define a species, I know it's defined different ways, but normally you define a species if two animals can interbreed, as is true with dogs. And I know you brought that out. I had a student who bred dogs and bred a Pekingese with a little Mastiff. And no one thought that could be done, and a student said, yes, that can be done. It was done, and I have dogs that prove it. Not by deliberately, but that's what happened. And so since we can interbreed, that's where I got my Neanderthal genes from. People from the area of Europe where I'm from, my ancestors are from, have the Neanderthal genes because we interbred with. So we and Neanderthals are the same species. Now, maybe I misheard you, but I thought you said that they're different species. They're not. They're us. They're just like you and I.
So they're definitely different species, right? They meet the morphologic criteria to be different species, and while humans and Neanderthals could interbreed, because we don't have any mitochondrial Neanderthal DNA in us today, it's the best parsimonious explanation for that is that reproduction only occurred one way, which means that Neanderthals were in the process of becoming reproductively isolated. Now, if you accept that lions and tigers are separate species, which they can produce fertile offspring sometimes, then you also have to accept that Neanderthals and humans are different species because sometimes Neanderthals and humans could not produce viable offspring, as evidenced by the fact that we have none of their mitochondrial DNA in us today.
Okay, well, that's a new concept to me. I didn't know my ancestors, different species bred.
Yes.
So
yes, in the same way that like a coyote and a wolf can interbreed, but they're different species. In the same way that a lion and a tiger can interbreed, but they're different species. Or, a chimp and a bonobo, or an African and an Asian elephant. And this is why the biological species concept is so messy. It's great sometimes, but it doesn't work all the time. And that's why people have been arguing about species. I mean, Zakos et al. 2016 is a great book if you want to read about how people are like fighting over what species are and how there's no good definition for what a species is because evolution dictates that descent with modification will be a gradient. It's actually phenomenal confirmation of evolutionary descent with modification.
Let me jump in real quick. Since we are over 40 minutes in, Jerry, was there a question or a point in the discussion that you wanted to bring forth for Erica to engage, just to keep this fair and even? Jerry, was there a question you had for Erica on hominin fossils?
Well, not really. There's so much debate, I guess. I could ask a lot of questions and find out her view, but then I read somebody else and I find out somebody else's view. And I'm assuming, though, that as time goes on and we discover more and more fossils, we're more and more closer toward the one slide I showed where we have basically different groups of animals, of primates in this case. And whether these could interbreed, etc. Of course, that's not known. But again, my main focus is how do we go from one to the other? We have no clear means of being able to do that as a result of the claim, which is mutations.
Erica, could you, I appreciate that, Jerry, in light of your answer there, Erica, could you, or not, it's up to you, could you screen share a couple of the examples that you presented on hominins and get Jerry's opinion on some of the features in, let's say, Ardipithecus or Afarensis? You also brought up at the beginning of the discussion the hypothesis that Lucy was a pygmy. I'm not sure we really had much time to interact with that and get Jerry's thoughts on that. So maybe in the last 10 minutes or so, we can specifically focus on some of those points, Erica.
Yeah, so first of all, happy to screen share. I'd love to do that. And also, I'm happy to answer any questions that Jerry has for as long as he wants. Like, I don't want it to feel one-sided either. So if Jerry's, wants to go down a specific path with me, I'm more than happy to do that. Yes, let me share my screen again. And actually, if we do go down the pathway of Lucy being a pygmy, I do have a different slideshow that I have a picture from that I think will be helpful for making my point that that's not possible. Okay, so here we have a bunch of hominins. Donnie, which one did you want to look at?
I think looking at afarensis would be fun. I'm looking and monitoring both chats, your chat and my chat. We could go down the mutations route, which is the last point that Jerry brought up, but I would say 99% of the chat, which is over 2,200 people, they really want to see some interaction with the fossils, with the hominin. So I think to meet the satisfaction of our awesome audience, maybe let's cover some of that for the last 10 minutes. And perhaps Lucy, maybe go over some of the features of the pelvis and see what Jerry thinks of those features. See if they meet his criteria of
can I
8-man.
Yeah, let me pull Lucy up here. Pull her up real big down here so you can see just her. And keep in mind, or actually here we'll do this so we can see a nice comparison of 3 members of Australopithecus and Lucy. Since they're all members of the same genus, they all share the same locomotor pattern. That should look nice right there. Perfect. I think a lot of this is going to hinge too, and I don't know where Jerry stands on this. I don't know if does he accept that Australopithecus is bipedal, or does he suppose that Australopithecus was not bipedal? Either Lucy
Okay,
or
that's
the
a good
entire genus.
question. Dr. Bergman, what are your thoughts on the Australopithecines in general? You can focus on any one of them. Are they bipedal? Are they knuckle walkers?
Whether or not they were bipedal. From what I know, they're not much good evidence that they were bipedal.
Okay, so
relative to the percent, Lucy, I know they say that 40% complete or close to that, but that's when you have a part of a bone that you say, well, they have that bone. But when you weigh the bones, you're closer to 20? I can't remember the numbers. You're closer to 25% complete when you actually look at the weight of the bones that we have. And they can add bones from other Australopithecines and say, well, this is what Lucy must have had. But again, this is an assumption, whether or not Lucy indeed had that set of bones. But so when you look at the weight, when you look actually at the bones you have, it's a small percent. And as I mentioned before, the difference in bones between a chimp and a human is not that great. It's very, very similar. So we'd expect to find similarities as we see here in your illustrations, because modern chimps and modern humans, we can see are very similar in many ways. The major differences are what? The hip bones, the pelvis, the brain, and a few other differences. So there are differences, but nonetheless, the vast majority of the bones are quite similar.
Right, but specifically...
That's not the issue. So and what you're showing again is that a lot of these bones are similar. Yeah, they are.
But Jerry, this evolution specifically predicts that the differences that do exist need to be bridged in the fossil record, and that's exactly what we're seeing here, right? Now, the idea that Lucy isn't bipedal, that's impossible, right? Like, if all of these are members of Australopithecus, and they are, because this individual was found in articulation, and this individual's morphology matches the morphology of these two, meaning that they all belong to the same genus, Australopithecus at the very least, right? Then that means that these recreations, right, and these reflections down the midline, I mean, you've got a medical background, so I know that you know that humans, as all mammals are bilaterally symmetric. So looking at Lucy here, you have the entire left side of the pelvis, the whole sacrum, the whole femur, and then on the left side, you have the entire tibia, some of the toes, right? You have on the left side here, the entirety of the upper arm, the upper right arm, as well as some of the left arm and some fingers here. A lot of that weight that you're talking about is coming from the rib cage, which is actually not super informative when it comes to how a hominin moved. Now, the big thing that's missing on Lucy is the skull, and that's where a lot of that weight that you're talking about is missing from. But the problem with that is that we have the entire skull in one chunk in Australopithecus africanus over here, the entire skull in one chunk in MH1 here, and if I scroll up here to my big Australopithecus slide, countless others. And all of these match at the genus level in regard to their teeth, in regard to their face shape, in regard to their pelvis, in regard to their femora, in regard to their foramen magnum position and their arm length, right? Like, again, they're not all the same species, so there's differences, right? But they're all intermediate as locomotors, and in fact, they trend human. So there is no way, right, when you look at the measurements, this is raw data. When you look at the measurements that you take of all the bones in this critter's body, like whether we're looking here at the pelvis, where all the Australopiths lump closer to humans than they do with chimps, whether you're looking at the distribution of cortical bone, which, again, since you're a medical guy, I don't need to tell you that cortical bone distribution responds because of Wolff's law. So it remodels itself in response to stress. That's what tells us that Lucy, and we have, this isn't the only femur that we've cut in half to look at this, or CT scan to look at this, right? Lucy's is this one right here, just to be clear. That cortical bone is super thick inferiorly, just like a human's, and it's thin superiorly, unlike a chimp's, right? It looks like a human. So the femur looks human. And this, again, we don't have one femur. We've got tons of femurs ascribed to genus Australopithecus. The knee is valgus in nature. This thing definitively had a carrying angle that's more similar to humans than it is to chimpanzees. You can look at the foot. Australopithecus africanus, again, STW573, has an inline big toe right here. And I mean, again, I don't have to tell you, like, where the first metatarsal connects with our tarsals here. Right? There's not any ambiguity in that, right? Joints have to fit like kind of like locks and keys. So we know that this is the angle that it came off of. And this foot that I'm gesturing at with my cursor was with this hominin, the one that was found in complete articulation, or not in complete articulation, but in lots of articulation in one spot all by itself. And there's the foot down there at the bottom, right? Both legs, both arms, most ribs, both are a partial scapula on one side and a full scapula on the other, the full cranium. And we know what these things look like. And if you tried to make them quadrupeds, you know, what would end up happening is that it would be like you trying to walk quadrupedally or me trying to walk quadrupedally. We'd crank our necks like that all the time.
Okay, so in light of what Erica presented there, Jerry, do you see the Australopithecines as leaning more quadruped or bipedal?
Well, with the information she's presenting, of course, indicates that they're bipedal. But again, my concern is that is there evidence that that creature evolved into us? And that's the major concern. And of course, again, you have a lot of similarity in the bones. Modern chimps, as I said, and modern humans, there's a lot of similarity in the bones. So you see the same similarity here. So that's no different than the pictures I showed earlier of what modern chimps look like today and what modern humans look like today. So yeah, you have a lot of similarities there. I know,
Jerry, if I could jump in then, would it be, based on your answer to that question, would you say it's inaccurate for a young Earth Cretaceous to say that the Australopithecines were knuckle walking quadrupeds? So in light of this discussion here, would that be inaccurate? Does it look like that they are bipedal, or how would you respond to that?
Well, number one, there's a lot of debate in the paleontological community about whether they were bipedal
Jerry,
or not.
I promise you there's not. Like, I hate to interrupt you on that one, but that one point drives me crazy, and I hear it from creationists all the time. There is not debate at all that Australopithecus was bipedal. The debate is how often it was bipedal, right? So Stern and Sussman's famous 1983 paper argued that Lucy still spent, 50% of the time up in the trees, whereas Owen Lovejoy and colleagues argued that it was bipedal in the way a human is bipedal. That's the debate, not whether or not it was a knuckle walker or a quadruped or a permanently suspensory animal. There isn't a paleoanthropologist that I am aware of alive right now, and I have looked, that holds to that position.
Well, I can't give the names, but there are some that do. But again, either way, it still doesn't deal with my concern, is that how did this animal, this primate, become human? And that's true. You don't have many chimps today that are bipedal, but you have some that can walk for short distances on 2 feet. So,
but
Jerry, do you think any of the examples she's presented, let's say Australopithecus afarensis, Artie, Littlefoot, any of these, even Sediba, Do any of these meet the answer that you provided earlier on what an ape man would look like? And if not, why not?
Well, again, all we have is a skeleton, though, and of course, the key is at the end, the muscle structure, the whole outer body is not there, and so it's hard to make decisions based on this. I know relative to whether they're bipedal or not, that can be determined to some degree in the skeletal structure, but it's difficult to go from the skeletal structure to the whole animal, which of course we don't have, the whole creature, which we don't have, but there are. And so, at any rate, I know that a lot of the argument has been well, the shape of the pelvis, and there's debate about that, whether or not the pelvis that is found in your examples here is indeed the pelvis which you dug up. The problem is when you dig up fossils, you end up with fragments, and fragments have to be put together, and you end up with parts that are scattered, sometimes over very wide areas. Lucy, the claim is that parts were found here and 100 feet away, other parts were found, and 500 feet away, or some large number, other parts were found. So you end up with a large number of bones that you have to assemble together. And whether that's done appropriately is an issue.
Donnie,
I know that some of the bones with Lucy have been found not to be, I don't know how many, but several of the bones with Lucy have been found not to be part of Lucy, but part of another creature. I think there are 2 or 3 I've read.
Yeah,
they pulled out because they're not part of Lucy.
So there are a couple of issues with that though, right? So I'm gonna scroll down here to not that one. Where are we going? Okay, when you say fragments, when paleoanthropologists say fragments, oftentimes what I'm highlighting with my cursor is what they're talking about here. This is 1, 2, 3, 4, 5, 6, 7 fragments, and they fit together like jigsaw puzzle pieces to form complete molars, right? These fragments are not like recreated by paleoanthropologists. They fit together, and it's the pieces that you have that tell you about the animal, not the parts that are speculated upon, which, contrary to what I hear a lot of creationists implying, paleoanthropologists don't do a lot of that because you can't get published if you do. Now, with regard to Lucy's pelvis, your problem with that, though, is that we have more pelvis than just Lucy. So this is that individual that I keep talking about, STW 573. This is what was found, over 95% of an Australopith skeleton. And here's the pictures in situ. A hand and an arm with the hand clenched together as if in a grimace in death, right? Here's the full arm in one chunk with the humerus connected to the proximal portion of the radius and the ulna attached to the scapula. There's the head peeking up out of the block, right? There's no question that these bones belong to the same individual. And this individual, Australopithecus africanus, or STW 573's pelvis, looks like the pelvis of Lucy, which tells us that Lucy's pelvis is not a human pelvis, in addition to the fact that it doesn't have the morphology of a human pelvis, because even though it's very, very similar to a human pelvis because it belongs to a biped, it still has an iliac flare and a couple of minutiae that clock it as something that's unique, right? We know that all of these pelvis belong to Australopiths and not humans. They're unique in their own way, and we can compare them across specimens that are found in articulation. And this isn't even the only one. MH2 and MH1 also have articulation, and in the case of MH2, you have a lumbar vertebra, right? Or vertebrae, I always get the plural mixed up with them, that is in direct articulation with the pelvis, right? Which looks human. It's got a more human pelvis with a more Australopith-like lumbar portion of the vertebral column. So these things fit together like puzzle pieces, and sometimes they're even found in articulation with the bones still touching. There is no way that these bones, when they're present, like especially in cases like this, when they're presented, belong to humans, because there's not a human within 100 miles at that stratum. In fact, within the entire Earth at that stratum, to be honest. But even in these areas, they're found still touching. So I don't think that's defensible as an argument, that Lucy's pelvis might be artificially not Lucy's or might have been manipulated somehow in post, in prep, because it keeps getting confirmed by every subsequent pelvis, and we've got half a dozen of these things, if not more.
Jerry, what are your thoughts on
fragments?
that?
Yeah, your fragments, you can assemble them together. That's true. Often you can, and you showed a good example where that took place. On the other hand, often you can't. Often you can't assemble these fragments together. And often, therefore, you have to assume on what they look like if you have the entire bone. Therefore, it's the fact is that all too often you have fragments, and it's difficult to guarantee, indeed, that all of these belong to one creature, since often they are, from my reading of paleontology, often the parts are scattered in a wide area, sometimes in a very wide area. Rarely do you find all the bones together, nice and neat, in one grave, as if they were buried by somebody a long time ago and were not changed or shifted around since then. Because you find a lot of shifting of the dirt through earthquakes and floods and so on, and so therefore you find, and animals will often consume part of the body before it decays and becomes fossils. So I'm questioning that. Indeed, a lot of this is speculation, and there are problems, and paleontologists admit there are problems, and that's why they are so aggressive in criticizing each other, as I documented in my book, Apes as Ancestors, that indeed they're very aggressive in showing that this claim was made and it's not true for this reason. And so basically what we did in this book is we used the criticism of paleontologists, of other paleontologists, and that's pretty much what the whole book concludes. The whole book includes, and that is paleontologists criticizing others. And so we're not saying these problems are there. Other paleontologists are saying these problems are there.
Right, but Dr. Bergman, I've been in the field with many of these paleontologists that you're talking about. I've met many of them at conferences, and I've even worked with some of them in the field. And I can tell you that yes, fossils are oftentimes found, spread out over large areas, not miles and miles and miles, but yes, within a square mile or whatever, I guess that's possible. Not at any of the field sites I've worked at. All the field sites that I've worked at in Koru are very, very small field sites, right? They're, up one hillside, right? In the case of like Songkor, or right by a little area by a creek in the case of Chemtwara, right? Like these are not big field sites. We found last year an entire Diamantomys, which is a little rodent that's got a skull of about that size, and we found the whole thing still entombed in the rock, every tooth still in place in the thing's mouth. And once in they're not, the articulated stuff is uncommon, but it's not like so rare it never happens, as I've shown you many times in this discussion, right? And it's not the fragments that these paleontologists are building their case off of. It's the stuff that isn't fragmented. And finally, I hear you on paleontologists disagreeing with each other, and sometimes even with themselves in the past. That absolutely happens. That's science. That's science operating how it should. But one thing that, and I'm sure you found this when you were doing your research, the stuff they're agreeing on is the minutia. Is this individual Australopithecus africanus, or does it belong to Australopithecus prometheus? Is it ancestral to Australopithecus sediba, or is Australopithecus sediba actually more closely related to Australopithecus africanus? Which is the ancestor to Paranthropus robustus? Like, these are the kinds of questions that they quibble over, and they'll go back and forth for decades on the answers to these questions. But one thing that no paleoanthropologist alive right now is going to argue with you about is the nature that Lucy was bipedal when on the ground, and when I say Lucy, I mean her genus, Australopithecus, and that humans evolved from Miocene apes over 7 million years, and that we can see the emergence of the human-specific characteristics through dozens of hominin species. Those are two things that you will not find someone arguing against, right? And so that's what tonight's debate topic is about. So hearing you say that paleontologists disagree about this, that, and the other thing, I know, right? Like I had to take my comprehensive exams on that. But for the purpose of tonight's debate, no, not at all. And again, the case isn't made on fragments, it's made off of skeletons, partial skeletons, skulls, maxillas, mandibles, partial femora that have the portions of the bone that are informative intact.
Okay, part of my response is that you see the world with evolutionary glasses. The glass is how you see the world. And you see, of course, most paleontologists will see certain things a certain way because they have that mindset, they have that perception, and therefore they see the world in similar ways because they have similar worldviews, they have similar perceptions, they have similar perceptions of reality. And it'd be nice if you had some well-known paleontologists, and there was a few in the past. There was one recently who just unfortunately died recently, but there are some paleontologists who don't have those glasses on, and they see things differently, and they come up with different conclusions. And so it'd be nice to have some that are not true believers as part of the club. And unfortunately, you probably know more of this than I do. Unfortunately, as far as I know, there are no paleontologists that are not members of the club. They're all members of the club. Therefore, they all see the world through the same glasses. They all see the world in the same way, and therefore they agree on things because this is how they see the world. So it'd be nice to have some paleontologists that were not evolutionists that could see the world in a different way. And I'd be curious to say what they thought about some of these. Now, I know in the past there were some, and when I corresponded with them, they indeed saw things in a very different way and had a very different opinion about some of these things that you say there's unanimous conclusion. Yeah, there's unanimous conclusion on some of these things because, as a friend of mine found out, if you don't conclude with the zeitgeist of paleontologists, you're not going to be part of the club. You're going to be kicked out of the club. And there have been a few paleontologists, by the way, that have been kicked out of the club. And so therefore, to be part of this cadre, you have to agree with the basics. And the basics include there was a common ancestor, and from that common ancestor, through a series of evolutionary changes, we ended up with humans. And that is a belief, which is a belief and held to. And it'd be really nice if there were people who were part of the club but did not share that worldview. You had some differences in worldviews. And Barton, you may know.
If I could jump in, and just to keep this discussion as comprehensive as possible, and then we'll shift into our closings and then questions, because we've got about 40 years worth of questions here compiled. So get that pot of coffee on. And so to keep this as thorough as possible, I'm going to pose a question, and then Erica, feel free to engage in. Same with you, Jerry. But we'll start with Jerry. In light of what's been said, in light of the topic, do hominin fossils support human evolution? What if Erica were to say, and then correct me if I'm wrong, Erica, if you wouldn't say this, that's fine, let me know, that finding a bipedal ape or primate in the fossil record, like Australopithecus prometheus, let's say, Littlefoot, which is largely complete and articulated, if I understand you correctly, Erica, is a necessary prediction and find of human evolution. As in, if human evolution is true, this is what we should find. We find it, therefore that supports human evolution. Would that be a correct way of iterating it, Erica?
Yes, I think that's fair.
Okay. Jerry, how would you respond to that point?
Yeah, that would be a correct way of articulating it. But on the other hand, one may have a prediction and one may find evidence for that prediction, but that doesn't unequivocally prove indeed that this prediction was, that this belief was correct. And in medicine, we don't tend to predict much. We don't tend to follow the so-called scientific method. In medicine, what we tend to look at is we've got a drug works in a certain way. Therefore, we don't say the prediction is the patient will get better, but we look that the patient will in some way improve, or the symptoms will be less, or something else. So we have an understanding of the body. We use a medication to either upregulate or downregulate some gene. And when that happens, we find the patient feels better, gets better, or gets worse, or has no effect. And so basically, you're not looking at a hypothesis and finding out whether or not that hypothesis is fulfilled by some prediction. You're looking at the essential results. And I think, I know that science, they push this idea, but you have a theory, you have a hypothesis, you look for evidence, and you either confirm the hypothesis or reject it. But there's a number of studies done by people who looked at scientific advancements, and they didn't work in this way. One basically said, science works by dreaming, by thinking about some possibility, and then looking around that theory, that possibility, and then coming up with insight, and the insight led them to the final decision relative to whatever they were looking at. So I know that's ideal. Every student we have in college, we got your hypothesis, we've got your evidence. You either confirm the hypothesis, you reject it, you modify the hypothesis, etc. But in fact, in science, and at least in the areas I'm involved in, that's not quite true. You're looking at other things, and it's not quite, you have a theory and you test it. You basically have ideas and you reason with them relative to what you know. And that's kind of vague, I know I mentioned, but on the other hand, you take a number of people who are very, very successful in producing producing a transistor that works. It's not, you didn't start out with a hypothesis and tested it. Basically, it was creative. You thought about what's going on, what is possible, and what can be done, and what can't be done. And through trial and error, basically,
Okay,
trying to get a solution.
Okay. I appreciate that response. Jerry, Erica, feel free to have the floor and respond. Go ahead.
Yeah, sure. I mean, I feel pretty good about the fact that, Jerry's response to the idea that we made this prediction ahead of time and then we found everything that we were looking for after outlining it beforehand, following the scientific method as it's been outlined, since the scientific revolution in many ways. I feel very good about the fact that Jerry's response to that was basically saying, well, sometimes you don't use the scientific method to find true things. Because to me, what I hear when he says that is, yeah, okay, maybe it is a pretty accurate prediction that has come to fruition, at least at present. And I know that he needs to take the time to go and look all this stuff up, because it's hard when somebody is showing you a ton of data in the middle of a debate and you can't look it up on the spot. I get that, and I've been in that position before. So maybe it'll be the case that Jerry will go and look all this stuff up and he'll have a response to it. We'll see. But at present, what I'm hearing is an acquiescence that yes, it is an accurate prediction, and at least for the purposes of this debate, the hominin fossils do support human evolution according to the typical scientific method. I feel like I've heard Jerry agree with that. Am I reading you wrong here, Jerry?
Yeah, basically you're correct in what you're saying, yeah.
Okay.
You have a hypothesis and you've proven this with a finding. But my question is, does that prove that indeed we evolved from the goo to you by way of the zoo?
I'm curious for myself in either that both sides of the equation are using the best and most up-to-date arguments available and possible in light of all the data. Jerry, in light of what Erica has presented and argued, and her comparing these other Australopithecines like Australopithecus prometheus and these examples of, let's say, the pelvis, that again, Erica, correct me if I'm wrong, matches up pretty good to the reconstructed Lucy pelvis?
Yes. So within the genus, which is, I'm not saying they're the same species. I'm saying that we know that Lucy's reconstruction is correct, not just because of SCW 573, but also because of other pelvies that we have that are partially or fully complete, including several other members of Australopithecus africanus that I didn't even touch on in this debate, Australopithecus sediba, and other partial pelvies from other closely related hominins.
Okay, so from other pelvies corroborating what we know about the Lucy pelvis, Jerry, in your opinion, do you think it's a good argument or a bad argument to say that the Australopithecines in general were bipedal or knuckle walking?
I think there are problems to come into a conclusion to whether or not they were fully bipedal or partially bipedal or knuckle walking. And I know there's different positions on that, and you can have a hypothesis, you can confirm it, but that doesn't mean your basic worldview is correct. That doesn't mean that indeed certain things you expected, they could have a hypothesis that this hominid was not bipedal, and therefore, or on the way to becoming bipedal, and therefore had some traits that would indicate in the future these traits would change in such a way to where it would become bipedal. That's true. So that's not...
Okay. Well, I appreciate you both being willing to engage my clarifying questions. Erica, since you get the first closing statement, if there's anything there you want to respond to, perhaps do it in your closing statement. We do have 5 minutes each, so we do have a good opportunity in light of everything discussed, which was a lot. This was thorough. And again, I appreciate the visuals on both sides to help myself and the audience follow a little better what is being debated and engaged. So 5 minutes to wrap up our thoughts, wrap up our points, and essentially land the plane, bring everything home for tonight, and give our audience the best possible representation of tonight's viewpoints. So Erica, whenever you're ready, please let me know.
Yeah,
I will reset the... Sure, take your time.
Let me get my timer up here because I'm always running over. Now, I actually had a version of this PowerPoint that when I was about halfway done with it, I I hit 17 minutes. So I was like, okay, I got to shorten this PowerPoint up a little bit and get a little tighter. Brevity is not my strong suit. So I got to keep myself in mind with my timer. Okay, I've started. Okay, I feel very happy with how this debate went in the sense that I said what I needed to say, and I feel like Jerry just kind of agreed with me that in the sense, not in the sense that this proves evolution, right? That's not what the title of the debate was, though. The title of the debate was, do the hominin fossils support human evolution? And what I heard from Jerry, at least in this past, the little exchange that we just had now, is that yes, they do. As scientists have laid it out, and as they laid it out from Darwin to Haeckel to Eugene Dubois, all the way up through our paleoanthropologists like Raymond Dart, and into the Johansons and Leakeys and so on and so forth, like all the way up through that, right? These predictions are being made over and over and over again. They keep coming to fruition. The details change because that's how science works. But overall, this resounding theme that we see in the hominin fossil record from Miocene apes roughly 7 million years ago, all the way up to anatomically modern Homo sapiens, we see the characteristics that make humans humans emerge slowly through geologic time in mosaic specimens, in mosaic bones, in mosaic species, in mosaic genera, right? And you know, I'm very happy to hear that Jerry at least was on the same page with me that, yeah, like according to the predictions set out, that's what we're finding. I don't think that proves evolution, but that's because I don't think you prove anything in science. That's another part of the scientific method that's super important to remember, is that science isn't about proving anything. You can only fail to reject something, right? And we have been throwing everything and at the freaking kitchen sink at evolutionary theory to try to falsify this thing, to try to show that it's incorrect. And a lot of that has come from creationists, and we've been unable to do it. Over and over and over again, we've been unable to do it. Especially with the fossil record, because that's what I'm most familiar with. But when I talk to people who are in genetics, whether it's PopGen or biomedicine or agriculture or any of these fields where evolutionary biology is really important and is used in the day-to-day as far as basic principles go. I mean, I listened to Dr. Bergman's debate with Chris Thompson the other day, and they were talking. Chris was talking about how you use mutation and natural selection in designer drugs, right? I didn't even know that. I thought that was insane. So evolutionary biology is a really critical part of biology and understanding it. And I get that Jerry does cancer research, and maybe it's not there, but it is in other areas. And I think that talking to people who do that work robustly supports that. So hearing a concession that the hominin fossil record does in fact support human evolution makes me feel good about my presentation, because all I really wanted to show is exactly that. There are a ton of questions that we still have about human evolution. But do these hominins show like the human characteristics emerge slowly over geologic time is not one of them. Australopithecus being a bipedal hominin is not one of them. The nature of the common ancestor of humans, chimps, and gorillas is like, how did that thing move? We don't know the answer to that. So certainly there are open questions, and that's a question that I'm super interested in myself. But all that being said, I don't really think that I have anything more to add. I feel very happy with how this debate went, and I'm excited to hear some questions.
Erica, thank you very much for that 5-minute concluding statement. I do appreciate it. I will reset the timer and hand it to Jerry. Jerry, you also get 5 minutes for a concluding statement. And I will start the timer now. Go ahead.
Okay, my concern is you may have found fossils, various means of identifying them, various theories relative to them, but I'm saying that it's limited in trying to show whether or not indeed evolution occurred. And a good example is I wrote a book called Fossil Forensics. And what I did is looked at the evidence for evolution of insects, of mollusks, of a variety of organisms. And I found clearly the fossil record, or what record we have, does not show any evidence of all of the categories that I looked at. For example, insects. We have tons of insects in amber, and ironically, pretty much all of them look like modern-day insects, even though they are so many thousands, whatever, years old. And other areas that I looked at were, when we talk about human evolution, one problem that evolutionists have had is the evolution of sex. And I've read 4 or 5 books trying to deal with the fact of evolution of sex. And again, you're not going to be able to tell much about that from the fossil record. But again, they are stymied as trying to understand how indeed sex could have evolved, how you end up with reproduction requiring two individuals to unite and form a zygote and that to be successful. It cannot be successful until all the parts are there, all the parts exist. And another example is eukaryotes, evolution from prokaryotes to eukaryotes. I've spent a fair amount of time looking at this, and they're simply the endosymbiosis theory proposed is severely problematic. We have no clear idea how prokaryotes evolved into eukaryotes. And there are many other examples of these questions which are not answered. So it's true in human evolution, you've got lots of fossils and you can make lots of claims, but as a whole, they don't support the idea of evolution from, from molecules to man. And indeed, if molecules to man evolution is not true, then you simply have to explain these findings in other ways, which is what I do. I have to admit, in looking at this question for a number of years, a human fossil record, I became more and more discouraged because there's so much disagreement. There's so many questions, so many theories proposed and found not to be true. Indeed, all too often we're arguing about small things, which indeed don't really address the basic question. And that question is, can molecules evolve into humans? And therefore I moved away from that and into other areas, which I find is more fruitful. And a lot of focus has been on human evolution, of course, because that's pretty important. But on the other hand, the material you presented, I can understand where you're coming from. But when you look at this in more detail, as Peter Line and I have talked about, there's a lot of problems with concluding, indeed, that these variations you found in the fossil record prove leading from some primitive primate to humans. And this is one reason that the progression, which has been by far the most well-known picture of human evolution in the past 30 years, why indeed that progression has been rejected. It was rejected for the simple reason that the fossils don't support it. What they support is a large variety of primates, and indeed enormous variety of primates, but they don't support a progression from some very primitive primate into humans. And that's well acknowledged in the paleontological world. Although they believe in that it is there because they believe in evolution. And therefore they wear the evolution glasses and they see the world through those glasses and they distort the world from, it's very clear they distort the world because they see what they want to see. And the reason I brought up the evidence they had for evolution in the Scopes trial days was they believed in evolution fully, and that's why all of the arguments they used we now recognize as embarrassing, clearly embarrassing, because they're simply not true. When you've proven not to be true. And again, I think that in the long run, evolution themselves will prove evolution is not true. And they've already done a very good job of that in many areas. And that's my conclusion. So,
Jerry Bergman, thank you very much for that 5-minute concluding statement. Erica, Jerry, excellent endurance tonight debating the question, do hominin fossils support human evolution? I am sweating here getting all of just the hundreds of questions that have come in on both ends. Erica, you've got like 2,000 plus people in your live chat. And so between both live chats and the questions that have come in, we will be going until about same time tomorrow or until you both or one of you fall asleep. So why don't we do this? We'll get through as many super chats as we can until we've reached a reasonable time to shut it down. My faithful chat mods throughout the first 2.5 hours of this epic event have done a good job notifying the audience that we're only asking super chat questions. And super chat questions for this debate, since we have so many, basically just give you a really good chance at getting your question engaged. But it's not a guarantee like we usually do. So maybe power rounds here and there, depending on what the question is. And I'll try and get a pretty good balance of questions for you guys, Erica and Jerry. So
Donnie,
Erica, your husband.
Yeah, do we want to like tell them no more, or do we want to let them keep going? Because I think they're just going to keep going if you don't tell them no more. So it's up to you.
I would say at this point, no more.
All right.
So
I'll
even
tell
the
them
one
on
that we have,
the clock or
you know, for poor Jerry, it's past his bedtime. You both have done a great job tonight. I've really enjoyed this. So to the audience, let's stop the super chats now. We're going to deal with what we have here, get through as many as we can. Erica, your husband's done an excellent job sorting through a lot of the super chats. Oh, he's had a tough job, but he's done well.
He's a pro.
So he's getting a
professional.
promotion here.
He also brought me more water when I was so thirsty because I ran out about halfway through. So he's a superstar.
You got to have lots of water for these debates.
Oh, yeah.
So it's very nice of him. Okay, I'm going to get a question up here from my end as I move the questions from Erica's end into our live chat to put on screen so people can see the questions too. Okay, here we go. Let's start at the beginning. Creationist Crybaby, good to have you here in our live chat tonight. I hope you've enjoyed this debate. I know I have. And Jerry, the question's for you. So the first question's for you. Here it is. Jerry, Lucy's humerus to femur ratio is 84.6%, which is intermediate between modern humans, which is 71.8%, and chimpanzees, which are 97.8%. What kind was Lucy? Go ahead, Jerry.
Yeah, don't have that data in front of me. I have no idea. I know humans vary in height from 2 feet to 2.5, 3 feet to 7 feet, I guess, some people. So we have a lot of variation. And I have no doubt that Lucy's kind had a lot of variation as well. So it happens to be that number and some number. And that's not a number that I keep track of.
So when Krish's Crybaby asked what kind was Lucy, Jerry, are you saying there was one Australopith kind or there were many Australopithecine kinds, or how would you view that?
Well, Lucy was Australopithecus afarensis, I believe. And at least unless it's changed. And that's the classification. And I have no problem with that classification. And so that's fine.
Okay. Erica, any thoughts?
Yeah. The reason it's intermediate is because Australopithecus afarensis is the best candidate right now for being ancestral to genus Homo. So that's why, because we're seeing an increase in the efficiency of bipedalism, and that includes a more human-like limb ratio.
Thank you, Erica. Jerry, any final thoughts since the question was for you?
No, it's an interesting fact, but it doesn't really prove that hydrogen evolved into humans.
Okay, thank you very much, Jerry. Next one's for you, Erica. Short, sweet, and an easy one. Veeks, $5. Appreciate you supporting this debate. I want to know if Erica has read The Last Neanderthal by Claire Cameron and thought.
Yeah, I have not. I would love to read that, though. I've heard it's quite good. I've got a large, I'm sure everybody in this room probably feels the same. We've all got a large backlog of books waiting to read. So I'll add this one to the list, though. Thank you for the recommendation, Veeks.
Thank you very much, Erica. Jerry, have you read that book?
No, I haven't. I have a lot of books on Neanderthal, but it's been swamped with them. There must be 100 books written about Neanderthals. And I guess I need to add that to my list as well.
I'm sure all three of us have far too many dust collectors in terms of books that we need to get to at some point. Okay, here's another one. Touchpad 50 SEK. Again, thanks for supporting tonight's debate. Could anyone please tell me, this came in from your chat, Erica, where the line between full ape and full human is drawn? And so I feel like it's kind of more directed at Jerry. Jerry, why don't we start with you?
That's a very good question, and I cannot answer it. And I think to answer it is going to be difficult. And that may be why he posed this question. I know enough humans that I really wonder. In fact, historically, if you look at the medical field that studied humans that deviated from the normal human, we find that some were not full human. Some had ape traits, and behave that way. Of course, some examples where the body had 8 traits, but not necessarily the person. But there are many examples, especially these examples were used in freak shows, which were common in the past. And many of these cases they used, many of these people they exploited, indeed had traits that were very monkey-like, very ape-like. And they were exploited for that reason, that they were able to make a living and sideshow freaks.
Thank you, Jerry. Erica, any thoughts?
Humans are apes, so there is no real line between a full ape and a full human, but we all know what we mean when someone's asking this question. Is there a difference between, like, something that is fully a Miocene ape and something that is fully a human? Characteristics change, but you can't out-evolve your clade, right? So there's definitely a difference between, like, genus Akembo or genus Rhodopithecus and genus Homo. And for me, for my money, if I had to place the line on, like, the perfect transitional species, it's going to be right in that area that is famously difficult to categorize, of late members of Australopithecus and early members of genus Homo. So no one can tell you where that line is drawn because the line doesn't exist.
Thank you, Erica. Jerry, would you like a final word?
No, we can move on.
Okay, appreciate it. Erica and Jerry, let's move on to the next question here. And this one comes in from Jackson Rowe. Jackson Rowe, thank you very much for the super chat and the question. I think it's probably for you, Jerry. Let's see what we got here. Are humans mammals? If so, why not animal? And why not primates? Accidentally sent a freebie before I never send these. Jackson, appreciate the question and the freebie. Jerry, any thoughts?
Yeah, humans are mammals, of course. The classification which is used labels them as mammals. They're also primates, and primates are mammals. And why not animal? I'm not sure what he means by that, but we're animals, and we have those 3 categories in common.
Thank you, Jerry. Erica, floor is yours.
Yeah, I mean, in that same way, humans are apes, right? We're members of the family Hominidae and the superfamily Hominoidea. So in the same way that we have the suite of characteristics that denotes an animal, a mammal, and a primate, we have the suite of characteristics that further denotes, like, an anthropoid primate, a catarrhine primate, a hominoid primate, which is an ape, and a hominid primate, which is a great ape. So humans meet all of that criteria, which is why as a primatology graduate, it gets under my skin when we're talking about the ape-human difference. It's like saying the dog-canine difference, at least from a taxonomic standpoint.
Thank you, Erica. Jerry, quick final word.
You mentioned taxonomy. There was a book I read. I can't remember her name, but she's, I think, Chinese and did an excellent job on taxonomy. And that book changed my life. I realized that taxonomic distinctions are very difficult to make, and she did a good job showing indeed how and why they were difficult to make. It was a long book, thick book, but the idea of taxonomy, which to me was pretty clear for most of my life, after reading that book, she helped me understand that, there's a lot of ifs, there's a lot of questions, there's a lot of, depends on the taxonomist, depends on what your goals are, depends on what glasses you wear, etc., to make the distinction between various taxonomies. And I just can't remember her name, but I think she's Chinese or Japanese, and done a beautiful job. She had her doctorate in taxonomy, and her frustration with the whole field caused her to write the book, and she did a good job. Dethroned the taxonomy classifications.
Thank you, Jerry. Okay, let's get one here for you, Erica. We can't have Jerry having all the fun here for the Q&A. So we got Wesley Coleman. Wesley, thank you for the super chat, support, and question here for Erica. $20. How do specific complex similarities like bipedal anatomy, certain cognitive skills arise convergently in primate evolution when the overall genetic makeup of lineages is diverging due to largely random processes like drift?
Well, cognitive skills has evolved like convergently several times in primates and several times in mammals, and that's because it's like pretty good to be smart, right? It's hard to be in a specific niche where that can be selected for, but when you check all of the boxes, you're a social animal, where you're living in groups, where it's beneficial to be able to keep track of all your kin, and you need to problem solve and navigate these social systems adeptly because you live in a hierarchy. We tend to see intelligence and complex cognitive skills evolve in those taxa, so that's why you see it in like crows, you see it in cetaceans, so whales and dolphins, you see it in proboscideans, and of course you see it in many, many primates. But not all primates are brilliant. In fact, lots of primates are very, very dumb. They're smart for mammals, but dumb for primates. Things like Colobus goriza, unfortunately, many of the lemurs, sometimes callitrichins, but I think they get a bad rap, and howler monkeys for sure. As far as bipedal anatomy, as far as we know, it's only evolved once. Now, it's not going to surprise me if it turns out that some other Miocene ape was moving in that direction because there was such a massive environmental shift happening at the end of the Miocene during the Valesian crisis. So it wouldn't surprise me if that ended up happening, but there's no evidence for it right now. And those processes for those specific characteristics that you just mentioned, those are not arriving by drift. Right? Drift is certainly at play and is responsible for a lot of differences genomically between these major groups, but ones that are being selected for or against, those come about by like natural selection, or natural selection having couched within it things like sexual selection, acting on natural variation within a population.
Thank you, Erica. Jerry, the floor is yours if there's anything you want to add.
I agree with her points. Some apes are appallingly stupid from our standpoint. And you wonder why, natural selection, of course, works, obviously. The problem is not the survival of the fittest, but the problem is the arrival of the fittest. But on the other hand, I'm amazed that some apes haven't become extinct because of some of their behavior that they manifest is appalling. And you think that natural selection would remove some of this behavior that is common among certain apes and doesn't favor their long-term survival, which is why a number of apes are threatened with extinction, which is tragic, and I think we should help to prevent that, like gorillas. I think gorillas are wonderful creatures, and we need to do what we can to make sure that they don't become extinct. And so, good point, Erica.
Thank you very much, Jerry. Erica, you get the last word. Question was for you.
Last. I love gorillas, so I concur with Jerry on that, and we should do more to save gorillas. But as somebody who's been outsmarted by one of the dumbest types of apes, which is unfortunately a gibbon, I maybe I need to raise my personal standards so that I'm not making it into the dumbest group of apes.
All right, thank you very much, Erica, for the final word. And okay, here's one from Joe King, $20 super chat for Erica. Can you give a list of characteristics that differentiate apes from other primates and show how they also apply to humans?
Yes, that's a phenomenal question. I've been hoping somebody would ask this because I didn't have an excuse to go through it. So if you take all the catarrhine primates, so that's old world monkeys plus apes, and you ask the question, how do these guys actually group out, and don't take humans into account at all. The characteristics that group the apes together, again, we're not including humans, are no tail, right, as compared to the old world monkeys, which have long postanal tails. A short, stiff lower back. This is because apes are extremely mobile. We're talking gibbons, we're talking orangutans, we're talking chimps, we're talking gorillas. All of them are very flexible animals. They've got flexible shoulders, flexible wrists, and that's because of the way that they move around in the trees is very different from how most monkeys do it. Apes also have very big brains for their body sizes, even for an anthropoid and even for a primate and even for a mammal. They have really slow development time as well. And they also have long arms compared to their body sizes. And humans actually fall into this as well. I'm a pretty tall lady, so my wingspan is kind of enormous. And my husband's a rock climber, and his wingspan's actually quite big as well. So our arms aren't long compared to our legs, but they are long for a primate. So those are the characteristics that take all of the apes and make them, when they're found all together, make something an ape instead of an old world monkey, which are separated out by like bilophodont molars and the presence of ischioclosities and extreme sexual dimorphism and things of that nature. So then when you ask, do humans, which are primates, which is something that Jerry agreed with, do we fall into the group Hominoidea, which has that group of 5 characteristics that I just listed, or do they fall into the other group, the Cercopithecoids? The answer is they fall into the hominoid group. There is no third group. There's no way to separate out the apes from the old world monkeys and not have those characteristics also applied to humans.
Thank you, Erica. Jerry, the floor is yours. Go ahead.
Well, I can see there's a similarity between us and other primates, but on the other hand, you may label us a primate, but there's a world of difference between us, as anyone knows, and chimps. Are supposedly our closest ancestor. A world of difference between the two creatures. Similarities, but on the other hand, there are many similarities between humans and dogs, humans and horses, and many similarities between us and chimps. In many ways, there are more similarities between us and dogs than there is between us and chimps. And chimps are a different world. There's a chasm between chimps and humans. And I think, unfortunately, evolution blurs that somewhat. And I have got a whole book I haven't read yet. I should get to it, but it basically talks about the differences between humans and chimps. And it's 900 and some pages. That's why I haven't read it, but it goes into great deal of detail showing indeed there's a more than a chasm, an enormous chasm between us and chimps. In fact, a larger chasm between us and chimps than there is between most other types of mammals, at least.
Thank you, Jerry. Erica, you get the last word. Go ahead.
Yeah, sure. I got my master's in primatology. That's simply not true. The difference between humans and chimpanzees, like genetically or physically, we share more with one another than many, many, many pairs of animals that creationists accept are related. There are also many, many differences between humans and chimps, just like there are many, many differences between a house cat and a lion, and yet they're both still cats. Humans and chimps differ in a lot of ways, but we're both still apes. The way that taxonomy works is you go from broad to specific. We don't share the most specific category of species with chimps, and we don't even share the second most specific category with chimps, the genus. We do share the third most specific category, in a very basic sense, which is the family level with chimpanzees. Again, we share more genomically with them, and I've done this myself over and over and over again. We share more genomically with chimpanzees than they share with gorillas, than they share with orangutans, and that mice share with rats, or African elephants share with Asian elephants, right? So yeah, there's huge differences, but that's not helping the creationist case here, because there's far, far, far more similarities than there are differences on the physical level.
Thank you, Erica. Okay, next one here is for you. Jerry comes in from Planet Peterson. $5 super chat. Appreciate the support. And here's the question. Jerry, if human evolution were true, what would the fossil evidence look like? What kind of fossils and specimens would we see? Please be specific. Jerry, go ahead.
Well, I suppose if evolution was true, many of the fossils we found are probably what we'd expect to find. We find animals that have traits of humans, and we find animals that have traits of other primates. Therefore, yeah, I think what we find in the fossil record is pretty much what we would expect if evolution was true. But that doesn't prove evolution is true. That simply proves that there are similarities. And there are similarities between us and other animals where there are not the same similarities between us and chimps. One thing when we look at humans, we look at other animals have traits well beyond humans, like dogs and smell. If we put a teaspoon of sugar in a swimming pool, the dog can smell it. And so the smell of dogs is far superior to humans. So we're different in some ways, but inferior in other ways as well.
Thank you, Jerry. Erica, the floor is yours.
Yeah, humans and chimpanzees have similarly sized olfactory bulbs because we share common ancestry. Apes can't smell well. A reduced sense of olfaction or smell is actually one of the characteristics that defines a primate to the exclusion of other mammals. We've traded off smell for sight. That's why most primates see in vivid color, just like humans do, whereas dogs and cats and most other mammals in general don't. So that's just using that dog reference as a way to say it's also another way that humans and chimps are very, very similar. And that reflects genomically, too.
Thank you, Erica. Jerry, you get the last word.
When you talk about eyesight, though, there are many animals that have good smell and good eyesight. I guess the best example is, I can't think of an example now, but there are examples of animals that have incredibly good eyesight. Birds, for example, can see a wider range of frequencies than humans can. And so you do find some animals have, well, what an owl, I think, can see a mouse at 35 yards away, or even farther than that. So their eyesight is much, much better than ours. I'm not sure about the smell of owls, but on the other hand, compared to many animals, our eyesight is not all that good.
Appreciate it, Jerry. Okay, next one here comes in from Robin Webster. $5 super chat. Appreciate you, Robin, supporting tonight's debate. Question for Jerry. Do you accept that all dogs evolved from wolves? How do you account for the diversity? The mechanisms are clearly stated in the theory. Go ahead.
When you're talking about evolved, I'm talking about mutation and natural selection. Yes, all dogs, I would say, came from wolves. And therefore, because wolves has an inbuilt system which produces a great deal of variety. Wolves, horses, cats, and other animals, camels, produces a great deal of variety. But this is not evolution. This is simply variation within a certain kind of animal. And other animals do not have that ability. And therefore, we try to breed other animals to produce variety, like we've done with wolves and other animals, and we've been failed in doing it. And so, therefore, some animals have created within them a system which allows a great deal of variety to come from that single animal, single wolf in this case. And so that is, you can use the word evolved, I suppose, but on the other hand, I would not use the word evolved because it did not change according to evolutionary theory, which you're talking about mutations and natural selection. It changed because of breeding abilities and different environmental factors and so on. And that's true with a number of animals, but I would say not most, but a number of animals it's true with. That they indeed, from one wolf, we can get the 200 and whatever breeds of dogs that they claim exist today. And more, by the way. We have a dog which is a combination of two other dogs, which is a unique breed. It's a Cavapoo, which is the unique breed, which is very different from many other dogs, and certainly very different from a wolf. But nonetheless, my guess is if we keep breeding the way we are, we're going to end up with 500 or 600 different breeds of dogs. But we've done that. Evolution has not done that. And probably if there were no men around to protect dogs, my guess is we'd end up with most dogs becoming extinct, and the only dogs surviving then would be wolves or coyotes or some other animal like that. So most dogs that we have today could not survive very well in the wild.
Thank you, Jerry. Erica, over to you.
Yeah, I mean, natural selection is just artificial selection taking longer and done by nature, and we all agree that that's something that does happen. So it depends how much change can actually occur. It really depends on the time frame you're looking at, which is another question entirely. I mean, evolution and natural selection are definitionally evolutionary mechanisms. Like, evolution doesn't exist without those two mechanisms. So I would say yes, dogs evolved from wolves, and in fact, we see evolution in real time because it's just changes in the frequency of alleles in populations over time. I think the issue, what Jerry's getting at, is that the issue is common descent, which is that's a part of evolutionary theory, but evolution is something that virtually all creationists do accept to some degree.
Thank you, Erica. Jerry, did you want a final word on that one?
No, I agree that again, as an in-based system, which some animals have and some animals don't. And if we can understand that system better, well, there's a lot of animals around today we would like to breed and to produce the differences that we see among dogs. But we can't. So there's limits. You breed artificially, and you reach limits very quickly on, I would say, most animals.
Thank you, Jerry. Okay, we got one for you, Erica. This comes in from Beyond Doubt Theology. $10 super chat. Appreciate the support. Here's the question. If a modern or very late human fossil is discovered that predates fossils like Lucy, would you rethink your position or say the split happened earlier than previously thought?
I mean, if a modern human was found if we're talking Australopithecus, the genus, then we're talking earlier than 4.4 million years ago. So yes, I would definitely rethink my position if we found a modern human 4.4 million years ago. It would have to be robustly supported, though, as tends to be the case when you're presenting something that completely goes against the paradigm within science in general, right? But yeah, I would totally be open to that. I've gone down rabbit trails on a couple of claims of that, and I have never once encountered anything with any substance whatsoever, but I'm always willing to look at stuff like that. I would not say the split occurred earlier than previously thought if you found a anatomically modern human before Australopithecus 4.4 million years ago, because I would propose that, 3 million years of time, that's pretty short. I mean, you would have to find, what you would have to find then, here's the answer to your question. What you would have to find then to salvage it would be a member of Australopithecus found even earlier. Like, you would need to basically show that all the fossil record that we have now is late surviving members of their respective clades. And if they showed up even earlier, then you'd probably be fine. But if things as it stood right now, yeah, I'd have to rethink my position for sure.
Appreciate it, Erica. Jerry, the floor is yours.
Okay, if they found a human fossil that predates fossils like Lucy, there's something wrong. There must be fraud involved. They simply would not accept it. And I know cases in the past, they claim, where something like this has happened, and they simply could not convince the scientific community that indeed this is what we found. And well, it could not be true. It could not be valid. So therefore, it's either a forgery, it's a fraud, or you have mistakes in whatever. And so it would not be accepted for a number of reasons. It's very unlikely to be accepted, primarily because it just couldn't be true. So therefore, it would not largely be accepted. And in the past, there have been finds like this. I can't really recall any directly because obviously these have been suppressed, but people have claimed to find things of humans that predated Lucy, and they simply were not accepted. And it was hard for them to get a hearing because it just couldn't be true.
Thank you, Jerry. Erica, you get the last word. Go ahead.
Yeah, I'm aware of some of them, and science puts the screws to anything that changes the paradigm, and if they don't hold water, they don't hold water, right? I mean, I'm in the scientific community, and I just said that if you could actually show that there was a member of Homo sapiens, like modern Homo sapiens, 4.4 million years ago, I would find that shocking. If it held up to scrutiny, I'd accept it. But the problem is it has to hold up to scrutiny, and none of these claims ever do. And, Jerry's saying, well, that's the point. But it's not, because science changes constantly. Paradigms change all the time in science, right? Not all the time, but not infrequently. This kind of thing can and does happen. The reason it isn't happening in paleoanthropology or paleontology or geology is because it can't. Quite literally, every piece of evidence is against young Earth creationism. It's not that people wouldn't accept that if it was true. It's that the evidence isn't there in any field.
Thank you, Erica. Okay, next one is for Jerry. Comes in from Chris Clark. $10 super chat. Thank you for supporting tonight's debate. Here's the question for you, Jerry. Would any amount of evidence change your mind about evolution? And in regards to your research, do you throw out compelling evidence if it is contrary to the Bible?
Okay, a very good question. I was once an evolutionist and was involved in various evolutionist organizations. I was involved with Madeline Murray O'Hare. I was involved in the atheist organization. In fact, I published quite a bit in the atheist journals. And I should mention that I was quite well received in the atheist journals. And I kind of miss the people I associated with who were atheists. And even Madeline Murray O'Hare liked my writing. In fact, everything I wrote, she published. So I was involved in that. And so it was a change from evolution. And this is not rare, by the way. I have a whole book of cases of people who were evolutionists, were strong, adamant evolutionists, and they changed. What caused me to change was primarily the evidence. The evidence, as I studied more and more, just did not fit the evolutionary paradigm. And so I changed with screaming and clawing, by the way, changed from an evolutionist to a creationist because of the evidence. The evidence was critical for me relative to what is contrary to the Bible, that's not what I'm looking at. I'm looking at what does the evidence say? And the evidence disputed evolution, and the evidence also conformed to the biblical record. And I don't want to get into the dating issues, the age issue, etc. But by and large, from what I learned about science, was very clear. Evolution could not occur. It did not occur. And the evidence is absolutely overwhelming against evolution, period. And therefore, as they say, kicking and screaming, I changed worldviews. Some of my friends were embarrassed that, gee, you were one of us. What happened? You must have taken a fall on an icy day or something that changed your mind. But nonetheless, I find the evidence overwhelming against the evolutionary worldview. And that's why I changed. Me and many others. There are many people. I just got a letter 2 weeks ago from a fellow who was an atheist, taught at a university for 40 years, was an evolutionist and an atheist, and he changed. He accepts the creationist worldview. And I just did an article about him, by the way, in a journal, which I sent to him, and he thought it was pretty well done. So we're not rare by any means. In fact, there are many evolutionists who became creationists as a result of looking at the evidence. I often say, let the evidence speak. Don't let anything else speak. Let the evidence speak. And unfortunately, I feel so many people don't do that. They don't let the evidence speak.
Thank you very much, Jerry. Erica, the floor is yours.
Yeah, I mean, I can't think of a single example off the top of my head of a person who was in science who was convinced of young Earth creationism by the evidence alone that wasn't accompanied usually prior by a conversion by some kind of spiritual experience, meaning that they put on their creationist glasses after they convert to being a creationist, being a Christian and being a creationist. I love the theistic evolutionists that I know. I have no problem with Christians. I love Christians. I think many of them are awesome. I work with many of them. Many of them study human evolution. Some of them are leading, leaders in the field. So no issues with that. The problem is creationism. And if young Earth creationism had any support for it whatsoever, then we would find people who are not inundated by Christianity and other parts of the world coming to the conclusion that the Earth is young without converting to young Earth creationism specifically. They are not young Earth creationism Christianity specifically, as in they would find the evidence that the Earth is young, say, oh my goodness, we have absolutely botched this entire thing. The Earth is actually young. We need to recalibrate everything from a secular perspective or Islamic perspective or Buddhist perspective or Hindu perspective, but that never happens. It's always, always, always tied, at least in my experience, to a conversion first.
Thank you, Erica. Jerry, you get the last word. Go ahead.
Yeah, my response to that is when you bring up the age question, I don't think you understand what we mean by the young Earth. I don't think you understand where we're coming from. And well, that's an issue a lot of creationists have a difficult time with. And I know that a lot of Christians attempt to accept the evolutionary worldview. But the point is, as Darwin made very clear, the point is his goal was to, in his words, murder God. How do you murder God? You destroy the reason people believe in him. Why do people believe in God? If you do surveys, lots of surveys have been done. You ask people, why do you believe in God? And one of the number one reason is basically, I believe in God because of the creation, the stars, the earth, the life, etc. They believe in God because of the evidence of the creation. And so they reject evolution because of the evidence. And so what Darwin's goal was is to come up with an alternative explanation for the origin of life, etc. And the alternate explanation he came up with was evolution, natural selection, mutations. So he didn't come up with mutations himself, but later on that was added to the theory. So basically, to say that you're a theistic evolutionist, you are basically accepting an idea that Darwin came up with specifically to disprove the idea of God. And so he knew that, and he was successful. I think if Darwin was walk around the world today, he'd be amazed at how successful he was in converting the world to his atheistic worldview by the theory of evolution. Among scientists, done many, many surveys of this, and something like 97% of all professors are atheists or very close agnostics. And therefore, his goal was met. He'd be surprised that indeed he was as successful as he was in converting people from a theistic worldview to an atheistic worldview.
Thank you, Jerry. Okay, next question comes in. Dr. Tapioca Weasel, $5 super chat. And okay, thank you for supporting tonight's debate. Here's the question. Are atoms, subatomic particles, or anything like that irreducibly complex according to Bergman? And if so, what does that mean? Jerry, any thoughts on that one?
Well, if you have a carbon atom, you have to have 6 protons, 6 electrons, and 6 neutrons. And you don't have a carbon atom until you have 6 protons, 6 electrons, 6 neutrons. You have one more or less electron, you have an ion. If you have one or more neutrons, you have an isotope. And so therefore, to produce a carbon atom, you have to have a certain, I said 6. Boy, it's been a long time since I taught chemistry. But you have to have, it's 6. So you have to have, you have to have 6 protons, 6 electrons, and 6 neutrons. Any change in that, and you have either an ion or you have an isotope. And therefore, by definition, the elements are irreducibly complex because you have to have certain things to produce, in this case, a carbon atom. And the same thing is true with all of the atoms. When that number of electrons or neutrons is changed, you have either an ion or an isotope. And so therefore, yes, atoms would be irreducibly complex.
Appreciate it, Jerry. Erica, any thoughts on that?
I don't have any thoughts on that. I'm going to forego my thoughts on that just to say that saying that Darwin wanted to murder God, that's completely untrue. Darwin was a Christian when he proposed evolutionary theory, and he talked to Charles Lyell about that, and he talked to Asa Gray about that, and he talked to many other close scientists who were also Christians about that, and we know that because we have all their letters. And we have their letters that they wrote to each other. The quote Jerry Bergman is talking about is when Darwin says he feels like he's confessing a murder when he talks about proposing natural selection and evolution, but not because of the theological implications. It was because he was proposing something against species fixity, which was the norm at the time. And the reason I know that is because I just got done writing a 150 plus page script on the history of the creation evolution controversy, and it involved reading, dozens of Darwin's letters and countless books on the subject. And I've heard that one many times. So, sorry, I don't think that's allowed, but I wanted to forego my answer to this to give an answer to the last one.
Thank you very much, Erica. Jerry, you get the last word. Go ahead.
Well, saying it's like committing a murder, and of course, yeah, that's what he said. On the other hand, though, That's what the theory of evolution did. And that's what happened after evolution was introduced in the world. Before Darwin, 98% of all naturalists were theists. After Darwin, a high percent of professors in this area, naturalists, are evolutionists. And so he indeed did convert the majority of professors science professors from the theistic worldview to the evolutionary worldview. And so he was very successful. And when you interview scientists who accept the evolutionary worldview, they invariably will state, well, I don't want to say I'm an atheist because that causes problems. I'll just say I'm an agnostic. But basically, they've left their worldview in that area. One good example is when I taught at Bowling Green State University, I try to keep track of my colleagues at the university. And almost all of them except one have died. And I was curious as to what funerals they had. None of them had a church funeral. All of them had a meeting in the park to celebrate the life. And so when I worked there, they didn't tell me they were atheists, but I knew most of them were. And so therefore, the level of acceptance of the atheist worldview is very, very high. And we know that's because of the evolutionary worldview. As Madeline Murray O'Hara said, evolution is the doorway to atheism. And indeed, that has been proven to be true.
Thank you, Jerry. Okay, next one here comes in from Jackson Rowe. And again, as you both can see, we've had a lot of interaction and engagement in our live chat for tonight's debate. So I do appreciate that from our audience. Some great questions here that help us to expand on the topic in many ways. Jackson Rowe, $8 super chat. Thank you for supporting tonight's debate. And Jackson has a question for you, Jerry, and he's coming at you. Let's see what he says. He says, Jerry did not mention a fossil found in 100 years. Please drill in the specimens like Littlefoot, Australopithecus prometheus, I believe, and the recent Paranthropus tracks as well. Jerry, any thoughts on that?
Not really, not really. I keep up with the literature, but not. My focus is not on the paleontological literature now. My focus is on other areas. But on the other hand, interesting question.
I'm kind of curious to expand myself because it was brought up earlier in the discussion, Erica, about the pygmy hypothesis with Lucy. So I'm curious as to your thoughts, Jerry, just to keep this as comprehensive as possible. From my understanding, Littlefoot, Australopithecus prometheus, the pelvis looks very similar to Lucy's. So to maintain a position that says Lucy is a pygmy human, would that not also mean that somebody who holds to that position would have to argue that Littlefoot, since there's so many similarities there, is also a human?
It surprised me that one could even propose the idea that Lucy was a pygmy. I mean, enough evidence to even make the proposal. So I have to admit, I haven't really read a lot about that, but there are several people I'm aware of that have proposed that, and I'm intrigued whether or not that could be possible. But I guess that's so different from my previous paradigm that I saw so much of Lucy, a vast majority of Lucy, as non-human, and to propose that he was a pygmy is just surprising. But then again, I guess as you study paleoanthropology, you realize there are a lot of surprising things that come up. And
so the data on Littlefoot, what we know about Littlefoot, might preclude the pygmy idea?
I would think so, yeah.
Okay. Erica, over to you.
Yeah, not even that. Also, the Australopithecus sediba stuff, right? Like, let's say you wanted to take the position that Australopithecus sediba is a mixture of two hominins. That doesn't help you with the pelvis stuff because the pelvis is Australopithecus and it's connected to a vertebra that is also Australopithecus. And the people who made that statement are the same ones who proposed that it was a mosaic species, like a mixture of two different species, Elabin and Yule Rock. Elabin is like the star when it comes to vertebral columns, right? And she's the one that was like, yeah, you have a Australopith lumbar there connected to the sacrum and then the pelvis of Australopithecus sediba of MH2, right? And that's one of the specimens. She's not proposing that those are two separate specimens. So that's a real problem for anybody who wants to propose that Lucy's a pygmy. Then you have to deal with all the other Australopithecus africanus pelvies that we have. Like, those aren't the only two. I forget if they're STS specimens. I think one's STS 15, but I'd have to double check. I do want to talk about this though. Paranthropus tracks. Paranthropus, I barely talked about Paranthropus. This is the face of Paranthropus. Anybody who would look at this, right? There's a 3D print of a scanned fossil of Paranthropus. It looks really apish. It's got a sagittal crest, right? It's got a brain case size that's within the Australopithecus range. This is the whole thing. There's no recreation here. This is the fossil itself. And when you flip this bad boy over, as I'm about to do here, that foramen magnum is closer to a human than it is to a chimpanzee. And it's not close, right? It's far closer to the human. In fact, it's basically in the human position. It has a slightly backwards orientation. But it's also a biped, right? And that's because this is the other genus that split from Australopithecus. It's Paranthropus and it's genus Homo. That's why these things maintain all of the same bipedal characteristics that you see in Australopithecus. So yeah, I mean, it's kind of important to bring Paranthropus up, but creationists never do because they just look at the face and they say, oh, that's just an ape face, until you flip it over, right? It's got that. In fact, these guys are unique in that they have heart-shaped foramen magnums, which is really cute.
So you're saying the foramen magnum in Paranthropus is closer to the position in humans than to chimps? I guess she.
Yeah, okay, I'll show you. It's right. You can see it right here. When you level them like that, it's way further to the back. And the way that you have to do this is you have to make sure the pallets are level, right? But I mean, it's not hard to see, right? There's the chimp. There's the human. These things were also bipedal. Paranthropus was. We also have a Paranthropus leg, and it looks like Lucy's leg. I mean, there's really no art. There's no way that you can maintain at this point in time that Australopithecus and Paranthropus weren't bipedal hominins. Creationists are better served just saying that they're bipedal and coming up with some other way to differentiate them.
Okay, appreciate that. Jerry, what are your thoughts on Erica's points there, especially her points on the foramen magnum position?
I thought the difference there was not so much where the foramen magnum was, but the occipital bone seemed to be a lot larger. And that seemed to give the illusion that indeed it's closer to humans, but I don't think it is. It's just the occipital bone. It's just the bones in that area are just simply much larger.
These are the occipital condyles, though, right? So the bone itself being larger still means that it's further forward, which would mean that it's still a biped. Like, the reason why it's further forward doesn't bear on how it's used in locomotion. Like, this thing could not, there's my fingers coming out of it, just keep them straight. If this thing is a quadruped, boop, staring at the ground.
Jerry, any thoughts?
Yeah, that's certainly a weird creature. So again, it illustrates the enormous amount of variety we see in the natural world.
Out of curiosity, too, to expand on this question a bit, Littlefoot and Lucy, Jerry, from your position, Australopithecus afarensis, Australopithecus prometheus, would they be the same kind or be a different kind of Australopithecus, or how would you view that?
Well, I would say they'd be different, but I didn't. One needs to compare a lot of traits to see whether how close they are. But I would say they are different enough to classify them. But we know the problems with taxonomy, so I guess if I was a taxonomist in this area, I would say they're part of different taxon. But of course, one who spends their life studying primates may not agree with that. I don't know what Erica thinks, but she may agree or disagree.
Okay, very good. Erica, Jerry, appreciate you engaging those clarifying questions. And okay, next one comes in for Erica from Dotsu, $50 super chat from your chat. Erica, thank you for supporting tonight's debate. And Dotsu says that they love your content. It was a huge help during their deconversion. And the question is this, a question for both of you, actually. What is your favorite book? Do you have any recommendations? And there is a question for Jerry, but Erica, let's allow you to answer your question first.
Yeah, of course. I mean, I myself am an agnostic, but a lot of people have told me that my content has made them like deconvert or has helped them deconvert. And a lot of people have also told me that my content has made them feel like stronger Christians. I've gotten the same emails from both types of people. The only difference between the two is that the people who deconverted were young earth creationists, and the people who felt their faith was strengthened by my content were theistic evolutionists. So, my content doesn't necessarily deconvert unless you're a young earth creationist, in which case, if you're building your entire faith off of a literal interpretation of Genesis, my content's not going to be friendly to you, I don't think. My favorite book. I have, a lot of books that I really like. I'm looking over at my shelf right here. If I had to pick, I can't pick a favorite book. I can pick a couple of favorites for nonfiction that I would really recommend that you read if you like the kinds of things that I cover. The first is The Ends of the World by Peter Brannon. I loved that book. It made me make my best performing video, which is The Deadliest Pattern in Nature. The second is probably going to be Behave by Robert Sapolsky, because I think it's really cool. It's a really interesting look at behavior in humans and in other animals. And my third favorite book is probably going to be Impossible Monsters by Michael Taylor, because it inspired me to make my most recent video, that 150-page plus script on the history of creationism. An honorable mention probably to anything by Frans de Waal, and another honorable mention probably to Ronald Numbers and the Creationists, which I really, really enjoyed. He did a big history on creationism in general, and I found it incredibly elucidating.
How dare you not say Lord of the Rings?
I was doing nonfiction.
I know. That's true. We'll give that to you.
I love Lord of the Rings, but nonfiction exclusively right now.
Very good. Erica, if we had both, then I'm sure LOTR would.
Oh, it would make it. It would at least make it in the top echelon for sure.
Right. All right. Very good. So Jerry, your question, let's see here. It's a two-parter. So let me grab the second part too. Jerry, if you had to choose one, what main factor strengthens your belief in creation?
Well, that's the most difficult question I faced all evening. I would say just picking here bits and pieces. And I think this is true of many people. question this part of evolution, that part of evolution, some other part of evolution. It just built up. And after a while, it just simply, it's like the water over a dam. The water became so high, it flowed over the dam. And I realized that this worldview could not be true. I think one of the main things was working at the medical school in the area of mutations and genetics. I realized how central genetics were to disease and how indeed there's no way it could produce evolution. It's not going to occur. And probably that's the most significant for me teaching at a medical college. By the way, I have 3 degrees from medical school. Not once was evolution mentioned. Not once was it mentioned among any of my professors, including my anatomy professors. In fact, the opposite was indirectly mentioned. We got good lectures on how wonderfully designed the body was, the hyoid bone, how incredibly well designed that was. He didn't mention creation or evolution, but how well designed the body was. And so that was a focus of his teaching, part of his teaching, my anatomy professor. And so I would say medical school was one of the major reasons that helped me to understand the creation worldview is valid and the evolution worldview is not. One concern I have is, Erica, this is film. You have film on this. Would it be appropriate to show this debate to a high school class? Would this be appropriate?
I think it absolutely would be. Yeah. I mean, I would show it to my students. I think it's really, really, really important for students to know the strengths of evolutionary theory and the potential strengths and or weaknesses of the ideas that challenge it. I think that's critical. You can't just accept something blindly. People need to know why evolution is supported and not just, not understand it and just say they believe it because that's what everybody believes. I'm a firm believer in showing exactly this kind of content to my students, but I'm not in charge of what I get to show because I teach, I'm not teaching next semester, but the previous semester and all of my semesters prior, I taught biological anthropology, and there's a set of standards for the state that you have to meet, and you can only fit so much in there. So wasn't up to me.
Are you aware I've written 5 books on the court rulings relative to this issue? And the courts have made it very clear that you cannot present any information which is against evolution. You can only present information which supports evolution. They don't use those exact words, but that's pretty much what they say, because teaching information against evolution is backdoor creation. And therefore, backdoor creation cannot be taught. You cannot present information in the public classroom that is backdoor creation, that is detrimental to the evolutionary worldview. And that may be why my professors at the medical school were very careful in covering this material. They wanted to be very careful that they did not present information that was detrimental to evolution. So in essence, what we have, and this came out very clear in the court cases, in essence, we have a situation where only one worldview can be taught in the schools, and that is the worldview that supports evolution. We cannot present information against evolution, even if the information comes from peer-reviewed journals. Cannot be done because that is teaching backdoor creation. You may not have gotten in trouble because you're obviously in evolution, but if one who was a creationist, and they knew he was a creationist, was presenting some of the information I and you presented, it could be the end of your career. And I've written 5 books documenting very carefully, indeed, what the court has ruled and why they've ruled the way they've ruled. Only evolution can be taught. It must be taught as fact, and information against the theory of evolution, like the information I presented in mutations, cannot legally be taught. And there are cases where professors have, and teachers at the high school level, have taught this information about mutations, and they got into trouble because they are not allowed to teach information that is against the evolutionary worldview. Now, you can do it tactfully, and teachers do all the time. I mean, teachers get away with teaching all kinds of things they're not supposed to teach. But if this came to the attention of the administrators and it went to court, you would likely lose, as many cases have, of teachers who actually, some were in the middle of this creation evolution debate, and they taught information that was incremental, that was deleterious, that was problematic for evolution, and they got in trouble and were labeled creationists. And once you're labeled as a creationist, that's typically the end of your career. And this is well documented, and I have a whole file cabinet full of documentations that show if you present information against evolution, it's likely, when it becomes the attention of the administrators, likely going to end up causing problems.
Erica, looked like there's a couple things you wanted to respond to if you wanted the
No, I mean,
opportunity.
Jerry already covered it. I was going to say, I mean, I have students who come from high schools in the state that I teach. When I was teaching, and I taught for, 4 years, right, at the university level, teaching labs and honors intro courses, core courses. I mean, I had students every semester who never got taught a lick of evolution, right? Or some of them didn't even have to take biology. I mean, that's not something that's allowed, but because they went to private schools, I don't know how they skirted it, but I mean, that's what they were telling me. So, I think evolution education needs to be amped up, period. And I think that it's really, really important to teach students what creationists are saying when you're teaching evolutionary theory. But I'm going to be transparent. I think that's because the evidence for creationism is so abysmal. I mean, I think that all of the evidence for creation needs to be on the table for students to consider, probably not during class time because there's literally not enough time for it. But I don't think that students or teachers should be reprimanded for asking questions like that in class. I had students who asked me questions like that in class. I had one student who came up to me the first semester that I taught and said that they really appreciated the class because they were afraid to ask about evolution because at their church it was something that was shunned so robustly. And I said, to them, I was like, there's no reason why it needs to threaten your faith at all. You can be a creationist or not be a creationist. You can be a Christian, accept evolution for sure. But it's a fraught topic. I don't know the details of these court cases you're talking about. I haven't read the books on the subject, so I don't know the details. But in my personal experience, where I teach at least, teachers are not getting in trouble for not teaching evolution, and they're also not getting in trouble for sneaking creationism in. But if it were up to me, I would say that I think it'd be good for evolution to teach some of what creationists are saying. That's my opinion.
Well, you should check out my books. They're on Amazon. And it's about censoring the creationists, silencing the creationists, silencing Darwin doubters, and so on. And I have at least 4 books that cover this in detail. 400 or 500 pages, well referenced, and so on. So the literature's there, the information's there. And it's horrible cases. 5 suicides as a result of this conflict and the response of the university and the public against the person who had the audacity to question evolution, and he ended up, and I cover that in one of my chapters, ended up committing suicide. Very well known case, and others have occurred as well. So, and when I was teaching, I was very careful. You got to stay away from this. If students ask questions about evolution, you say, well, the evolutionists would say this or that. And so you have to be very, very careful. In spite of being very careful, still I ended up with problems at some of the places I've taught at because they said, you don't teach evolution with heart, with sincerity. And we know you don't accept it, and therefore probably these anti-evolution statements come into your classroom. And just a warning, you better be very, very careful. You don't hint at any problems of evolution. And of course, I did so for 40 some years. Didn't have any problems, but I know many people who do.
Okay. Thank you, Erica and Jerry, for the back and forth there. We'll have to add this debate to the curriculum for people to analyze, examine, have some tests. Erica, I heard your dog in the background bark, and so I think he was agreeing with some things said there. So very good. And okay, let's move on to the next one. Great Q&A so far. Nephilim free. Okay, so Jackson Rowe was coming at Jerry earlier, and now Nephilim free is coming at you, Erica, one of your biggest fans here. $50 super chat. Do appreciate the support. Nephilim free. Yeah, let's see what he's got here for you. He says, aphorensis. The iliac blades flare out. No locking knee joint. Foramen magnum, which we were discussing earlier, is rearward. Pelvis to knee angle is distinctly ape. None of these allow bipedalism. Can you ask for, so he's contesting what you said earlier, Erica. What are your thoughts on that?
Yeah, I mean, Neffy's just wrong on that, right? I mean, I showed the numbers in my presentation that are pulled directly from the literature. I've run these statistics myself in R and showed some of the images in my presentation, right? So do the iliac blades flare out? Absolutely, yes. Does that preclude bipedalism? No. Is that something that also exists to some degree in later members of Australopithecus and early members of genus Homo and later members of genus Homo? Yes. Okay, locking knee joint. Do you need to be able to lock your knees in order to move bipedally? No, because many apes today who are not humans walk bipedally without being able to lock their knees. It certainly makes you more efficient. But would we expect an early biped to have every feature of efficiency to walk bipedally? Not only is the answer to that no, but if that happened, that would actually be surprising. Foramen magnum is rearward. No, it's not. This is Mrs. Plez. This is just, again, like the Paranthropus fossil that I just showed you. This is a scan of the fossil itself. This is the whole piece. There's no reconstruction. There's nothing that's added to it. It's just the original cast that was scanned, or not cast, the original fossil that was scanned, uploaded to Morphosource or the like, and then I 3D printed it with my 3D printer. You're wrong. Foramen magnum is forward, and it's like this in all the members of Australopithecus. It's more forward than you see in any living ape. The orientation is forward as well, so the angle of the foramen magnum itself is also forward. These things do not have rearward foramen magnums, and that you just see that with your eyes. Pelvis to knee joint is distinctly ape. No, it's not, and I showed countless pictures in my presentation of exactly the opposite of that. But even if all of the things that you just said were true, outside of the foramen magnum being rearward, which is the most false of all the things that you just said, if you had iliac blades that flared way out, couldn't lock your knee joint, and even if the pelvis to knee angle, I assume you're talking about the valgus angle, was slightly varus instead, you could still be a biped. So saying that none of those allow for bipedalism is also demonstrably false, because all apes can walk bipedally today. They're just not very good at it, and if they do it for too long, they get pathologic. That's why Lucy's adaptations towards a far more efficient bipedalism than what you see in other living apes is so well supporting of evolutionary theory as a whole. So I will turn that on you and say, please ask my forgiveness for putting this kind of putting this kind of thing in the chat, because I've talked to you specifically about this before, Neffy, and you're still saying it, and I showed you the pictures last time, and you're still saying the same stuff. So I'm glad to see you're doing well, though. In general, I thought about you the other day, and I was like, I wonder what Nephilim Free is up to. I think about some of the people that I used to interact with a lot more back in the day, occasionally as I go through my life.
His ears must have been ringing when you were thinking about
probably
him,
were.
and so he decided to join
They
in
probably
today.
were. You're probably right.
To clarify a little bit, so you mentioned with the iliac blades flaring out.
Yeah.
You were saying that some in the Homo genus, like Homo naledi, I think even Hobbit, their iliac blades flare out too.
I don't know about naledi, but Floresiensis has the iliac flare, yeah. So,
okay.
And I don't think anybody, creationist or otherwise, is going to propose that the Hobbit, that Homo floresiensis, is just an ape that isn't closely related to humans. That would be absurd.
That's a fair point. So you're saying the flaring hip basically can't really be a feature that we can look at to rule out bipedalism.
Yeah, not even close. In fact, if anything, it's telling us that the iliac blades are moving into the sagittal plane, which means that it would, and this has been argued by some paleoanthropologists, that would actually make you more efficient at a more bent knee bipedal gait.
Okay, well, I appreciate it, Erica. Jerry Bergman, the floor is yours if you had anything to add or anything you'd like to respond to there.
Well, not really. I could see his point in the question he asked. I guess one thing I want to mention is the anti-creation books are really grossly irresponsible. So much wrong information. Hopefully when you do your book, you will at least understand where we're coming from. I have been just called every name in the book, names I never heard of because of my stand. And so they're very, very critical, and they just irresponsibly inaccurate in what they have to say. So be careful in doing your research. Look at the other side. And one way you can look at the other side is check Amazon and check my 5 books. At least you're aware of the other side. And that's why I think so many of the anti-creation books are not very effective, because most creationists recognize this is just totally wrong. Like your concerns relative to the age question. It's easily answered, very easily answered, but on the other hand, the way you framed it, your statement about it, you just don't understand where we're coming from. But anyways, just be careful. Ron Numbers, by the way, does a good job, by and large. And that's because his background was a Seventh-day Adventist. He was a creationist, and he explains how he left the creation worldview and why. And so he does a decent job, because I think his background, he still had strong feelings for his father, and his father was a creationist, and so he is better than most. But on the other hand, some of what he wrote really surprises me, that he indeed wrote what he did. and he should know better. But on the other hand, he's been doing very well as a lambasting creationist, and as many people who lambast us have done very well.
Thank you, Jerry. So one quick clarifying question for you then, to be fair. In light of what Nephilim Free says here, and then Erica's response or counter, do you think it's more accurate for Creationists to say that the Australopithecines were bipedal or not?
From my knowledge, there's debate, and maybe I'm not keeping up with the current literature, but there has been a lot of debate about whether it was or was not bipedal. And I think the question's not easy to answer. And maybe they have more information now and they can answer better. But on the other hand, that doesn't prove evolution. That doesn't prove anything except, well, they were bipedal and could walk around on 2 legs and spent some time crawling around. So it's interesting. It's nice to know. But on the other hand,
thank you, Jerry. Appreciate it. Erica, you get the last word. Go ahead.
Yeah, I mean, I'll just tell you, as somebody who is up to date, like on the literature, because I have to be, since this is what I'm getting my doctorate in. I mean, I don't know when the last time you did a deep dive was, but there's nobody out there who's saying that Australopithecus is not bipedal when it's on the ground. The debate is, and I would even argue has always been, about whether or not it spent a lot of time in the trees still, or a little bit of time in the trees still. I said this earlier, but Owen Lovejoy and his team were the ones who said, no, it's mostly spending all its time on the ground. And Stern and Sussman in 83 pointed out that, no, it's still spending some time in the trees. I'm partial to the latter. I think Australopithecus still spent quite a bit of time in the trees. But I think that there is literally no way to reconstruct Australopithecus as a quadruped or as a knuckle walker. You can't do it. In fact, I've said this before on my channel many times, its morphology precludes a knuckle walker or a quadruped. It's just not going to work. So that's the most up to date that you're going to hear from somebody who's quite involved in this topic.
Okay, thank you very much for that final word there, Erica. Beyond Doubt Theology, $5 super chat. Appreciate the support. For you, Erica, you mentioned the mutation TBXT, which was exhibited in mice which deleted their tails. Can you please tell us what else happened to those mice?
I mean, I don't know what they're referring to. I think they're probably talking to the serpentine condition that some of them got, but not all of them got the serpentine condition. Some of them just didn't have tails. That's kind of the point of mutations, is that sometimes they can be deleterious and sometimes they can be advantageous. It's not a coincidence that every time tails seem to vanish in primates, it's happened twice in apes and then also in lorisoids. It's happened at the same time that grip strength and precision grips in particular increased. Because if you're a slow clamberer in the trees, a tail isn't going to help you. It's also why the only other orthograde primate that isn't an ape, which is the spider monkeys, the atelids, or genus Ateles, they don't have thumbs, and they don't accomplish their arboreality and their upright posture in the same way the apes do. They use their prehensile tail like a fifth limb. I mean, unless they're talking about something else, it would be news to me if every single mouse, because I remember seeing the pictures, that was what was so nice about that paper, is that you had several pictures lined right up next to the other to see how these mice were born when they had that gene or that mutation in particular in them. Some of them are serpentine, some of them are not. The tail loss is variable.
Thank you, Erica. Jerry, anything you want to add?
No comments. I'm aware of that case, but there invariably is side problems which also occur. And I can't see how losing the tail is in general beneficial. And again, this is a loss mutation, and there are a number of loss mutations. That's not the issue. The issue is mutations which build tails, which build these structures, which produce these structures. And so that's what I focus on. So yeah, there are a lot of loss mutations, especially color, hair color. You have a mutation, you end up with an animal that's different color. The mutation that produces albinoism, of course, the best example. You end up with really neat animals as a result of this mutation, which prevents the normal melanin being produced on the body, producing the color. And so, in a number of animals, you do have benefits indirectly that can come from certain mutations, but that's not what we're talking about. We're talking about building an animal from hydrogen to humans by accumulation of mutations.
Okay, thank you, Jerry. Erica, any final words on that
No,
one?
I just looked it up and I saw the picture that I was thinking about, and I don't see any serpentine mice. So I'm not sure what this person is talking about with regard to negative aspects of losing a tail, other than they don't have a tail.
Okay, appreciate it. Okay, this next one here, Alyssa Hallister, $20 super chat. Appreciate supporting tonight's debate. And looks like it's for you, Jerry. How can I exist as the biological genetic offspring of two humans with type O blood while having type A blood if you are correct? All evolution requires is an accumulation of, I think mutations was the next word, but it got cut off. Jerry, any thoughts there?
Well, type O blood means, of course, you don't have either A or B. So you either have AA, BB, AB, or BA. So type O blood has none of those. So how can you? That's interesting. I don't know. It's interesting that you would have type A blood. There must be a mistake somewhere because we know type O has neither A or B. Those. So therefore, I don't know how you could have type A blood. I have to answer doubt. I don't know. There might be some extraneous factors that were involved in this conception here. But I'm lost.
Okay, appreciate it, Jerry. Erica, anything you wanted to add or elaborate on there?
I mean, I think what they're saying is that the reason they have type A blood while having two parents who have O blood, which would mean they'd be O, and then you could only, under normal sense, have a child with type O blood. I think what they're saying is that a mutation is specifically responsible for giving them type A blood, which, while being, quote unquote, a genetic mistake, conferred a benefit to them in the sense that they can receive blood donations from more people. The idea being that, like, that's how you can get new blood types, maybe. That's what I think they're getting at. But I also don't know enough about, like, I know how blood typing works, and how codominance works, and how to do a blood typing Punnett square, because I have to teach my students that every semester, but I think that's what they're getting at.
Thank you, Erica. Jerry, anything else you want to add on that question?
Yeah, it'd be intriguing to find out how one could get type A blood when neither mother or father has a type A gene for type A blood. I don't know. That'd be interesting. I don't think a mutation could explain that. I doubt very much if that could result from a mutation, but on the other hand, interesting.
Okay, thank you, Jerry. Planet Peterson, $5 super chat. Appreciate the support. Jerry, do you think evolution teaches that chimps evolved into humans? Because you specifically said mutations cannot get you from chimp to human in your rebuttal. Jerry, what are your thoughts on that?
Yeah, well, obviously the current position is, as Louis Leakey likes to stress a lot, that chimps did not evolve into humans, but chimps and humans have a common ancestor. But what was that common ancestor? That's the question. And rather than go through that explanation, we just often say chimps evolve into humans, or it's just easier. And basically, that common ancestor was probably chimp-like. I don't think they're claiming it's human-like, so it's probably more like a chimp than a human, that common ancestor. So therefore, basically, it would be a common ancestor of chimps and humans would be a chimp-like creature, which evolved into chimps and then also humans.
Thank you, Jerry. Erica, the floor is yours.
Yeah, I mean, I think that's in part, unfortunately, I think that's in part the responsibility too of the media, because they often portray the march of progress like a chimp is turning into a human. That's not what's happening, but that's not entirely creationists' fault, because the media is like constantly inundating them with that one image. And I don't like the march of progress, even though I use it as a cartoon all the time. I still don't like it. But what I will say that's interesting is that while the common ancestor of humans and chimps probably had more in common superficially with chimpanzees, it almost certainly wasn't a knuckle walker, which is really interesting, because what I'm studying for my dissertation is Miocene apes. This is actually my bread and butter, right? And there isn't a single Miocene ape that knuckle walks. Not one. We don't have a single extinct ape that knuckle walks. The only ones that do it are chimps and gorillas, and they do it in different ways. So what that suggests is that the common ancestor of all apes was not a knuckle walker, but instead was probably something like a generic suspensory clamberer, not unlike what you would see with an orangutan.
Thank you, Erica. Jerry, you get the last word if you'd like it.
No, I think fine. What we've talked about is fine.
Okay. You guys have great endurance. You just let me know when it's time to quit. I know we've it's been an extensive Q&A. We're at an hour and 15 minutes. So here, let's it's been great. The audience is enjoying it. That's why we got so many questions. So Michael Curtis, $5 super chat for Dr. Bergman. Are you aware that in 2002, Svante Pabo was awarded a Nobel for work concerning the genomes of extinct hominins and human evolution?
Yes, I am. I have his book. I've read parts of it. And I think it's 20 years ago. And when I read his book, I questioned it. The concern is contamination. To do this sequencing, you need to be in a free lab, a sealed up, air pull out of the lab, a level 5, I think it's called, level 5 lab. And so my concern was, although he covered this quite a bit, he claimed there was no evidence of contamination, that indeed what he found was indeed the genomes of extinct hominids and specifically the Neanderthals. So I can't, but since his work, I think others have criticized it and have found some problems in it. And that's an area I've looked at, but it's be interested in seeing what the current position is, because I have a hard time understanding how genomes could survive however many years they think the Neanderthal died off. Because I know in forensics, we have cases where we know a woman died in 1947. We know she died in 1947. And yet when DNA analysis is done, it's questioned by the other side, because how do you know that this DNA indeed, this woman who died in 1947, how do you know that this indeed is pure enough, is not contaminated enough and not problematic, that you can make these judgments relative to who this person is, etc. And so DNA is very sensitive to radiation, etc. It breaks up very easily. And so I've always questioned how in the world you know that that DNA is the age that they claim it is in the Neanderthal that they worked with, because DNA is very fragile and it has to be protected to a high degree, because cosmic radiation and other radiation can damage it considerably. And so I know whenever you have a criminal case, when you go back 20, 30, 40 years, there's going to be problems raised in court relative to whether or not this is valid. So I have a hard time believing that indeed DNA that's thousands of years old could indeed accurately represent the DNA that existed at that time in Neanderthals.
Thank you, Jerry. Erica, over to you.
Yeah, I mean, I'm pretty confident that it's actually DNA because it's different from humans and it matches what we see with regard to the molecular, or not the molecular clock, with regard to what we see from the fossil record. It shows that Neanderthals, in fact, did go extinct like 40,000 years ago, which is the oldest Neanderthal, or the youngest Neanderthal fossils that we actually have. Moreover, the reason I trust it is because many, many, many more Neanderthal genomes have been sequenced since then. And we've even sequenced the genomes of like old humans, like normal humans that have survived, their DNA has survived because they were in similarly Arctic conditions, because that's why the Neanderthal DNA survived and why you can't get DNA from, someone of the same age but in like the Sahara Desert. So, I don't have a problem with it. And, I think anybody that does really needs, like, what you got to do is show that that DNA like can't actually survive that long, when experimental work shows that under like Arctic conditions, under cold conditions, DNA actually can persist. But yeah, I mean, Neanderthal DNA is super inconvenient for creationists in a lot of ways. So I get why, people like Nathaniel Jeanson like to throw shade on it and say that it's not legit. But I find it compelling that other creationists like Robert Carter are fine with it. So, we'll see what ends up happening with that. I'll leave that to them to hash out.
Thank you, Erica. Jerry, you can have the last word if you'd like it.
No, I appreciate Erica's comments. I think that just the conditions obviously were such where it could have lasted that long, but on the other hand, I have to wonder.
Okay. Next one here comes in from Marvo Marverson, $20 super chat for Jerry. it seems that you suppose that all modern and contemporary horses existed simultaneously at one point. If so, do you purport that species variation is on a continuous decline throughout time?
We know a lot of the horse species that were thought to be extinct were not. And we know that there are not that many extinct horses or pre-horses that we found. There's a couple, but those are questionable. On the other hand, the charts that I showed you they lined them up nice and neat to look at the evolution from primitive horse, so to speak, to a modern horse. And we know that today that all of these lived contemporaneously, or indeed were true horses. And so that's the conclusion of the people who look at horse evolution and who did these charts that I showed earlier. So there's not that many extinct horses they found that known to be extinct. And so a lot of these horses that they thought were extinct were not. And they were lined up, and I'm not sure where they got the horses that lined up. I know the hoof differences were there and were mentioned, but we find many of these hoof differences exist today, or some of them at least exist today.
Thank you, Jerry. Erica, over to you.
Yeah, I mean, I don't know much about horse evolution. I think that it's telling, though, like, that when you go backwards through time, the horse toe number decreases. You see similar trends in other perissodactyls. So, you know, it's not just the toes as well. They also have an evolutionary trend in their teeth. Horses are hypsodont, so I don't know how what landmark specifically you use with hypsodont teeth, but I know that as you go backwards in time, people like Donald Prothero have charted perissodactyl evolution quite extensively. And my understanding of it is that there's like quite a bit of overlap there as well, but there's certainly fewer fossils. Not everybody is as lucky as paleoanthropologists.
Thank you, Erica. Jerry, here's another one for you from Cheetah. $10 super chat. Thank you for supporting tonight's debate. To Dr. Bergman, can you point out a physiological difference between humans and chimps that is insurmountable by evolution from a common ancestor?
Well, many. Conscious ability of humans to sing, to read, to write, to use words in complex words, sentences. So there's a lot of differences. And I suppose you could propose that indeed chimps had some of these traits. You know, they tried to train chimps to use symbols, to communicate by symbols, and there's debate about whether or not this is valid. But on the other hand, they can be taught certain things and taught how to interpret symbols and so on. But still, there's an enormous difference between humans' ability to do these things and chimps. And consciousness, of course, is a basic difference. The perception of self, how humans see ourselves as individuals separate from the world around us. And commonly when animals look at themselves in the mirror, they don't know who it is. I'm not sure about chimps, but indeed there are many differences which you can't really easily explain. I suppose if you accept the evolutionary worldview, then you would say, well, they slowly developed a conscious and slowly developed the ability to speak. And of course, the tongue, mouth structure is such where chimps are limited in what words they can articulate, where humans can articulate quite a few sounds. And that's because the design of the throat, the palate, the tongue, etc., the teeth. And so the animal has to have all of these systems before they can articulate sounds that allow speech. And so therefore that would be, I think it's a problem. How would you explain this? Why would they develop these things if they're no use until they have all the whole set necessary to talk, and including the brain function, of course. And so as the problem with evolution is always, how do you get from one structure to another when the structures in between have no function? When mutation makes a change, the structure that decodes when the mutations begin doesn't work anymore. So that's a problem that Darwin had, and that's also a problem which we have today.
Thank you, Jerry. Erica, the floor is yours.
Yeah, I mean, I just did a video on this. So chimpanzees, actually, their closest relatives within their genus. So we're the same amount of related to chimpanzees and bonobos because they're both, they're both chimps. But, we observe bonobos using syntax, right? So they have grammar in their calls that they utter to one another. So they'll have a call and then they'll alter the meaning of that call with subsequent calls. We see this not just in chimpanzees and bonobos, but we also see this in Campbell's monkeys. We see that geladas have like calls that or communication systems that follow basic human language laws, like Zipf's and Menzerath's laws. To give a specific example, in the case of the Campbell's monkeys, they have a specific call. Everybody who watches me has heard this example a million times, but they have a specific call that means predator, and then they'll alter that call with like another call that means essentially like from above, which means it's a crowned eagle, because crowned eagles eat Campbell's monkeys. Or they'll alter it with a different call that means from below, which means it's a leopard. So they're utilizing grammar or proto-syntax in their communication systems. And actually, like bonobos exhibit both trivial and non-trivial syntax as well. So we see this in their wild populations. This isn't attempts of us trying to teach them how to speak the way humans speak, but their communication systems have all the basics of a human language. Now, are they as sophisticated as human languages? No, of course not. But they have all the basics there. Elaboration on that system is really not that difficult, I don't think. I mean, I think 2 weeks ago, we inserted a human language gene into a mouse and they started squeaking in human linguistic patterns or whatever. It's really not that difficult to change mammals with software, genes or whatever being the analog for software there. Chimps and bonobos also have analogs for Broca and Wernicke's region, which are the brain regions that are responsible for language. Now, I wasn't sure if Jerry was saying conscience or consciousness. Chimpanzees are certainly conscious. In fact, many, many animals are conscious. They have politics with one another. They have a sense of humor. They laugh when they're tickled. They grieve with one another. They preferentially grieve for bereaved mothers. They scheme. They do all sorts of things that humans do to a different degree, but they certainly do all of those things. As far as a conscience goes, right, they also have that because they will punish group members that violate the rules within the group. We call that in the animal behavioral biz proto-morality. So all of the basics for what makes a human exist in a chimp. That doesn't mean that chimps are humans, and it doesn't mean that humans are chimps, and it doesn't mean that what we're doing is the same, and it doesn't mean that what humans are doing isn't special. It just means that it's definitely not an evolutionary gap that's like impossible or even really very difficult to actually hurdle under the selection pressures that we see in hominins.
Thank you, Erica. Jerry, it was directed at you. If you'd like a final word on that one, go ahead.
Well, animals, of course, have certain abilities which allow them to communicate, etc., and probably more so than we assumed in the past. There's still a chasm between our communication and, I'm not talking about their conscious, but consciousness or the ability to conceptualize ideas in such a way to where they can do math, etc. I know they've trained animals that can do simple math, and but on the other hand, there's still a chasm between us and the monkeys and their primates, and therefore to bridge that, even though they have indications of certain abilities in that direction, but still there's a huge difference between us and chimps in communication, etc. And although some animals are pretty effective in communicating, but not nearly as effective as we are. We can write books and communicate very effectively in many ways.
Thank you, Jerry. Okay, next one here. I think this is directed at you, Erica. Beyond Doubt Theology, $5 super chat. Appreciate the support. You brought up the 1% divergence in your intro. Why then act surprised when things like the waiting time problem or papers countering it are brought up?
Because we write intros before we actually have this conversation. So we plan on what we're going to talk about before the other person actually speaks, which means Jerry and I both did our intros before we listened to each other talk. Now, the waiting time problem, like I've said a zillion times, and other people who are in this space have covered it way more extensively than I have, is not an issue. 1% divergence also isn't accurate. 1% divergence in protein coding regions, maybe. It's looking, the most recent genomic paper actually seems to suggest that it's less than that. It's now over 99% in protein coding regions. But with regard to the entire genome, that number still hovers around 96%, 95, 96%. So, I don't know, waiting time problem people, you got to pick whether you're going to have a problem with the 1% for protein coding or the 4 or 5% for full genome, and then take it up with somebody who's actually a geneticist and knows it better than I do. I can certainly refer you there, but, to pretend like I'm upset that Jerry brought that up, I'm not upset. I love this kind of stuff. It's my bread and butter.
Appreciate it, Erica. Jerry, any thoughts?
Well, 96% similarity or 5%, 4%, 5% difference is actually huge when you're talking about 3 billion bases or 6 billion bases total, 3 billion base pairs. So it's actually a huge difference. And it's kind of amazing that assuming that difference is correct, amazing such a small difference can create such major differences between us and other primates, like the chimps, for example. So the problem I have with this is that there's, as one professor told me, it's hard to compare things that are not comparable. And we're trying to do that. And I guess as we learn more and more about the genome, we're able to do that better. But on the other hand, that's limited in what can tell us the difference between humans and other primates. And so you can have one change in a controlling gene, and that change can cause large changes in the organism when it's mature, in the phylogeny, as well as the physical appearance and behavior of the creature. So that's because we have many controlling genes, and one of these, well, it's like cancer. One gene can mess up a lot of things in the body. One gene can change a lot of things in the body. And we have a few genes that can change a tremendous number of things in the body because of the sequence system, which is all assembled together to function as a unit. And one part of that unit is changed. It could affect adversely all the other units, which could be catastrophic in some cases.
Jerry, I understand there's a diversity of thought in the world of young Earth creation on just how similar genetically humans and chimps are. Would you argue that they are 96%, 95, 96%, or would you personally go with a lower number?
The problem is when they do comparisons, what are they comparing? Ideally, you compare the entire genome, but that's hard to do because, again, so much of it we don't know. Probably the best comparison is to compare genes that produce protein and not the other genes. I'm impressed with some of these lower numbers, 85, 90%, but on the other hand, until we understand fully the function of most of the genes, it's going to be very hard to come up with a number. And then that number is misleading. The cliche is, which my friends get angry about, is we're 50% banana genome-wise. Well, what does that mean? It's in a sense misleading. Does that mean that half of our, well, what does it mean? But that's often used that we're 50% banana. And also when you compare genes, it's amazing how many organisms that are very different from us, that genomically are very similar to us, other organisms that the opposite is true, where their genomic are very different, but yet in many ways they're very similar to us. So we have a lot to learn about genes. Now, by the way, they're sequencing more and more animals, more and more primates, etc., and we're better able to understand the whole relationship between the genes and the organism which is produced.
Thank you, Jerry. Erica, you get the last word, so we'll throw it over to you for some thoughts.
I mean, the protein coding number has only ever gone up. The protein coding number has never gone down, at least not to my knowledge, and I'm pretty well read in this subject. Those lower numbers reported usually by creationists or Richard Buggs on his blog are talking about the entire genome nucleotide by nucleotide, so not taking into account the types of mutations, or in the case of Jeffrey Tompkins, something else entirely. But what creationists miss on this, and what I really, 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 if I could get one thing that they would all remember forever, it would be this. The number isn't what matters. It's relative to other species that matters, right? So it doesn't, I mean, chimps and humans could be 50% similar, and it wouldn't matter if lions and tigers were 40% similar to one another, right? It doesn't matter how you compare the genomes. Every way that we have tried, humans and the apes, right, are more similar to all of each other than any of them is to anything that isn't an ape, and are more similar to one another than rats are to mice. So for creationists to accept that rats and mice are related and not humans and chimps is very hypocritical in my opinion. And I think, I don't know this, and I hope this isn't true, but I suspect that that's why on the creationist side of things, they only ever look at humans and chimps. They never look at anything else. I've never seen it. They never bring a third organism in to compare.
Thank you, Erica. Erica, here's one for you. Richie Torres, MMA, $5 super chat. Thank you very much for the support. I want to know where Erica gets the uniformity in nature and the laws of logic to make these truth claims from her goo to you worldview. Erica, any thoughts on that?
I mean, I had an entire debate about this subject with Redefined Living, who I don't know if he's lurking around here. I suspect maybe this is his alt account. I don't know. But yeah, I think presuppositional apologetics are a complete waste of time. I make one less assumption than creationists do when it comes to uniformity of nature and laws of logic. When somebody asks me where do they come from, I say I don't know the answer to that question. Creationists say God is responsible for it. So I don't see an issue in admitting when you don't know the answer to something. But to say that you can't say anything about science unless you know where the uniformity of nature and the laws of logic come from is to say that you can never solve any crime for which you are not present for, right? Is to say that you can't, unless you know how and where a knife was manufactured, you can't know if somebody used it to kill somebody else, right? I mean, we do this all the time, investigate things where we don't know their entire history of origin. And when I say we do this all the time, I mean we literally do it in everything. Every single field does this. So, I don't have a problem with that any more than I have a problem with saying evolution is demonstrably true. Every single field in biology supports it, and we don't have to have abiogenesis solved to say that. For all I know, God did start life on Earth, or somebody else started life on Earth, or whatever. That doesn't change the fact that every biological system follows the pattern outlined by evolution, and not some other thing. So, that's my 2 cents on that. I think presuppositional apologetics are lazy apologetics.
Erica, I knew you would love the presup question, so we just had to get that in there for you.
I love them, Donnie.
Make your weekend. Jerry, anything you want to add to that?
Yeah, the problem we have in the creation movement is we just don't have many PhD level astronomers, PhD level paleontologists, PhD level geneticists, etc. We've had a few in the past, but they are no longer with us. So I think that unfortunately the creationist movement, for some reason, isn't attracting these people, or they are creationists when they start their graduate work, and when they graduate, they become evolutionists. So that's one problem. I think schools like Liberty University, etc., should train geneticists at the PhD level who accept the creation worldview and also can grapple with these issues. I just had a paper criticized by some fellow creationists, and they said if I had a good astronomer review it, they would have caught these errors that I had in the paper, 2 errors, by the way. And the problem is, how many creationist astronomers have PhDs? How many PhD creationist astronomers are there out there? Not many. And I think one thing we should focus on is having more people trained in science who accept the creation worldview. And we just don't have the funds, don't have the money, and don't have the support, and even most Christian, but of all the Christian colleges, there are like 12 that support the creation worldview. All the other Christian colleges support the evolutionary worldview. Why is this? Well, because that's all they pick up. That's all they learn. That's all I learned when I was in college. And that's all a lot of us are exposed to. That's all the literature, scientific literature, science and nature and so on, the journals I've subscribed to for many years, they only cover the evolutionary worldview. And when they cover the creation worldview, it's derogatory, or they're trying to come up with ways of critical of that worldview and so on. And we just don't have the numbers. We spend a lot of money on a lot of things, but we're not supportive of training future creationists that are well trained in this area who have a good background in genetics or astronomy or even biology. We had a number of PhD geneticists, but they're not with us anymore. We used to have a number of PhD astronomers, but they're not with us anymore. So they earn their heavenly reward. And so we need to train more people. Not many churches. I was in Chicago recently and at a church, and they have creation presentations once just about every month. And so when you have 12 creation presentations presented every year, and the church has about 1,000 that attend, you're going to have a good background in creation. How many churches have a creation speaker even once a year? Not very many do. And that I see as a problem that a lot of churches, they avoid it. It's controversial. Let's just avoid it. Let's stress preaching the gospel and let's avoid this debate about creation. And this church, by the way, that does have creation speakers every month, they're very well informed. They're very well educated and good students, etc. And they have a solid creation worldview, and they would be able to stand up to almost any evolutionist because they have solid background in various areas of the creation worldview. And it's a worldview, basically. It's the way you see the world.
Thank you very much, Jerry. Erica, you get the last word because the question was okay.
Nothing
Looks like
to add.
you're good. Okay, so this one here, it's a joke, but it's an innocent joke. So I think I'll allow it. Baltazar, $10 super chat. They're coming at you, Jerry. They say, how can Jerry object to the out of Africa thesis when he's clearly still in denial? Jerry, what are your thoughts on that?
Well, I don't really object to the out of Africa thesis. I'm aware of it. I'm aware of it's commonly taught, and I don't see any problem with it. And don't know why I would object to it. So that's my response.
And then from your position on origins or worldview, would you have more of an out of Middle East position at the Tower of Babel, Jerry, or how would you view that?
Well, yeah, probably more out of the Middle East, but on the other hand, the Middle East isn't all that far away from Africa, and people travel around and don't know. Could be, of course, the Christian teaching has been out of the Middle East, is where Adam and Eve and the Garden of Eden was, but no one's been able to locate specifically the Garden of Eden. Claims about where it is, but I don't think we really know. And likely in the Middle East, some area, that's where Christianity and Judaism began. So, or at least Judaism began primarily, and Christianity. So, I don't know. I know evolutionists debate, or at least in the past, the out of Africa thesis.
Okay, thank you, Jerry. Is there anything you wanted any input there, Erica?
Yeah, I hate a pun. I do hate a pun.
Yeah, the questions that came in that were attacking the debaters or were unprofessional, we're not going to put those up. We want to be respectful, but if they're more innocent ones, then that's okay. We can have some fun with it. You guys are good sports, Erica, Jerry.
I have to go to the restroom really quick, so let Jerry do this. I'll be back in a second.
Okay, I was just going to ask who's going to tap out first in terms of wrapping it up. So Erica, feel free to have a restroom break, and then we'll start to wind things down. Jerry, appreciate your time. I'm just impressed with the endurance from the both of you. That's kind of why I'm smiling, because this was more of a debate conference than a debate itself, Jerry, I think. So Jerry, here's one from Design, $5 super chat. Jerry, this might be a two-parter because I'm seeing the dots. So I might be missing the first part. Let's just see. Consistent with how you view horse fossils, how do you draw the line between similar and related? So maybe they're wondering from the creation model, what's not just due to similarity without relationship, but similarity through relationship?
Similarity refers to morphological differences, and related deals with genetic cousin, uncle relationships. So I imagine people that are related would be similar, but people or organisms that are similar would not necessarily be related. So you have animals that are very similar, but they're not related, and vice versa. So that's the distinction that I would take.
Appreciate that, Jerry. And we'll wrap it up with a nice one here. Doc Dino. Well, no, not this one, but yeah, you can have an after show. You can do an all-nighter if you'd like to. Doc Dino, what are y'all's favorite hominid and dinosaur? Two-parter, Erica.
Ooh, that's tough. Hominid. Probably my favorite hominid is probably Ardipithecus ramidus, which is incidentally also my favorite hominin. But if you'd expanded that out to like include hominoids, obviously it would be some kind of gibbon. My favorite dinosaur is, what is my favorite dinosaur? I think my favorite dinosaur is Echilibator. I like a raptor. I think they're cool. Who doesn't think they're cool?
That's true, especially the Jurassic Park style Velociraptor. I'm more of a Spinosaurus kind of guy.
Like
Jurassic Park 3, Spinosaurus versus T-Rex, Spinosaurus 1, that was good.
I like a Spinosaurus.
Jerry, what about you? Favorite hominid and dinosaur?
I really haven't thought about it that much, so actually I don't know how to answer. But favorite dinosaur? I don't know, I suppose T-Rex is,
It's a good one.
Along the favorite, but I don't know if I really have a favorite dinosaur. I have favorite animals, but not a favorite dinosaur.
What's your favorite animal, Jerry?
My favorite animal? Oh, probably a panda or a koala.
Yeah.
How it's pronounced. Duck-billed platypus.
Oh, yeah.
I have a long list of favorite animals. Of course, a dog and a cat and a horse. And I like dogs and horses and cats too. So I've been amazed at how we had a dog for 15 years and it died. And I am amazed at my response and never thought I would have a response that I did. And I haven't even felt the same way when a relative died. So it's amazing that how you miss that.
Jerry, I feel you on that. We just put down my family dog about a week ago now. And it's the worst. It is the worst thing. It's so hard. I mean, I got 3 dogs in my house now, but gosh, I grew up with my family dog Rosie. I miss her every day, even though I don't see her. So I empathize. I know how you feel.
Amen to that. That's true. You mentioned a panda. Yeah, I've seen Kung Fu Panda, so I know pandas are good at Kung Fu. That's for sure. So, okay. I picture Captain America when he says, I could do this all day. And I'm seeing that from the both of you, Erica, Jerry. We've essentially gone through all the super chat questions that came in over the first couple hours of the debate before we cut off super chats. And so this was a marathon, but a fun marathon. I really enjoyed it. I feel like this was very thought-provoking. It was engaging, that's for sure. And you guys didn't even break a sweat. You look like you're ready for another 4.5 hours. So why don't we have a quick nap, 20 minutes, and then do round 2. So, okay, that was that was a great Q&A, 2 hours. This gets us out of our echo chambers. Jerry, were you going to say something, brother?
I appreciate Erica's response because so often when I interact with evolutionists, name calling comes in, name calling. And, your degrees are fake and on and on and on. And name calling is, and she never used name calling once in the whole debate. So that really speaks very well of her character. I wonder if she has a Christian background. Don't know, but it seems like she does because a lot of it still shows through. I would have students occasionally that walk up to me and say, are you a Christian? And I would, wondering why they said that. And I would ask, well, why do you say that? And say, well, just picked up little things here and there that indicates that you had a Christian background. And you got to be careful about talking about such things in the classroom. But I say, well, since you mentioned it, I do have that background. But you can often tell, even when they leave the faith, you can often tell they have that Christian way of responding to people, and it's not nasty or not angry or not mean or not name calling doesn't show.
Jerry, that's so sweet of you to say. I really appreciate that. I really enjoyed this conversation. I had a blast. I try my best. I really, there are a lot of creationists out there that I really, really like. As people, I think they're fun to engage with, really all of the above. And there are some that I don't, but I think that's just people being people, and that is what it is. But yeah, I mean, I hope that everybody who knows of me or knows me well enough knows that, gosh, I'm never gonna name call someone in a debate or a discussion. That's not what this is about, and I think it's frankly a waste of time as well. So I please don't thank me for doing what I consider to be the bare minimum in civil discourse.
Well, you guys did a great job. Like I said, couple of good sports, couple of true professionals. I feel like we were just backstage a couple minutes ago getting set for this epic showdown on the question, do hominin fossils support human evolution? So I mean it. I think this was very thought-provoking. I know I learned a lot throughout this debate, which is why I love to host and moderate these technical debates. Always a good learning opportunity, that's for sure. And to our audience, excellent interaction, a ton of great engagement, feedback. The live chat had fun in both chats. Lots of good comments and questions. Clearly, as we just engaged questions for 2 hours, and that was fun. So, guys, let's get some final words, final thoughts. Thank you so much to the both of you, not only for doing the debate and the time you gave for the debate itself, but the time leading up to the debate, the prep, the just getting ready, and the study, of course. So I know how busy you both are. Let's get some quick final words, final thoughts. Erica, thank you so much for doing this. Hope you had as much fun as I did. And let's hand it to you. Final words, final thoughts.
Yeah, no, this was super fun. I wish I could do debates more often. I really, really enjoy them. I think they're so fun. I don't really treat them like debates. I think of them more as discussions. I spend a lot of time reading about creationism and talking about creationism over on my channel and, combating it from my perspective. But I try to understand where creationists are coming from to the best of my ability. So any opportunity that I have to engage with creationists on this topic, on this subject, is really just a guaranteed fun time for me. I really enjoy it. So thanks, Jerry, for his time. I know, gosh, it's probably super late where Jerry is. It's late where I am. So I appreciate his time. And yours as well, Donnie. And the wonderful audience as well. Oh, and to my audience, stick around for about 2 minutes, because after I'm done here, I'm going to say goodbye to you guys and thank you myself, and then we'll leave. So I'll hop over onto OBS here in a second, and maybe, I don't know, I'm so bad at OBS, you guys. I'm still learning it. I'm sorry. Sorry for my
Well, it went smoothly. So you did a good job. Your husband did a good job behind the scenes. He really helped organize those questions too. It was intimidating at first, but we did it. This was a success. So for those that want to see more from Gutsick Gibbon, Erica over at Gutsick Gibbon, here's a couple links where you can see more from Erica. So I appreciate those final words and final thoughts. And I appreciate you doing this. We need more debates of this caliber. So, okay, Jerry, Dr. Jerry Bergman, appreciate your time as well. Thank you so much for doing this.
We need debates like this in the schools and the churches. Why not have a debate like this in the schools? I know it'd be a problem because, Erica, you'd be okay. You'd be given an honorarium, but me, they would kick out. So you cannot present the information. The courts have made it very clear. You cannot present both sides. You can only present one side. You cannot debate this question. It cannot be debated. It can only be presented one side, and that's it. And so they're not going to, by and large, I would say 99.9% of the schools are not going to hear the material I presented. It's not going to be heard. The courts made it very clear that is not allowed in the schools, period. So, Erica, you can go to teach all this stuff in the schools, no problem. But unfortunately, the material I presented cannot be presented without a problem, unless somebody, complained about it. So if no one complains, then you're okay. But on the other hand, invariably you have one student. I had one student that basically complained about this very thing, and Bergman was not an enthusiastic evolutionist and did not fully believe it. It was apparent, and therefore there's a problem. And so the dean basically said, well, try harder to appear to be sincere when you cover evolution in your biology classes. And
okay, well,
that way, but that's basically what he said.
I think round 2, then we'll have to do in person. There we go. In-person showdown on the hominin fossil record or whatever topic we choose. For those who want to see more from Dr. Jerry Bergman, do check the description box of this video as well as the live chat. Okay, Erica, Jerry, appreciate you both doing this. Thank you for those final words and final thoughts. And to the audience, thank you so much for hanging out with us for a great debate on hominin fossils. I'm really glad we had a long discussion. Discussion's important rather than just the openings and rebuttals. And we really got to dig deep, I think, on some of these hominins. So very good stuff. And to the audience, thank you so much for tuning in. Appreciate all the support coming in from both channels as this was a simulcast debate. And okay, Standing for Truth is out. God bless all.
Okay, I know my guys are still here, but I gotta figure out how to get this stupid video device back on. You can see my marmosets in the background. All right. Hold on. I'm working on it. I gotta find my face. Is that it? Aha! Yes! Excellent! Hold on, let me go back over. Let me make sure I'm actually up. Whoa, the lighting sucks. I don't know why that happened all of a sudden. I thought it was good over there. Maybe it wasn't. Okay, hold on. Let me make sure that I'm actually showing up over on YouTube. Please, please, please tell me it worked. Hold on. Can I see my ugly mug? Hold on. Aha! Yes! Excellent! Okay, guys, thank you so much for hanging out for so long. Truly that was a pleasure for me. I had an absolute blast. I'm gonna give you a couple of my thoughts, and then I'm gonna go eat the rest of the dinner that I didn't get to finish because I was busy putting the finishing touches on my PowerPoint. And I'll tell you, you know, shoot, man, I might have overprepared. I spent a lot of time. I had this entire extra PowerPoint that I had like all of these metric comparisons of every bone that had a decent picture of it that I could find so that I could share it with Jerry and share it with you guys. And then Jerry was just like, yeah, no, I mean, you know, that sounds right to me. But that doesn't mean it proves evolution. I couldn't ask for a better response for for a debate that was on does the hominin fossil record support human evolution. I think we resoundingly came to the conclusion that it does. So I'm gonna check the chat over here and make sure that, please let me know if I missed any, did I miss any super chats from anybody here, or did we miss any super chats? Since my sweet beloved husband Luke was on the job, and so if it's his problem, if we missed it, it's his problem, and I'll get him later. Let me check. It doesn't look like anybody's saying that I did miss anything. Couple people are saying that they enjoyed it. Yay! Couple people are doing trans colors. Yes, trans rights, I agree. A couple people are saying that oh, super chat's lovely, thank you. No, stop super chatting. I cannot stand answer countless super chats. I'm just answering the ones that I missed. So Erica, do you think that your superiority in the debate and intellectual curb stomp of Jerry's whole argument constitutes elder abuse? I feel like Jerry was too sweet for me to answer that question with honesty right now. Ask me when I'm irritated, maybe. I don't know. When I emailed Donnie about this debate, like setting it up, one thing that I said is I was like, tell Jerry that I'm going to be going over a lot of comparative morphology. Like, I know he has a medical background, but like you brush up on that because like if I got quizzed on my gross anatomy stuff, I don't think I would do a great job on it. So, but you know, we got a very different opener from Jerry than I was expecting. I was expecting what was basically what I did release the video on yesterday, and I got none of that. So I really wanted to talk about the Laetoli footprints. I really wanted to talk about Lucy being a knuckle walker, but then Jerry was just like, nah, I'm cool with all that. Maybe evolution is right on that, but that doesn't mean that it's right in general. And so it's like, goodness. Okay. Erica, I had a $50 Homo naledi question that Standing didn't ask about the new papers. I'm glad you said something because I'm about to give you some insider information for this channel. I've talked with people and recorded video with people who were reviewers on those new papers. I have opinions on these new Homo naledi papers. I have opinions on Homo naledi in general. I have a whole gigantic backlog of video that I need to go through because for whatever reason I've become sort of like the side go-to for like internet people who talk about Homo naledi, and I think it's because I talk too much about Homo naledi. But I want to make sure that I do this justice because these new papers are making a ooh, they're making a lot of claims. Lee's been talking a lot on Twitter, and he's been talking a lot on Blue Sky. And believe it or not, these days, what you say on those platforms actually kind of does have bearing on some of the scientific communication and some of the like actual arguments that are going down in the scientific literature. So thank you. Wait, I need to make sure I recognize your name because you super chatted. Hold on. I started with a J. I'm scrolling back up to you. Don't worry. Hold on. Okay, it was J. Lubell. So thank you for your super chat, J. Lubell. What I'm going to tell you ahead of time is that for me, I'm not convinced. And here's your sort of advance notice. I think that actually I don't know if I want to say that yet. I don't know. We'll see. Just wait for the video. It's really coming out soon. It's my next project that I'm working on. It shouldn't take too long. I'm hoping for it to be the next video that releases on the channel, especially because a friend of mine, a friend of the channel, you guys probably know Flint Dibble, he does a lot of archaeology. He's doing an interview with somebody else who also has like an area of expertise that overlaps with the Hominin stuff. And he got permission from the person that he's interviewing for me to use some of that footage in my video as well. So we're going to have a big old Hominin time here soon, talking about whether or not this bizarre little hominin buried its dead, whether or not it made art in those caves, whether or not it used fire to get to the backs of those caves. And we're going to talk a lot about what responsible science communication looks like, I think. I'm excited for it, and you should be excited too. Is there anybody else that I've missed? Just making sure I don't. Oh, yep, there's somebody else I missed. Great job. I would have not. Okay, this is LG Son for $20. Thank you, LG Son. Great job. I would not have had the patience for his dishonesty. You're an amazing representative for science. You know what? That's very sweet of you to say. I really appreciate that. I struggle with this, with creationists. Maybe I'm naive, right? But like, I have a very long history of arguing with people who I perceive to be good faith, who basically everybody else doesn't think is good faith. And I do it over and over and over again, sort of like Sisyphus. And then eventually I will come to the conclusion on my own, and I'm like, that person wasn't a good faith actor. Why didn't anybody tell me? But, you know, I don't know, like, Jerry's been doing this for a long time. I really have to believe that what's actually going on isn't necessarily dishonesty, but I think there's just a lot of cognitive dissonance with a lot of these guys, with a lot of these creationist PhDs, to be perfectly honest. There are definitely some that I think are dishonest. I think Jeffrey Tompkins is dishonest. That's my opinion. And I've been very vocal about that here online. There's only so many times that you can get the same thing wrong over and over and over again. Blizzades for $8.99. Have some money. Stop giving me money, you guys. I gotta go. I'm just basking in the post. I don't know. I was gonna make a joke there, but I don't actually. That might get me demonetized. I gotta bask in the glow of that conversation. I really had a good time, and I hope you guys had a good time too. There's like 1,500 people still here. I think we topped out at like 2,100 or something like that, which is, I think that's a record for this channel. Which that's great. Like, comment, and subscribe if you haven't already and you like this kind of content. I'd love to do more debates with creationists. If you know creationists who want to debate me on human evolution, tell them to reach out, because I would like to do more of it. I make this joke a lot on the channel, but like, I swear to God, dude, the only reason I don't do it anymore is because I debated all of them. I debated them all. They stopped asking. So that's why kind of I jumped at this opportunity with Jerry. But there are many, many creationists that I would love to have a debate with who I think might be able to like engage the specifics of the material a little bit more in depth, I think. Oh my goodness, Appy Gray, $5. Erica, thank you for saying trans rights. It's nice to be encouraged. We love you. Good job, and I hope you rest well after the debate. I will. Yeah, I hope that it's like not surprising that I'm like obviously an advocate for trans rights. I'm trying to say that a lot, but you know, gosh, it's a hard time for everybody, but especially for you guys right now. So, you know, apes together strong. Josh Pratt for $2 more. Stop it. But thank you. We got $2 from, thank you, Mr. and Mrs. Gibbon, my goats. Dude, my husband's so awesome. I just want to brag on him for a little bit. I walked up to him yesterday and I was like, hey, I have a really big favor to ask. And he was like, oh God, what is it going to be? Like, he's thinking that I'm going to ask him to like help me move the rocks in the garden again, or help me move the big, like our big D&D screen back upstairs, even though we're having to move it back downstairs again the next week. But then when I told him it was moderating the debate, he was like, yeah, I'll do that. And then he was on it. That guy rocks. Whatever, don't tell him I said that. Okay, we got, let's see, $10 Canadian dollars. This is the real money now from Where is Waldo? I don't know how many times I gotta tell you guys to, you know what, I think the only answer is for me to leave. Thank you very, very much for doing that. Where is Waldo? $10 Canadian super chat. That's very kind. Balthazar 228, excuse me, for $4.99. Make the dinner cold chat. You know, it's already cold because it's in the freezer, losers. You didn't think about that, did you? Didn't think that I already had I'm already gonna have to heat it up. Didn't consider that. Okay, guys. Oh, Jesus. Okay, Bubby for $2 more monies. Enjoy your night with the Mike Wazowski, and Sully Fusion PFP. Okay, I gotta go. Guys. Okay, wait, hold on. Back in this yak, just because I've been tagged here, can you make a video on that bone by bone PowerPoint? I would love that. The reason it exists in the first place is because I've had this video of like, it's titled, it's like Hominin Evolution Precludes Creationism. And it's basically just that. I walk through every hominin, every major bone, and I explain step by step, piece by piece, with excruciating detail, why all of this debunks and in fact precludes creationism. But it's very long. I know that's shocking, but it turns out when you do a deep literature search on all of hominin evolution with a focus on transitional species, it takes a long time. So it's almost done, and I think I got a lot. This helped me prepare even more for it because I had to go find a bunch of images of like charts, lots of principal component analyses, lots of canonical varied analyses, lots of measurements. Why at for $4.99? Do you think the uncanny valley was what caused the conflict between sapiens and Neanderthals? If anything, it's Paranthropus. Why at right now? I want you to go to Google and just Google Paranthropus reconstruction or Paranthropus recreation, and you will see where the uncanny valley came from. Neanderthal fine, Paranthropus bad. They're very spooky looking. Okay, before anybody else comes back, guys, thank you so much, my gentle, of course, very modern apes, for being here. If you like this kind of thing, like I said, like, comment, and subscribe, do the usual thing. If you want to support me in the financial way, you can do that on Patreon. Patrons get early access to videos when I'm on top of things, which I haven't been in about 6 months. And I don't know when I'm going to be on top of things again because my projects are getting bigger and bigger and they're taking longer and longer. But they do get their names at the ends of every video, except for live streams, where you get nothing. So thank you for being here. I guess that's all I have to say. Last check, and I think